Hello and welcome to Django for Everybody. One of the things that I like to do at the beginning of each class is sort of say why. Why should you take this class? Why did I make this class? And in particular, why Django? There are some questions like, oh, why not Flask? And I'll get to that. So I just want to take you back in time a little bit. 3 years ago, I was a happy professor. We were teaching Python for our beginning users in our data mining, and then I thought it was really important to learn a second language. And so I taught PHP for our web dev. I like PHP. It teaches you like how the web really works. I taught SQL and I love that and taught about all the good stuff. And then we taught JavaScript, JQuery, and JSON as well. And I had been building that class literally for 5 years. I had been building the graders for it, the stuff. And one of my metrics as a teacher is how far do my students get at the end of class? And so I look at 15 weeks, and what was the last assignment? And then that to me is the way I judge whether or not I've done well or not. And over the years, I try to get the students farther and farther, and I adjust the first part of the class to be more efficient so that I can be more effective at the end. And so I can put more useful stuff, because there's so much in the beginning classes that is just like, oh, the mechanics of it. And you got to learn the mechanics, and then you can apply those mechanics, but you just can't start off and say, here, cut and paste these 4,000 lines of code. It does you no good whatsoever. So 3 years ago, I had a very well-developed PHP class, and in not too many words, I was told that they didn't want me to teach PHP for web dev anymore because everybody wanted to do Python. And a lot of people were actually doing Flask in some of the more advanced classes, like our mobile application classes. So I was told to switch to Python, sort of told to switch to Flask. I've done Ruby on Rails, I've done PHP, which is pretty raw, I've done CapePHP, which is a framework, and I've done a lot of programming with and without frameworks. And another teacher taught a class using Flask, and I didn't like how that class turned out. I looked at the end of what they were doing at the very end, and I thought, whoa, that's not very much stuff. But I started with an open mind. And so I actually had a whole year when I was teaching PHP, for 1 whole year. They let me teach it for the last year. That's also when I developed web applications for everybody. And that's also become a MOOC as well, which I love, and I think a lot of people use it. They use it. It's really a great MOOC. And I'm still convinced that learning more than one language is a good idea. So you might want to take web applications for everybody after you take Django for everybody. So I would go everywhere I would go. I would ask everyone that I would meet, do you use Flask or Django? I mean, luckily, 5 years earlier, there was like 25 choices in Python. But by 3 years ago, it really narrowed down to Flask and Django. There's other cool ones like Sanic that are specialized. But Flask and Django are kind of like the big ones that everybody, not Web2Py, there were so many of them that I'm like, oh man, which one am I going to pick? And that's the problem with PHP frameworks, is there's so many of them. Although Symfony and PHP is kind of winning. So I would ask people, Django or Flask? And people would give me very passionate responses. They would say, Django is the greatest thing ever and Flask is absolute trash. I would go on to the next person. They would say, oh, Django is trash and Flask is awesome. 50% of the time they would love one thing and hate the other one. It was amazing. I really got no trend whatsoever. And so about halfway through that, I'm like, I'm getting no data. I mean, I'm getting half the people love one thing and hate the other thing. And so I changed the question. I stopped asking whether it was Django or Flask, because they were saying, what do you like? I was really asking, what do you like better, not what should I teach? And so I said, look, I can only teach one, Django and Flask, and which would you teach first? And then which would you teach second? What order? And then universally, everybody just had to accept the fact that Django was way better, way better to teach as the first class. And so I felt I got really strong data on that. So I picked Django. I wanted to use Django, and in retrospect, it's brilliant, right? I've been working on this Django class for 2.5 years now, and each semester I make it better. Each semester I improve the slides, and I do that thing where I try to like compress the beginning and get efficiently done with the beginning part so that I can do better stuff at the end, and I'm really pleased. And so what you're seeing in this Django for Everybody's MOOC is that 2 years of careful engineering of the class. And I'm really proud. You can go to projects.dj4e.com and see some of the things that the students have built. I'm amazed at how much they can actually build on their own, and literally couldn't have done it with PHP, and couldn't have done it with Flask. Django is the only way that students would be able to produce complete functioning websites with a real user interface at the end of a 15 weeks. And so that means that to me made Django a great success. I'll close with, I just got done looking at the most recent Python programmer community survey, and I was surprised to see that the #1 use that they had of Python was web applications, and the #2 use that they had was data applications, which floored me, because I know that Python is great for data applications and it's just super dominant. Part of the reason that it worked out that way is it wasn't like web was twice as much. Python is used for so many things, and so there was a lot of things on the list, and then web just edged out data analysis by a little tiny bit. You can be critical of Python web development, and my answer is, if it's not perfect, it's going to be perfect, because people like to write in Python and they don't want to write in Rust or Elixir or Scala. Those are harder to learn, and honestly, whatever the shortcoming of Python web development, it's going to get fixed. So welcome to Django for Everybody. I really enjoyed, and I've been looking forward to the moment where this was mature enough and well enough developed to become a MOOC, and so here we are, and I'm glad to make your acquaintance. Cheers. Hello and welcome to the first course in the Django for Everybody specialization. The purpose of this course is to, in fact, make it so that the only prerequisite you need are Python skills. Like you might have taken the Python for Everybody specialization and finished that, and then you can come here. And so I don't want to put a bunch of prerequisites like HTML and CSS and SQL. And so what I've done is I've just covered all the foundational knowledge that sort of supports the rest of the specialization in this class. We're going to use Python Anywhere. In this first class, we're going to install Django. We're going to use it for some HTML, CSS, and SQL assignments. And so the idea is to get everybody on the same page when we finish this course, so that we can sort of, at that point, start digging into learning how Python and Django work together. Hello, and welcome to our lecture on dynamic web content. It may seem kind of weird to be talking about building web applications, when we start out talking about building web applications, that we're going to talk about protocols and stuff. But in a way, when you are building a web application, if you don't understand the protocol and you just sort of say, I changed this little bit of code and I hit refresh and some magic happened, you really are cheating yourself in terms of becoming a really good web application developer. Because ultimately these protocols are what enable web applications, and as you go forward and use frameworks, you don't need to know all these things in detail, but when you debug your applications, you absolutely do. And I don't know if you've had your Firefox console or looked at things and watched. There's so much complexity going on, and when you're using a web application, hopefully everything works and that complexity is hidden from you. So if you have some interest in this and want to go even lower to sort of more of the network protocols, not just the HTTP protocols, I've written a free book on networking called Introduction to Networking, How the Internet Works, that you are welcome. You can buy a print if you want, but it's also completely free, like every book that I write these days. And so if we take a look at what we're going to really be talking about in this lecture and in this web application course, is the technologies, the different technologies that are used to, in effect, produce a web page, right? So we have a web page over here. You go to URL data.pr4e.org/page1.htm, and here comes a page, and this is like a super simple page. But there are so many technologies, like how browsers work with JavaScript and JQuery and CSS and eventually Vue and things like that. That's a whole set of front-end technologies, and then there's sort of back-end technologies like Django or Flask and databases. And we're gonna learn in this My focus in this class is less about how to make it all look beautiful, although that's important, and more about how to deal with the back end. So what we're going to see is these technologies that define the look and feel and the interactivity of your web pages, but also then how data and HTML, CSS, and JavaScript are served up by the remote server. And so the internet here is in the middle. The browser is sitting on your laptop or your phone or whatever, and it has all these technologies built into it. It makes requests, and then the server comes back with responses. And so the simplest version of this protocol is that you click on a tag, and when you click on that tag, you get a new web page. Now, if you watch your debugger console, you will see that sometimes it's 120 different request response cycles used to construct the page. But in a sense, they're all the same. Now, as we move to things like HTTP2, there are ways to pull down multiple documents in a single connection, but we'll stick with the old HTTP1 way of thinking about it. In the simplest form, the browser asks for a document and then retrieves the document and then shows the document, and that is the basic request response cycle. So if you look at how this works, that browser is an application running inside your computer on your laptop or your phone. That is a piece of code. And in that, it's got a connection to the screen or the keyboard or the mouse or whatever, and it's watching for events, meaning that you're going to go and you're going to click somewhere, and then this application is going to respond to the events. So on a web page, in the simplest case, you got stuff that you can click on and stuff that you can't. And you go find your way through whatever to click on part of that web page. And that click is intercepted by the application, whether it's Chrome or Firefox or Safari, running on your piece of equipment. And then that application then opens what's called a network socket, a socket across the network to a web server, and sends a request. And that request, as we'll see in a bit, is a specially formatted request. It has a GET command, and then it has the URL that it wants to get from the web server. And then the web server does a bunch of work inside itself, maybe reading disk files and running programs, generating what it is that you want. And then it sends the response back on that same socket connection. So there's like this socket connection through which all of this stuff is viewed. And so the HTML is the kind of the basic thing that comes back. As we go further, we'll see that it's not just HTML that comes back, but other things as well that come back. And so when the browser receives that HTML, then it says, oh, I know what HTML is. I've got this header 1 tag. Here, let me change the color of this thing so you can see it a little better. Yellow is way better. Okay, so when the browser receives this page, it sort of sees it and it looks at it, and then it looks at all the HTML. And so part of this course is to understand the syntax of HTML. That itself is how to build good HTML and CSS and how to make it look beautiful. But ultimately, something in that HTML plus its CSS plus its JavaScript leads to a visual display of the page, and then that's the thing that you see. And so this is the request response cycle. So up next, we're going to talk about what these network sockets are, or the things that fundamentally underlie this request response cycle. So network sockets are like phone calls for computers, and literally in the 1960s, when they were designing the concept for network software, that is the concept that they came up with. And that is that, in a sense, we make a call, we talk on the call, and we hang the phone up. And as computers were going to share data, and some computers were going to have data, and other computers were going to want data, they thought, oh, the way to do this is not necessarily have a permanent connection to that data, because there's going to be so many computers and so many sources of data and so many computers that want to consume those data. And of course, in 1960, they had no imagination that there would be billions. They just thought there would be 10,000, and they thought that was a lot. But they came up with a protocol that basically said, when you don't have continuous permanent access to data, you actually make a phone call, you know where the data is at, you kind of say, you dial up, you grab the stuff, you get it back, and then you let the connection go. And so it means that with billions of computers, each talking to each other, the network isn't so complex. And so there's this connect, talk, disconnect. Connect, talk, disconnect. And it's the way the phone system in our world scales to all the people, and it's the way the internet scales to all the people that want to use that internet. So this is made inside of software using an abstraction or library called sockets. And sockets really are computer phone calls. You know where you're going to call. You can start the call, wait for them to answer. Once they answer, there is a two-way communication. It's kind of like a file, except that you can simultaneously read from the file and write from the file. Although it's important for the two cooperating pieces of software to know who's going to read first and who's going to write first, because it's like if, when you pick the phone up after it rings, we all know to say, hello. And that's kind of a protocol. Who talks first is a protocol. And then the person goes like, who is this? And then eventually conversations happen pretty naturally. Somebody talks, listens, someone else talks, listens, and that works. But there's complicated protocols. And you can think of this not necessarily as the browser on your laptop or phone as talking to data on the server. It actually is talking to another program. And so even when it's just retrieving a file, it's talking to an application on that server, and that application is reading the file and sending it out. And we'll see that eventually, how we have to do that when we're doing things like uploading pictures. We upload pictures and then we have to actually serve them back out. We can't just say, oh, the pictures are there, you can grab them. Because sometimes not everyone can see every picture. And so part of the software application decides, if you are allowed to see this picture, I will send it. If you're not allowed to see the picture, I will not send it. And so that's where it's a piece of software that you're talking, even if you're looking at a picture. Sometimes that software is really simple and you barely notice it. But there is software in the loop. It's not like you just go straight to data. It is really two pieces of computer software talking to each other, and we use the internet as that intermediary to allow that conversation to happen. So if you read my book about the TCP/IP, you'll learn this in super great detail, but every computer has an IP address. It is a number. There are two kinds of addresses. There's IPv4 and IPv6. IPv4 version 4 is the one that's got 4 dotted numbers, like 142.16.42.14. But within each of those, they have what's called a TCP port number. And because this whole internet thing is applications talking to applications, we need to have a good way to know which application we're talking to. And that's where TCP port numbers come in. And you can think of this as like a phone extension. So you have a phone number and then you have, extension 1436. And so TCP port numbers are like that. So we can not have a specific address for every application, but an application that has an address and a port within that address, or a phone number and an extension within that phone number. And so you can look these things up. Port 25 is used for email, server-to-server communication. In the old days, we used this thing called Telnet. We'll talk about that on port 23. And so the client is on the right-hand side, and it might be a computer where you've got a keyboard and it's you, or it might be a server that's got some mail that's being forwarded from somewhere, and they all talk and they connect to an IP address. In this case, 74.208.28.177 is the IP address of this computer, and then port 25 is the extension where one computer sends email to another computer. And each of the arrows in between them is a separate protocol. So if you're talking to an email server, you expect to talk an email protocol. And if you're talking to a login server, you have a login protocol. That's kind of the simplest one. Or a web server. Web server can be on port 80 if it's unsecure. Preferred, of course, is HTTPS, which is on port 443. If you have a mail application like, say, Thunderbird that's reading Gmail, it talks to ports 109 or 110 or a couple of other ones that are ways for a mailbox application to talk a protocol to a server-based mailbox to retrieve the new messages or delete a message or view a message or whatever. So there are these ports on servers that have protocols, and then we can build software on our clients that talk these protocols. The one we're going to be playing with the most In development mode is port 80, and in production mode, port 443 for the HTTP for, web documents, basically, and web application documents. So up next, we're going to take a quick look at the Hypertext Transfer Protocol. I always want to call it Hypertext Transport Protocol, HTTP, and that is the protocol that we talk to port 80 or port 443. Hypertext Transfer Protocol is the protocol that browsers use to talk to servers. Now, we've used it for all kinds of other things because it turns out that it's a super simple and super elegant protocol. This goes to a long time ago. This protocol was invented in 1990, which is like going on 30 years ago. Yeah, going on 30 years ago now, or more. And there were many protocols. You would have one piece of software, and there was server software and client software. You had to match them up, and then you talk to the right port with this server software. And one of the inventions of Tim Berners-Lee and Robert Caillou at CERN was that we came up with this notion of, instead of lots of pieces of software, we would have one piece of software called a web browser, and it would be multi-protocol. And so we have this thing called the URL, or Uniform Resource Locator, and we just sling these around, we just use them. But these things, this was itself an amazing innovation in 1990, because in the old days it'd be like, use this piece of software and talk to this address. So the URL captured three really important, very separate things. The first thing it did is it allowed for multiple protocols. Now, the one that you mostly have seen is HTTP or HTTPS, but that's a protocol. FTP : or mail to : might be the other ones that you've seen. And then a host, and then a document. And that host is a domain name, which is a nice symbolic way to get a server address. And that eventually resolves to an IP address like 141.206.14.22 or something. And then the document within that server, and that /page1.htm is the document in the server. And I'm just saying, before 1990, there were many protocols and we did many things. But after 1990, this one protocol, HTTP, found its way into so many awesome solutions that it's by far, other than email, the dominant protocol that we use on the internet. Like I said, it was invented at CERN by Tim Berners-Lee and Robert Caillou to retrieve documents and images. And as soon as they built it, because it was all the other protocols that came, most of the other protocols were kind of complex, because we're computer scientists and we make complex things and we love complex things, and we're very, very good at complex things. But this was, when the web was being built, Tim and Robert were not like, we're going to make the greatest thing ever. We're just going to make a simple thing. So they made a simple thing, but it turned out to be the greatest thing ever, because different engineers would be like, oh, wow, I can use that a little different way. And it was, the grounding of it was super simple. And the basic concept was, you connect to a server, you figure out where it is, you send a single command with a bit of extra data, and then you get back something, a document. It could be an image, it could be data, it could be HTML. And it was really amazing, right? And so the sockets, the underlying sockets, are the things that make the phone call. HTTP is what we do once this phone call has been established. So one of the things that made the internet so successful starting in the 1960s was a radical openness, we're all around the same campfire feeling, very friendly, respectful, that still allowed criticism. There wasn't like one super genius that designed this or one company that designed this. This was a collaboration. And the collaboration was around a set of open standards and meetings to help build these standards. And they were called RFCs. They were called Request for Comments. And there was a group that built these called the Internet Engineering Task Force, the IETF. And the Request for Comments is a fun notion. We're looking here at a September 1981 document, which is 40 years old about now. And it's called a Request for Comments. And the idea is, as engineers, we might have a design that everyone thinks is the greatest thing ever, but we should always question. No design is perfect. No design is beyond question. No design is beyond commentary. And so even when they're 40 years old and used worldwide, and dang amazing, we still say there is room for improvement. And so this talks about, I think this one's IP, and there's an IPv6. There's another one if you look for this RFC that we're looking at here, there'd be IPv6, and you'd start reading it. And it's pretty dense reading, but as an engineer, it gives you all the details to build a router or build a piece of software or build whatever. And these are 100% public documents. And the idea is that no company, because literally the companies that were around in 1960, if they had said Burroughs or Sperry owns the internet or digital equipment owns the internet, they're all out of business because they didn't make good choices, but the market was able to make good choices. And because the commons were these open standards and open specifications, new companies like Sun Microsystems and new operating systems like Linux could come in, and even Windows could come in and participate as full participants because they just read these specs and all of a sudden they're interoperating with everybody else. This is fundamental and foundational to how the internet works. And I'm not saying you're supposed to go read them, but it's just fascinating to understand that the entire technological infrastructure upon which the internet is built is free, license-free, royalty-free, and you could build a brand new gadget and you could hook it to the internet by reading these specifications. You don't have to pay a developer's license or nothing. Dang, it's cool. Sorry, I'm just a little bit too excited about that. So let's take a look at one of these in particular. Now this is probably supplanted, but we'll look at RFC 2616. They go up in numbers, and so this is HTTP, Hypertext Transfer Protocol. And if you wanted to build a web browser or a web server, you could read this document. Go ahead, read the document. And if you read down far enough, you'll say, oh, this is how you make a request. Blah, blah, blah. It's got a header, and it's got like a carriage return line feed, and then a message body, and you got to do this, and this is what it looks like. This is how it works, right? And so at some point, you're deep in this document, and you're finding out in this page right here of this document how your browser is supposed to format it. And this tells both the client and the server what the rules of the protocol are. Now, it's a lot easier for me to tell you. So you connect to the server on a socket, usually port 80 or port 443, and then the client is supposed to make the first sound. It makes first request. It sends a line with a carriage return line feed at the end that has the characters. There's other ones, but get, GET, space, a URL, space, and then a protocol. And right now I'm using this HTTP 1.0 because I can do it by hand, right? And so you ask for a document, and then you can optionally send some header information, things like what language this person at this browser prefers, you know, what are the capabilities of this browser, what version browser we have. So there's a series of things. You say, give me this document, and here's something about the browser that's requesting the document, including information like cookies that are being said. Now, so this, in case you want to know who is doing this request because you've logged somebody in and set a cookie to indicate that they're logged in, that's all sent on this GET request. But we'll not send the headers. There's actually incoming headers and then outgoing headers. We'll see these when we start looking at you know, Firefox's debugging console. And so this is an entire interaction that you can do on your laptop. Now, I'm not going to do it for you, but I would note that the program Telnet that this uses has been removed from most computers. It makes me sad. They think of it as a security hole because it doesn't use encrypted connections. Like port 80 is not an encrypted connection. But ultimately, you can install, go search on your favorite search engine and find out how to install Telnet. But if you get in a command line, whether it's a Windows command line or a Mac command line or a Linux command line, and you get Telnet properly installed, you can type the following command: telnet datapr4e.org 80, and then hit enter. And at that point, so Telnet originally was used to log into computers, but if the server we're talking to and the protocol that we're talking to is simple enough, and in this case HTTP1 is simple enough for us to be able to do this, we're actually talking to the server, because remember I said that these are applications. They're not, your browser is not talking to files. Your browser is talking to an application on a server, and the server might give you back a file. So it's really talking to a piece of software, and we'll see this in more detail in the next section. And so what will happen is, because the HTTP protocol requires that the client speak first, we have to type. Now, if you can get this working and type wrong things, and type a couple enters, new lines, you will see that you're talking to a piece of software, and it will say, "You have violated my protocol." You're not talking to a thing that has any online help or user interface or anything like that. You're talking to a server, and your job is to request some data using the proper format because you read the specifications about the proper format, right? So in this particular one, it's easier to cut and paste this, because some of these servers, if you don't type fast enough, they'll be like, "You're not a software, you're a human, quit playing with me." Like you talk to Facebook or something, and you can talk to Facebook and see what happens on port 80. And it will time you out really fast. So it's good to have a cut and paste buffer. So you paste this get command in. And the other thing that's important is you got to put an extra blank line. And this extra blank line is to indicate that you're not going to send any of those headers. If we were going to send things like what language we would prefer, or what formats we would prefer as a browser, the browser has certain languages and other configurations and login information, and that can get sent up to the web server along with the request for the document. And we would be able to type them in here. But we're not going to do that in this very simple. We're just going to say enter, which means no more headers. If you were putting in headers, you type header, 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 and then enter on a blank line, and then the server would know that our request was finished. But we can just ask for a page, and then what the server does is it sends us back two pieces of information. First, it sends us headers. The first header is HTTP 1.1 200 OK. That's actually a status line. Now, you'd have to go read the documentation on what that works. But for example, 200 means that you got a document. Another one that you might have seen is 404. It might say 404 not found. So if you go to a web page and it doesn't exist, something will say 404 in your browser, usually, unless it says, "Here's a search box, go find it." But there's a status, and so the thing that you're typing, page1.htm, may or may not be on this server. If it is, then you'll get a 200 OK and the data, or you'll get a 404 not found. And then we get some response data, some header response, and this header response looks pretty much like the same format of the data we would have sent into the browser if we were sending things like that in there. Here it's what the date is, what the server we're using, last modified, and one of the important things is what kind of content are you about to see. Content type in this case is text/HTML, which means the thing coming next. And then there's a blank line, and the blank line is our indication as we're reading this data that we've finished the header, which is really metadata about the page we're retrieving, and the actual page itself. And so the rest of this page is the actual data, and we know the format of it because we were told before the page starts. This could be image/PNG. This could be XML, application/XML. Then it could be JSON. It could be like anything. And then the browser is supposed to, and if this was an image, it would be like garble, 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 right? It would be all garbled stuff that we can't really see, but the browser knows what a PNG or JPEG looks like, and it shows it to you. And it basically uses this text/HTML to tell you what's going on. And so then your browser has read all this information. It has both the metadata and the data about the retrieved page, and then its job is to sort of produce a pretty rendered version of the page and show it to you. And that is the request response cycle. Again, you don't have to do this. You can just sort of believe that it's done here. But if you want to install Telnet on your system, it's not a bad thing to install Telnet. It's kind of a classic, fun thing. It's far less useful than it was in the early days because we used to use Telnet to test everything. Now we've got like browser developer consoles that are way easier than Telnet. But it's kind of a cool thing. Feel free to do this, and you'll be like, I know what's really going on. And so I'm a big fan of using the console, of using the terminal, of using text-based interfaces. I think they're actually way more accessible. I think it's awesome. And in a way, all these fancy graphical user interfaces distract us from the simplicity of what's going on inside of computers, because you think, well, where's the button? And the answer is, oh, there's probably some command inside this computer that does what the button does. So I have a former student of mine who actually wrote the scene in, I think, maybe it was Matrix 2. I think this was Matrix 2. Yeah, Matrix Reloaded. And this scene where Trinity is breaking into the power grid and she is using the console. And it turned out that the way this scene was written is it was written exactly as a hacker, whether that's a hacker with bad intent or good intent, because there are hackers with good intent who are trying to break into your system so they can tell you, you pay them to break into your system so that they can tell you your vulnerabilities. But you can take a look at the analysis of this little scene, and just this sort of is just one of the cool things about me teaching people about how to use the command line, and increasingly me teaching people about how to use Linux. I really think that it's okay to know your Mac and Windows command line, but really increasingly the world in the server world, and we're starting to work on web servers in this class, and you might as well start learning some Linux because that's an important skill. Just writing some Java code or Ruby code or Django code, that's a skill, but knowing how to start the server, debug your application, find log files, etc. in the command line is really important in real production systems, because we're going to play in some simplified environments to make it a little easier, but those simplified environments go away once you go into real production in a real job. And so I'm really into teaching you Linux, command line, etc., etc. So up next, we're going to show you in Python, in effect, as few lines as I can possibly show you, how a browser works, how a browser sends the HTTP protocol, how a server reacts to the HTTP protocol and returns documents. So that's what's coming up next. So now we're going to build a very simple browser and server in Python. Okay, so import a library, import socket, and that, just like, import math or import whatever, that pulls in a library into Python. Sockets are built into Python. It's very cool, and it's very, very simple. So sockets kind of function like files, but they're files that we can send data to and receive data to. But when you're using a file in Python, you've got to first open it. And so the opening of a file, of a socket, is really a two-step process. First, you create the socket, and that socket sort of lives in your computer as an endpoint that's not yet finished. It's the endpoint that you're going to send and receive data to inside your computer. But then we have to actually make the phone call. So socket.socket, and don't worry too much about this syntax, we don't change it. Socket.socket basically says make a phone. That's what we're making. And then mysock.connect, that second line, is dial the phone. And we're dialing the phone to a domain name, data.pr4e.org, and a port in that domain name. So that is the call. Now, if we made a mistake, right, if we were dialing and not talking to the right server, or that server didn't exist, this connect would blow up, meaning we'd make a phone call, a data phone call to a server that doesn't exist. That line is what's going to blow up. But as you continue down to the next line, if it gets that far, now you put try and excepts around this if there was, but I want to keep this really short, so I'm not putting in all the stuff, all the error checking. So connect might blow up. Socket.socket won't blow up because it's like, unless you don't have networking at all in your computer, but it's unlikely these days. But mysock connect is like dial the phone, dial the data phone to this endpoint, and it includes the port 80 that we talked about before. And now we need to send a command. And in this command, it's exactly what we talked about before. It's exactly what we sent via Telnet. It's a get, followed by a space, followed by our URL, followed by a space, followed by a protocol HTTP/1.0, and then we hit the enter. Now it turns out in network world, you actually hit two things. It's the /r/n is a return and a new line. And you have to hit it twice, the enter at the beginning of the first line, and then remember we had to put that blank line in because to say no headers. Now we would put in between here, we put all our headers in there if we were going to do that, but we're not going to do that. And then you have to use encode, and encode means that the data sent across the internet is generally sent in what's called UTF-8. Inside of Python, the data is in Unicode, so that you can put literally any character in a Python string, and then preparing it to send it out across the internet, we kind of encode it into the more dense more compressed UTF-8 format, rather than, we don't send strings across the internet in Unicode in general. I mean, it's very rare, but you'd have to control both ends. We want to send them in UTF-8, and so the string get blah blah blah, that's in the Unicode string in Python, and .encode says convert this into a UTF-8 string, and so command cmd is a variable that has a UTF-8 string in it. And then we say send. Now remember, I said that you can simultaneously send and receive on these sockets, but the protocol tells us whether the first thing we're supposed to do is listen or talk. And we're the browser in this case, and so we're supposed to talk first. So we send the request out, and that's just like you typed it in Telnet, because in effect you're scripting Telnet. Telnet, we liked Telnet in the old days because it was kind of like a socket. I could connect to any host, any port, and type things and see if it's broken or not. And then the protocol says once the server has received the first line, any headers, and then the blank line, then it's to return it. So then the next part of this is we're going to have a little loop. So the protocol tells us we are supposed to receive data until the socket's closed. And at the bottom of that telnet, you saw that it sent a bunch of lines, like 4, I think, and then it closed it. That's what's going on here. We are retrieving data, and then this receive, this actually waits. If the server is coming slow or the network is slow, this piece of Python will be sit. Oh, got a little bit, up to 512 characters. It will wait until it's gotten 512, or it's done and it's got 100 or so. But the receive is a blocking, waiting operation in Python. It says, give me up to the next 512 characters. Now, usually the network's so fast that the Python doesn't even wait because the operating system already has it. But we get it, and if we get no data whatsoever, that is our indication that the network connection, the socket, has been hung up on, closed by the remote server, and away you go. So that's why we are going to break if the length of the data is less than 1. And if not, we're going to simply print out the data, but we're decoding it. And that's because the data that comes in is in UTF-8, but the print statement wants to print Unicode. And so decode says, here's a variable that has UTF-8 in it, convert it to Unicode for printing inside of Python. So because this data is externalized to us, we encode it before we send it, and we decode it when we receive it before we use it, because Python inside itself doesn't use UTF-8. Python inside itself uses Unicode, which is awesome and a whole separate conversation. I'm just kind of bringing that up to remind you how important it is, because we're not going to write much of this in Python, really, and all this stuff is taken care of for us in web servers when we get to that point. But it's just a good time to review Python's strings and Unicode and encode and decode, because it's really important. So if you run this and you've got it right, it runs pretty simply. Let's get the color back. Get back to yellow here. So if you run it in your system, Python socket1.py, all the work is done up here before you see your first output, and then all this output that you see is just this loop running. And what you see is really the exact headers that are coming from this server, and then you see a blank line, and then you see the actual page that's coming out. And you don't see it, but at the end here, the connection gets closed, and you break out, and you're done. And then we close our end of the socket. The far end was already closed. That's how we know to stop reading data. And then we hang ourselves up so that our local system does not end up with a bunch of half hung up phone calls. And so that's basically how we talk to a socket in Python. Now, that was literally 10 years ago how I would debug applications. I would like telnet or write a little thing like that and dump all the headers. And that got really tiring, really boring, really tiring. And so browser developer mode is going to be your friend. In a way, browser developer mode, and I'm going to have a separate video on this, browser developer mode lets you look at the sent headers, the received headers, the received data, the sent data, what URL it went to, and it's super awesome, especially because a lot of web pages have like 40 to 150 request response cycles. So you don't want to debug them all by hand. You just let the browser do its thing and say, what was that second one and what went wrong in the second one? I spend a lot of time when I'm debugging web applications using the developer mode, and that's why I have a special little video that gets you familiar with it. And I tell you, by the time you've done web stuff for a little while, you're going to know your browser developer mode. So next we're going to talk about writing code in the server to respond to these requests. So we build a browser in Python. It's time to build a web server in Python. So remember that what we've got here is we've got, the browser is an application, and we've made this a Python application now that sends this GET request. So we have effectively, like I said, built the world's simplest browser, and that sends a GET request. The server does something, and then it sends the response back. And now we're going to kind of change this, right? We're going to assume the browser exists, and it's like, okay, because we're going to be the server folks, right? So now we're going to look in greater detail at what goes on in the server. And so here is a very, very simple web server. It's a few more lines than the simplest web browser, because we have to put a little bit of error checking in with some tries and accepts. Okay, so let's walk through what this code does. Okay, let me change the color again to black. If you're from Microsoft and you can tell them to make a key to change the color on the scribbler, I'd greatly appreciate it. Oh, and then I went down a page too. Okay, so we're going to pull in some more stuff from the socket. We're going to pull in some stuff from the socket right here, and so we're going to make a function called create server that we're going to call right down here, and it's going to print out how you're supposed to access it and then start the server. Now the whole idea of the server is the server is woke up to wait for incoming connections. So the server already exists. So when you start talking to a web server, that server's in that computer already. The server software is already running, registering its interest in incoming requests. So that's what we do. So when this Python program starts, it's going to sit there and wait in an infinite loop for incoming requests. So the first thing we do is we're going to make a socket. This looks very much like the time we made. It's an endpoint. It's not actually making the phone call. Remember I said this socket call is making the phone. So we're saying we're going to make a phone, and it's up to us later to decide if we're going to make a phone call or receive phone calls. And then this next thing is like the connect, except this is I am willing on port 90 to receive the phone calls. Now it turns out there's only one program on port 90 that can receive phone calls. So this might blow up. You might try to do this, port 9000. And if you run this twice, and you can do it in 2 windows on your computer, the second one will blow up and say, you can't have port 9000 because another piece of software has it. But as long as there's only one running, away you go. And that's part of this whole try except thing, because if you run this twice, it's going to blow up the second time, because you cannot receive phone calls on this server on port 9000 with 2 applications. One application gets the phone calls. That's what socket listen says. The 5 on there says, dear operating system, if I'm busy handling 1 phone call, you can hold on to 4 more and queue them, and then I'll come back and get them for you. And that you're asking the operating system to queue incoming calls. Don't just say you're busy, shut down. If you didn't say this, listen 5, if you were busy writing the data for phone call 1 and phone call 2 came in and you weren't ready for it right that instant, it would just deny the phone call. So that's what listen says is, dear operating system, hold those temporarily, I'll get back to you, which is how it works. And then what happens is we go into this accept. Now this accept is, I'm at the phone, I've registered what my number is and what my extension is, and I'm ready to pick the phone up. Let me know. So this accept is blocking. It stops, and it just sits there, and it can sit there forever. It just literally forever. If nobody calls it, nothing happens. The next line never runs until you blow it up or the server goes down. So that's except is a blocking. And the reason we do this except, well, we have to establish the phone call first, right? So then this next line runs only when a phone call is received. So that means that we, on the browser side, we already connected, we made the phone call. Now we haven't sent any data yet, right? And so this is just now, at this point, somewhere out there, there's a piece of client software that has done a socket.connect, and we have done accept, and our accept has succeeded in the server, the connect has succeeded, and we are ready to talk. So the phone call has been made. Now the question is, who's going to say hello? And this is where the HTTP protocol solves our problem. The server knows that the client must speak first. So it just does a receive. Now you'll notice the receive and the send are the same function calls because it's a two-way thing. Whatever the browser is sending, the server is receiving, and whatever the server sends, the browser receives. And they can do it simultaneously if they can figure it out. But usually you kind of like say, it's your turn to listen and my turn to send, and then I'll listen. And usually they kind of go back and forth. In this, there's only one step. The server listens, gets the GET request, sends the data back. And so then we're going to read some data, and we're going to get 5,000 characters. We're going to get the whole thing. Remember, it's one line. It has a GET request in it. It has the optional parameters in it. And so we're going to split it. Now again, we've received it as UTF-8. We've got to decode it for UTF-16. I mean, not UTF-16, Unicode inside of Python. And then we split it based on new lines because the GET request is on one line, then header, 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 and then the blank line to tell us that we're into the headers. And we're only going to take, in this, we're just going to look at that first line. We're not going to do anything with it. Most servers actually look at the line to figure out what document to send. It's a very simple server. It sends the same document no matter what the URL is. All we do with the URL is we print it out to prove that we got it. And then we construct a response. And in this response, again, go back to RFC 2616 and it will tell you what this response is supposed to look like. It sends back a 200 OK. Remember, this is all the stuff we saw. Probably I cut and pasted it from a working thing. We tell it that we're sending it back in content type text HTML, the character set UTF-8. Remember I was telling you that. A blank line, and then some HTML. HTML body, hello world body. And I'm throwing in these /r/n's, which is the network's version of new lines. And then you will notice that I encode it before I send it because it's Unicode inside of Python, and it needs to be sent as UTF-8 because the phone, when you're in a socket, the thing that's going across the socket almost always is supposed to be UTF-8. So we encode it. And then because the protocol says so, as soon as we send the data, we close the connection. Now remember that the client had to close the connection too. So we close it, it's half closed, and then the client gets all of its data, gets the indication that it closed, knows it's finished all the data, and then the client shuts its side down. And so there are two hang-ups. It's kind of like a phone call. The person hangs up, and then click, you hang up. Now, you can't really keep talking, but you do want to have both sides hang up, and that shutdown is what's going on. And then the rest of this is all try except for various things. So we clean up our socket so we don't have to restart our server when our software blows up, and so the rest of it's pretty simple. And then, so this while one, the first browser will talk, and then it'll send some data, and then it'll go back and wait for the next phone call. And that's what's going on. The next phone call comes in, it sees a GET request, it sends the data back, then goes and waits for another phone call. So this is an infinite loop that sits and waits for incoming phone calls, and it answers the same thing. So it's like you call this phone number, and it goes, and you go, I would like a pizza. And it says, hello world, and then click, and then you call it up and say, I would like a car. And it says, hello world, click. And then you say, I would like to register for this class. And it says, hello world, click. So this is not a very flexible server. You will build far more flexible servers. But it's the one I could build and fit on a single page in a slide deck. So to run this, if you, you download this code, and it's a tiny bit of code, and you run it. So you go somewhere, maybe your laptop, maybe Python Anywhere. I don't know if it works on Python. It probably doesn't work on Python Anywhere because you can't actually talk to ports. But let's just run this on your laptop, and you start the server up somewhere, get a hold of my sample code, or download it from here, server.py, and it's telling you this is just output from the server. And this is the moment at which it's waiting, right? It's waiting. The server could wait for hours at this point. But I just give you this in a print statement so you can copy that and put it into your browser. So you paste localhost 9000 into your browser, and then the server is printing that it got a GET request for the / document from this browser. That's what the browser send. I mean, we're talking from Firefox browser to the little web server that we just built. Now there's a second GET request that you don't even know because you didn't ask for it, and that's because the browser is built in to ask for a URL called favicon.ico so that it can make an icon, and that icon ends up in the tab or wherever in your browser. And so that's like an icon for the website. So you didn't ask the browser to do this, but it's a thing browsers do. And you'll see when you're looking at your debug logs, when you're building stuff, that it's a favicon. And so this happens like blink, blink, and now it's waiting again, right? And you could hit refresh, or you could go start a different browser, and you would see these GET requests. Every GET request you're going to see in your browser and your server. So it's working, and it works really well, and you're welcome to go ahead and play with it and try it all out. So now what we're going to do is build a simple web client, and that'll talk to our server. So the other web client we made, talk to data.pr4e.org. This one is going to talk to yourself. So it's this. It almost looks identical, right? We're going to make a phone. We're making a phone. We're going to connect to localhost 127.0.0.1 is the IPv4 connection, what's called loopback, right to the same host. We're talking to port 9000 because that's where we've got our web server running, that little web server we just wrote. And then we're going to send a GET request, a valid GET request to this thing, HTTP10, and then 2 new lines, and we're going to encode it into UTF-8 before we send it. Then we send it, and then we just have a loop that prints it all out, and then when the socket gets closed, we hit a break, and then we close our end of the socket. So the server clicks the phone, and then we're done with our data, but we've already printed it out, and then we hang up the phone on our end to kind of clean everything up all the way in between everything else. So this is a very simple web client. And so now you can run the web server, right, just like we did before. And instead of talking in a browser, we run this client. And this client gets a header of HTTP1 OK, its content type HTML, it gets a new line, and then the body, and we're done. Now, I mean, it's not a browser, but it is a client that's talking HTTP. And so now you'll notice that this server sort of sits and waits for incoming calls. You could run this over and over on the client, run the client over and over again, right? And then you would see more requests. But in general, the server is destined to just sit and wait for hours potentially until a client connects to it. And then at some point, you'll just abort this server. And then if you Control-C or blow this up somehow, this will fail. The client will fail, and it will fail. It will fail in this connect code. So if you want to play with it, try to run this client without running the server, and you'll see that the connect, which is the part of actually making the phone call, this will continue to work, which is make me a phone on my current computer, and then connect is make a call to the remote computer. That will blow up. And then if you wanted to play with this, you could put some try and excepts around it. Say, remote computer is not responding on port 9000. That's if you blew up. You could put a try and except around that. But I'm not doing it because it don't fit on my slides. So here is an even simpler web client that we can use. And again, you can get this code from my sample code. We don't talk to this. There's a higher level thing that so the previous client talked to sockets, so I could show you the low level. But because we spend so much time talking about to URLs, we then have a URL lib. So I'm just going to use URL lib. And this could be a local host, or it could be whatever. I'm just going to make a 4-line URL lib call. And so I just do a URL open of that same URL. Now we're operating at the HTTP level because URL, the concept of URL is not a socket concept. The concept of URL is HTTP concept. And we just get, in effect, what looks like a file handle to us, and we loop through it and print it all out. So we run our server, and the server sort of says this and waits. And then when we run our client, it basically hits our server, and we can see in the server window. You got to do these two things in two windows, right? You got to do these things in two separate windows. So in the server window, it'll sit and wait, and then in the client window, when it runs, you'll see the client will make the request to the server, or blow up if the server's not running. And the server will see the GET request, and then the data will come back to the client. So you sort of do this in two things, and you can run the client over and over and over again, and you'll see every time you run the client, the server sees it, responds, and away you go. And again, our server always says hello world no matter what, which is delightful and classic. It's a classic. So you actually can watch when you're running Django. There will be a way for you to see when you're running Django locally and you start the server up. This managed we'll do this later, managed pi.run server, and then you talk to it and you will see all the GET requests. And so Django, when you run it locally, you can debug a lot of what's going on. So you can see like the favicon that it's asking for, and that is 5 or 6 HTTP requests to produce that little Django web page. And so that will be something that you will learn how to do. And so that sums up what we're doing in this. At the beginning, you look at it very simply. Pretty soon, you'll just be looking at the developer console, and it'll all make sense to you. I want you to be able to know that you can dig as deep as you want to and understand all of these protocols that are going back and forth. Okay? Cheers. Hello, and welcome to another walkthrough for Django for Everybody. In this walkthrough, we're going to talk about the browser debugger console. And so this is something that in the old days was only in Firefox, but eventually everybody built it in, and you used to have to build a plugin. And it shows up at different places. And so in Firefox, it's here under Tools. It turns out that you can kind of go to any of these things because these are they're just different tabs here. In Chrome, we do View, Developer, JavaScript Console, and then you see a similar kind of thing here, right? So I'm going to do it in Firefox here. And so you can see things like you can see the document object model, you can see the JavaScript console. This little error hardly matters. It's because it's such a simple page. You can actually debug JavaScript code. You can watch the network. You can play with CSS, etc., etc., etc. Performance cookies are in here. So there's a lot of things that you can do. I'm going to start and show you right now. We're at the very beginning of class. I'm just going to show you some of the most basic things here. I'm going to clear this out and then refresh the page. And so what you see here is you see each request response cycle, right? And so I came up here as if I type this. Let me clear it again so you see it. I'm going to type this. I'm going to press enter. And that tells the browser to go retrieve this page. So it connects to the server, www.drchuck.com, and gets the document page1.htm. This favicon.ico, that's basically getting this little favicon right here. That's the little thing that shows up in the tab bar. And so websites can have a file, and later we will actually make a favicon. But what I want to show you from a request response cycle is you can see some detail here. So let's go up here, and you can see detail. You can see that this was the URL. We sent a request, a GET request. We got back a status code. The status is the first thing. 200 isn't okay. 404 is not found. And we used HTTP version 1.1. The request headers, they always show you the request headers, response headers first. So these request headers are actually part of the HTTP protocol where we are telling things like what my preferred language is. what kind of documents we can handle, you know, and cookies that we're sending back in. We'll learn more about all of this stuff. And so this is actually when the browser makes the connection to port 80, sends the GET request to the URL it's interested in, get http www.drchuck.com/page1.html space http 1.1. And then after it sends these, and this is pretty much the format, except colon, blah, blah, blah. And so that is and then it sends an empty line, and then it's done. And then the browser sends back first a set of headers. You know, what the content type is very important. The size is sometimes in here. gzip means that it compressed it on the way. And so these are the response headers. And so if I go to an error page, not a page.htm, so now I'm going to clear this. And what's happening here is it's putting up a page from my hosting system. But the most important one here is this, and that is the 404 error. And so it was going and it sent a GET request to http://drchuck.com, not a page.htm, and it got back a 404 not found. So that was that 404 not found is a different status code that said this is a thing that's not there. 500 means the server had an error, and we'll talk about all these codes. But the point is you can debug all this stuff quite nicely. So let me go back to page1.htm. So let's clear this and refresh it to make sure we got it all right. Okay, so we grab the page. And now I can, another thing that you probably by now have figured out to be able to do is inspect element. So now you're actually looking at this document object model, right? And so this document object model is not necessarily the code that came back from the server. If I go here to network and I click on get and I look at the response, this is the response down here. This is what actually came back from the server. And then the browser parses this and turns it into what's called the document object model. So this is the source. Now, just as for fun here, you'll notice that I can change the document object model here, right? If you are cool, you can switch to the second page. So you'll notice the document object model changed, and what I saw up here changed as well. And so this is like inspect element. I can do something like, I can even add here, I can add some CSS, style equals color :red semicolon. And if all goes well, there you go. You see I switched the color. This is the document object model. Now the server was completely uninvolved in that. And later we're going to write a lot of code to mess with the document object model. So the server is still, it doesn't have the red in here, it didn't change this to cool. So this is what we originally got from the server, and this is what we've got in the browser. And so once that page comes from the server, you or JavaScript can mess with that page. So it's pretty dang cool. Okay, so now I'm going to clear it, and I'm just going to click on the second page, which is an anchor. Let's inspect it. Well, it's an anchor tag, and so it's going to do another GET request. And so this time it went and grabbed page 2, and there's the second page. And you can go back to the first page. And so there's a lot of things that you can see. This persist logs is an important feature. That means that it keeps them crossed more than one request. And disable cache means that sometimes the browser wants to keep a copy of something, and you, while you're debugging, you want to say, hey, go get the original every time. And so this, right now I'm starting you on very simple pages, but if you take a more complex page, and I can never remember where it is, view, developer, network, let's go here. If you take a more complex page with a bunch of things in it, and you hit refresh on this page, you will see that it does a GET request, but then as it parses that GET request, it finds things like all kinds of stuff, right? So here this took 44 request response cycles, 1.6 megabytes, and it took almost 1 second to download all that stuff, right? It took a second to download it. And so if you scroll all the way up to the top, the original GET request was to this URL, which is /lessons/rrc, which is the URL. But then if you were to look at the response, And I don't want to see that. I want to see the actual HTML. So if you look at the response, you see all these URLs for more stuff, some CSS or from JavaScript, some who knows what. And so then what you see is you see it then retrieving all these other things that it needs to actually construct the page. Some CSS, grabbed a font, it grabbed jQuery, it grabbed time ago. That's a little thing like, and then grabbed a bunch of JavaScript and fonts and this, and then the translate. So you see this little translate thing? It's doing that. And so you'll see that's how it quickly builds up to about 44 request response cycles to produce a page. Now, so that's just my quick introduction to this. You may not see these little drop downs like this. You might have to turn them on in preferences. So you go into preferences somewhere. I turned them on a long time ago. I probably couldn't even find it, but you might see it. The other thing that I would suggest is don't use Safari, because Safari's trying to hide too much stuff. Like it doesn't even show you the URL unless you click on it. So Safari's kind of a pain in the neck. And so I would suggest that for this class, you either use Firefox or you use Chrome in addition to using Safari. Safari is fine for daily use, but I just find it as a debugger, it's bad, which is really sad for Safari. They made Safari unfriendly to software developers, which means we're not going to test our stuff on Safari, which means if it breaks, too bad. Okay, well, enough of that little Safari diatribe. Again, I hope that you found this walkthrough for Django for Everybody, as usual, helpful. Cheers.
I'm Guido van Rossum. I created the Python language. I've worked on Python for 25 years, and I've worked with a large group of others, of course, in the Python community. I'm very excited to see you all in this class, and I'm very proud that you're using my language to learn. Python is just the first step you are setting on the path to programming. There are many exciting things to learn in programming, many that you can learn using Python, many that you can learn using other things, and you won't be alone. There will be millions of people who have gone before you or who are learning Python at the same time as you, and you can help each other and you can learn together.
Chuck here. It is 2019 and we've been to Bletchley Park. It seems every odd-numbered year about spring, although it's really beautiful. The trees are blooming. But once again, we're at Bletchley Park, and so I'd like you to meet some of your fellow students. So here we go. Hello there.
Hi, my name is Cătălin. I'm coming from Romania. I took the history class, and I use the Python for everybody to teach other fellow colleagues how to code in Python.
So how many students have you taught to teach Python in Romania?
Over 100, and I will send you some cool pictures with them.
I'll put some pictures in this video, okay? So you send me the pictures,
Yes.
and I'll put some of the pictures of you teaching Python in the video.
Thank you very much.
Thank you.
Hello everybody, my name is Karina Sevillano. I'm originally from Peru but live in London. So I am a supply chain professional who is looking to use Python and other tools in order to solve the supply chain problems. So very interested, and thank you. I am in the Python for Everybody specialization. I have just finished the first course, so very looking forward to continue with the second and the next ones.
Thanks.
Thank you.
Hello, I'm Maria and I'm originally from Russia. I now live in London. I finished the Python for Informatics course in 2015, and since then I wanted to meet Dr.chuck, but
Well, here you
never
are.
managed to do
Yeah.
this. And I must say that the specialization ended me indirectly up in Google. So now I
You work for Google?
in London, yes.
Oh wow, congratulations.
Thank you.
Yeah.
Hi, I'm Torben from Copenhagen, Denmark. I took the internet course and used some of the material from the surroundings to make papers on how to see how technology, human and innovation can interact.
And you actually traveled from Copenhagen
Yeah,
down here
I flew in yesterday.
for this.
For this, yeah.
That's impressive.
Thank you.
Hi, I'm Olivia, and I live pretty close to here.
You didn't fly in?
No, just drove in. Yeah. I do the Python for Everybody course. I'm almost finished, and I'm a marine biologist and using Python to study sponge genomes. That's the plan. Yeah. So and hopefully I'm gonna get a PhD with this course on my CV. That's the plan.
Yeah, that's really cool. I mean, like, Python can be used for anything, right?
Yeah,
Sponges.
Yeah, sponges.
Exactly.
Yeah, hi, my name is Amani. I'm from Brighton. I took Internet History course and Python for Everybody. I'm a PhD candidate at the University of Sussex.
What's your topic?
Cloud computing and vehicular networks.
And vehicular networks.
Yeah.
You know, I have a theory. My theory is that if we just put Wi-Fi in all the cars and they would broadcast their locations
Yeah,
to
well,
each other.
this is what we're working on. Yeah.
Right,
Connected cars and...
Yeah, if the cars just would know where the other cars are at, it would kind of be helpful.
Yeah, you're right, of course.
That's cool.
So, we're gonna do it.
That's
Why
cool.
not? Yeah.
Hello, I'm Yanis. I'm originally from Greece, but I'm living in London. I'm in computer science, but I really enjoyed that course, and I'm suggesting it here and there to friends not related to IT, and that's why I'm here for.
Cool.
Thank you very much for inviting us.
Hi, I'm Arian. I'm originally from Greece. I live in London. It's a hobby. Programming is a hobby for me, and I really very much enjoyed the course.
Well, welcome.
Last year. Thank you very
Hi,
much.
I'm Martin from London. I'm a gentleman of leisure, but I decided to take the Python for Everybody course just to keep my brain from going to pulp. I'm very pleased I managed to just get there.
Well, we'll keep making more specializations so that your brain will never turn into pulp.
Hi, I'm Steve. I'm one of your TAs for Python in the capstone and the Web Applications for Everybody course.
Yeah, so this is the third time that Stephen and I have met in Bletchley. But a week ago,
We were in Michigan.
We were in Michigan.
Yeah.
I brought Stephen in for the 5th anniversary celebration that we had on campus in Ann Arbor. So, let's everybody give a big round of applause for Stephen and all the work that he does. Yeah. Okay, so I believe my next trip, well, 2 things. First, I'm going straight from London to go car racing, and I'm going to invite everybody to visit me at the car track in Illinois, but you probably won't make it to the car racing track in Illinois. But South Africa is the next place that I'll probably end up meeting students. So hopefully I'll see you in South Africa. Cheers.
When you walk into the back entrance of Bolter Hall on the UCLA campus, you may notice a seemingly random pattern of floor tiles in the entrance. If you spend a little time looking at the pattern, it might dawn on you that the tiles represent 0s and 1s, and then you might even figure out that the tiles represent ASCII characters. The characters in the floor tiles spell out Lo and Behold, to commemorate the building where L and O were the first 2 packets ever sent on the ARPANET from UCLA to Stanford Research Institute on October 29, 1969.
Arbor wanted a network so that they could share the large computing resources they had given to their researchers across the country. University of Utah had a terrific graphics operating system. SRI had database, we had simulation. University of Illinois had high performance computing. And every time Arbor brought on a new researcher, they'd offer to buy him a computer, fine, but the researcher would say, I want the same capability all those other guys have. I want the graphics, the database, and all the rest. And Arbor said, we can't afford that. If you want to do graphics, You log on to the machine at Utah through a network that we think we're going to make. So the need for the network was to do resource sharing and not to protect the United States against a nuclear holocaust. When Bob Taylor came in as the NEC director, and he recognized his need for sharing resources. By the way, notice the phrase I'm using. Sharing resources is exactly what I built into the network design. Now they wanted to share the external resources. Same idea. You have it, you're not using it, somebody else should be able to. So they brought in Larry Roberts, another classmate of mine, in fact, an officer of mine at MIT, to manage this project. He came to me because he knew my work. He watched me do the simulation. In fact, I used his compiler on the TX2 computer. And said, Len, we need to know if this thing is going to work. He knew that I had the theory, so I could show it to him, it's going to work. In fact, he even says he would never have decided to spend millions of dollars of the US government's money if he wasn't sure this thing would work. So the design began to be laid out by a few of us in 1967. In '68, they sent out a request for proposal. At the end of '68, Bolt, Beranek, and Newman, a Cambridge, Massachusetts firm, won the contract to produce the first switch of the ARPANET. And we became the network measurement center early on so we could test it out. During the design phase, some great people were there throwing their ideas out. Herb Baskin was there, a time-sharing expert. And he said, if this network can't deliver short messages within a half a second, I can't use it for time sharing. Right. Specification, exactly. Half a second. By the way, we got 200 milliseconds. It came along. And Wes Clark said, separate computer from communications. I said, look, if this is going to be an experiment, and I was also interested in the research and the experimentation, we have to build software in so we can run experiments. Artificial traffic generators, measurement hooks, a place where the measurements can be evaluated, put that software in. So Howie Frank began to talk about network reliability. He said this network, if anything fails, the network shouldn't collapse. So we built in so we didn't say there should be 5 nines of uptime. We went much more pragmatic. We said if any single thing fails, everybody else can still talk. Yeah. So to do that, you need something called a 2-connected topology, 2 independent pairs between every pair of nodes. Built in it. So all those specs went to BBN. They built the darn thing. They delivered the switch here at UCLA on schedule. 8 months after they got the contract, they were to deliver this new technology, new applications, new device. They did it on time, on budget. It came here, we plugged it in, and bits began to move back and forth between our time-shared machine and that switch on the day after Labor Day, September 2nd, 1969. Wow. But that was just a one-node network. The schedule was that another one of these switches would be delivered at Stanford Research Institute, 400 miles to the north, and they would connect that to their machine. And that happened in October. So in October, we had a 2-node network. My machine, my switch, another switch, 400 miles away, and the SRI host. Okay. And it wasn't one single line. It was a gang of 4.8 kilobit per second lines. So now what do? You have a 2-node network. Well, now you can do something. So we decided one night late in October, programmer Charlie Klein and I were in the room and said, look, let's communicate between the two machines. So we got a hold of Bill Duval, their programmer there, and we said, let's simply log in from a terminal connected to our host to that machine. The idea is these are both time-sharing systems. They expect terminals to connect in and use the services of the machine. The big thing was sit at a terminal here, log onto your machine here, and through this wonderful network, log on here as if you're a local user. Well, that's easy enough. So we got all set, got Charlie down at the terminal over here, and just to be sure this worked, we had a telephone handset. In fact, I actually think I've got here it is. I just happen to have it. That was a telephone set.
That's the telephone handset.
That was the telephone. We plugged it in. We derived a...
You weren't using Skype.
Afraid not. Plugged it in. We used a piece of the high-speed line for the phone connection. But what the interesting thing is, we were using the defunct circuit switching technology to prove out the new packet switching technology, and it really helped us so we could understand what's going on. So Charlie typed the L. He said, "You get the L?" Bill said, "Yep, got the L." Type the O. "You get the O?" We're trying to do LOG for login. Get the O, got the O. Type the G, get the G, crash. So the first message ever on the network was low, as in lo and behold. Now that's especially interesting because if you go outside this hallway here, down into the alley, and come into another entrance to this building, and I just discovered this about a week ago. You walk on a platform, and there's a mosaic of tiles down there, and they're a strange pattern. It turns out it's the ASCII code for lo and behold. I have no idea who did that. You know, it's about 1.5 years now. Some very clever person put that in. That was the first message, October 29th, 1969 at 10:30 at night. You're entering 1969 right now. We reproduced this room to look as it did and smell and feel like it did some 40-odd years ago. And if you look over here, you're looking at the first piece of equipment ever on the internet. This is that first interface message processor, IMP #1 at UCLA, a Honeywell mini computer adapted by Bolt, Beranek, and Newman, BB&N, to operate as a switch, which handles all the functionality. And this is the same physical 4 square feet where it served as the opening node of the internet. The first piece of equipment ever on the internet.
And that's the actual one.
That's it. I kept it for years. They tried to throw it away many times. Most of the people who had IMPs have tossed them. There's just 1 or 2 left around the world. But this is #1. This is the first piece. If you open this machine, you'll be privileged to smell it.
Yeah.
It's got an unusual odor and just brings you right back.
Yeah.
You know, emotionally, it's great. You can't smell it through this. This is a military hardware machine. This machine was essentially a state-of-the-art mini computer, which was adapted by BB&N. And I first saw it in 1968 at one of the Joint Computer Conference shows. Thousands of people on a big exhibit floor. And you see these skyhooks up here? They had one of these machines hanging from the ceiling, swinging in the air, running. And there's a guy, big guy, stripped to the waist, oiled skin with a sledgehammer. And he was going whack, whack, to show that it was
military.
And it was. But the most important document of the internet, the most important document of the entire internet is right here. You talked about who was working with me. Well, one of my software programmers was John Postel. In fact, here's his picture. And he was not a hippie, even though he appears to be. He was the one who basically disciplined my staff to do things properly and keep records. He said, we have to keep a record of what's going on. So beginning in October, basically a month after the IMP arrived, we started keeping an IMP log. You know, this is an engineer's log. This is not, you know, Madison Avenue piece of document. Just scribble. We use an old STS log. And in here, we kept a record of what's going on. And the most important entry happened to be right here. On October 29th, 1969, at 10:30 at night, Charlie Klein, the programmer who's in the room with me, made this entry. Talk to SRI, host to host. This is the only record of the very first message ever on the internet, right here. You know, we had the technology. We started making measurements. We were the first experimental node. So we saw things happening. How come we have a 50 kilobit per second line? The routing procedure either goes one way or the other, one at a time. So how can you get more than 50 kilobits per second between 2 nodes if there's only one path at any time? And we say, oh, it's obvious. That path is on now. When it gets backed up, you change paths. So this guy's emptying its backup while you're sending this way. Then you go close to 100 kilobits per second, right? Too. So but we could break it at will, as I said. And every time we did, we would call BB&N and say, fix it. We did this, fix it. Because they wouldn't give us the code. They kept it proprietary until Arbor said, we paid for that code, you have to open it. They did, we saw it. Every time we got it, and it would take them 6 months to fix anything.
Right.
We discovered a fault this time we had the code. We showed them how to fix it, still took 6 months. One of the things I was very much interested in with design was distributed control. Why?
Right.
Well, I was a student of Shannon. And Shannon's great work came when you had a lot of things interactive, long code words, for example. That's when these emergent properties arise. So I said, I want to design large networks. Design a large network. You can't have a single point of control. You have to distribute it.
Right.
So what does it mean to distribute control? You're delegating authority to all the peers. When Arbor started funding the principal investigators, they had the same philosophy. They said, look, you're a smart guy, here's some money, go do the thing you do best. We're not going to sit on top of you. Make good things happen. So here we are, I'm a recipient of that kind of money. What do I do with it? I've got my graduate students. They're brilliant kids. Look, we need a host-host protocol. Here. I'm not going to sit on top of you. I'm going to run with it. That is not a product mentality.
Right.
That is a research and development and creative mentality. And it worked so well.
Hello and welcome to a demonstration for Django for everybody. This is to install Django on Python Anywhere. In a sense, we're going to just be getting started. This is a bit tricky because there's a tutorial on how to write your first Django application. There's a tutorial on how to set up Django.org on Python Anywhere. And neither of these are exactly perfect. So what I've got is an assignment that sort of walks you through a series of things that lay down some necessary things for this class. And so the first thing we're going to do is you should have a Python Anywhere account. And you should be able to log in on the Python Anywhere account. And you should be able to get somewhere. So this is my Dr. Chuck. This is my account that I use to I used to be a student on this. There's other accounts that I have for the production stuff, but this is one of my student accounts. And so the first thing you're going to do is you're going to use a console, and you're going to start a bash shell. So this is actually Linux, and I love Python Anywhere. I love the fact that we're learning Linux. Hopefully you'll just get a little more comfort with Linux as we go. But this is where you're going to do a lot of the command line of the system. So we're going to do make dir virtual environment. You might be able to make this Python 3.7 or Python 3.8. The later that Python is, the better. This is going to take a while because it's going to create what's called a virtual environment that allows you to have your own version of Python, your own set of installed Python libraries, and virtual environments are a wonderful thing in Python because then you don't have to ask the owner of this system, which is Python Anywhere, hey, could you upgrade the Python? Turns out you can upgrade the Python all by yourself. So we will sit and let this, oh, there we go. It ran right away. And ran right away. So let's go do the next thing. The next thing I know takes a long time. So the next step is to install Django. Now this is pip is installing software. So it's going to download a bunch of software and then it's going to install that software and it's installing it in our Django 3 environment, right? And so this is not installing it for the whole system. It's just installing it for us. And so you'll get used to the idea that you've got to work on the Django in your appropriate Django environment. We're using Django 3.0 in this situation. As the recording of this, Django 3.0.2 is out. Django 3 is quite nice. So we'll just sit and watch this for a while. So it's finished, and now we have it installed. Now there's a command that gets us into This is redundant right now because we're already in it. But work on Django 3 and make sure that you're in it. Then the next thing to do is grab this command and make sure your Django version is right. If that says 3.02 or later, then life is good and you have your Django working. Now, I want to also have you install some of the sample code in the class. Let me get this started and I'll explain what's going on. So this is GitHub, and this is code that I maintain, and I can update this code and I can send it to you. And so this is a lot of sample code. So if you go to DJ4E tab, I hit the tab key to do completion there. There is a bunch of files in here, and this is the kind of sample code that we're going to go through in the class. And so we need to add the requirements. Pip, again, is the dependency manager. There's a file requirements.txt that says, hey, we need a whole bunch of libraries. And so let's install those libraries. Now, in your first Python applications, you're not going to need all of these libraries, but I want to get them installed into your virtual environment early on so that as we go along, you're not going to add a feature like social authentication, which is this little application right there, like social authentication, and then oops, we had to install a thing. So I want to get all that stuff installed at the beginning. And this will take a little while, so we'll just pause for a bit. Okay, so that finished. And now what we want to do is run a command, manage.py check. You're going to run this command a lot. And this, we're in actually a Django application, and this Python manage py check reads through your files and these files that point to other files, looks for syntax errors, and it's a good way to check the sanity of your application, because if it won't pass this manage.py check, it's not going to start. We haven't even tried to start this application yet and put it up on the web. For now, we're doing that. So don't worry about this message. We'll get to that later. We can say Python 3 manage make migrations, and in this one it's going to say no change detected, and then we're going to run migrate, and that will create a bunch of database tables. Don't worry too much about that. So we've finished there. Now we're going to actually pick up in the Django application, but we're going to basically make a new Django. We're going to make a folder. So we're going to go back to our home directory. CD tilde says go back to home directory. And we're going to make a directory called Django projects. This is so you can have more than one of them. We're going to go into that directory, CD Django projects. And then we're going to start the project my test site. Now what this does is this actually created a whole bunch of files in my test site. Okay. Now we do have to edit one file. I'm going to edit this file. Now I have a whole thing on how to edit files on Python Anywhere. I'll do it I'll do it the way you probably will do it, and that is use this files screen. Oops, I have to go back and get my shell, dang it. Console, open like a new tab. You'll find that you'll want to go back to that console. So here I am. I want to edit some files, so I can go into Django projects, my site, and then settings.py is the file that it's telling me to edit. So it's just my site. It's a little weird that the name is doubled. You got to go down to around line 28 and say add quote star quote. And that has to do with protecting what systems can talk to this web server, and we're just going to say anybody can do it. Do not set this default. Forget this warning. It's a lie. We are not in production. We are in development. So then we have to say save. So then we'll save our file. Okay. So let's go back. We had to do that. Here's different ways of editing the file. You could use nano on the command line. That's cool. I just use this #1 way to do that. VI is really cool, but we won't do that. Okay, so now we need to convince Python Anywhere to run the application. Okay, and so that is under another tab. That is under, and I'm going to open this in a new tab. So now I have these files. Actually, I don't need this tab anymore. I have my, oh, I should oops. I should say Python 3 manage.py check here just to kind of be creative. Yeah, that's good. So you always want to do Python 3. I'm in this file, the site, the actual website that has manage.py in it. Python, actually, you don't have to say Python 3 anymore. It's after the year 2020. So you can say Python manage.py.check. You'll see me type Python 3 all the time because old habits die hard during the transition from Python 2 to type Python 3. So that's good. That suggests that this application in Django projects is in good shape. So now I have to go look at this web app setup. And what's going on here is this is Python Anywhere's way of taking the code in that folder and running it and giving you a web address for that. And so the first thing you got to do is you got to set this up. This is correctly set up. You got to point to the folder that has that manage.py in it. And if I go to the console and type pwd, print working directory, you see home Django Dr.chuck's my site. And this is the file that has the folder that has manage.py in it. So these two things have got to be right. This code here has also got to be right. When you see this, it's going to start out really big. Throw it all away, throw the sample away. I give you the entire code to put in there. And again, it's all setting up which site. And then, we also have to set the virtual environment in this web tab. Go back to the web tab. We've got to set this virtual environment. And I want that to be, you gotta go and change the name of it. Don't do the same as me. This is for my virtual environment. So it checks, yep, there's a good virtual environment. So you gotta have this source code, working directory, WSGI configuration file, and virtual environment set properly. We'll come back to this. These are error logs. And if all goes well at this point, let's double check the assignment. Hit the reload. It's what it says. So every time you change your code, you have to tell Python anyway. So this takes a little bit. And if all goes well, I will open this URL in a new tab. And it worked. Debug is true. Please leave debug true, or else this course is going to be really tiresome for you. Okay? So that's the first step, but then we have a little bit more work to do. We're going to add a polls application. So we're going to go back into that. I'm already in that folder. I'm in that folder, and then I'm going to start an application. Oops. Come back. I'm going to build an application. This is a way to create a bunch of source code. So one of the things about Django is that it comes with batteries included. And so in this particular case, it's writing a bunch of code in a folder named polls. Okay? And so that's now in polls. And then we go continue on our, now we're going to pick up in this Django tutorial. So we said start at polls. We did that. And we're going to edit a file, polls/views.py, and we're going to, I'll copy this code here. Open in a new tab, and Django projects, my site, polls, views.py. So I'm going to put that code from the tutorial in there. Okay, so that code is in the tutorial. Going back to the tutorial, it says create a file called urls.py in that same folder and put in this code. So I'll copy this. So I'm going to create a new file here, urls.py, new file. Let's put that stuff in there and save that file. Then we go back, and then we are going to go in the my site. So polls urls.py is an application. My site is for the entire site. And so I'll grab this code also. This file already exists, so we go my site, settings. This is the only folder that has settings.py in it. Oh, I wasn't supposed to edit settings. I was supposed to edit URLs. And this looks pretty good. We'll just add the line. Well, actually, we got to do all of it because we have to import the include. So this little import include, this little part here was there. So this was, I copied this. These are all, of course, comments. So all these files are just some Python. This is setting a variable called URL patterns to an array, and path is a thing that returns an object. And so you can go read all the, and you should read all the documentation. And then I will save this. And then let's go back. Now, every time you see here when it says Python 3 manage run server, you want to go do Python 3 manage check. So that's like do everything but run server except run the server. And again, you could get errors here and read those errors. They're tracebacks. You'll say, oh, no comma found. Let me just make a mistake so you see what happens. I'm not making mistakes. Come back. Let's go into this file. Let's forget a parenthesis. Okay? Let's save it. Shocking. See? So now, when I did a Python 3 manage py check, it blows up and it tells me, oh, something's kind of funky around line 22 of urls.py. Looky look. I mean, my editor even told me that. So there we go. So I fix that back up and I say save. And now I go back and I type, by the way, you can hit up arrow and you can run a command again. Python 3 manage.py finds no issues. So then what do we do to test our application? We go to the web app. Now we've got these guys set up. We don't have to change those. They're all set up again. So we hit the reload button. Take a little bit of moment. Then we go over to our actual application. Now this looks like a failure, but it's not, because it turns out that that little bit of code you run is sitting in polls. And so that's the code that you ran. And so at this point, you have completed the assignment. I got a little bit about errors down there. But so we walked through that. Wasn't too bad. Getting things set up is often the hardest bit. But hopefully in a little bit of time you'll have it all working, and then we'll start adding things to our application. So hope this was helpful. Cheers. Hello and welcome to another walkthrough for Django for Everybody. Today I'm going to actually sort of fast forward a little bit into the future and talk a little bit about how the auto grader works. So I'm going to go about to the middle of the course and show you an application that you're going to be working on called the Auto's CRUD application. And Auto's CRUD is kind of our destination. The idea is that it's got to create, update, and delete. And it talks about login, etc., etc. And so I'll take a look at the assignment for this, and it tells you how to log into this. You're going to have to make your own account. And this is your assignment, and there's a lot to this assignment. I want to point out to you that one of the things that we always encourage you to do before you submit to the auto grader is to do your own testing. Okay? And so let's just do some testing here. Let's run this program, this sample implementation. It's going to log in, add a make, add an auto, view the makes. All right, so I'm going to log in, DJ4E CRUD, and there's a password there. And so we'll go to the autos one. Let's add a make. So we're going to do a dodge. Let's add the make. So we're kind of running through this manual test. Then add an auto selecting the make. Add an auto on 1, 1, 2, 3, 4. Some comments. Pick the make dodge. And this is code. It can break, right? View the makes. Update the make and press cancel. Update the make and press cancel. It should go back to the list. So what I've given you on a lot of these more complex assignments is an outline of things that you should test, right? And then if you update this and you I'm going to update the makes. I got to view the makes. I got to update the make. I'm going to say dodge exclamation point and submit it, and you'll notice that this changed automatically because of third normal form and all that stuff. And so you're supposed to write this code and then submit this to the autograder. So the way the autograder works is you're going to submit it. So you're going to get your homework all done and you're going to test it, and then you are going to submit it to the autograder. And then and you'll say evaluate. Now one thing you'll notice is this takes a little while, and that's because this is doing a whole bunch of request response cycles. So let me just show you. Well, I mean, and if it's good, it tells you I like what you I like this, I like this, I like this, I like that, I like that, and then it figures out your score. And you can see the pages that it's actually retrieving by looking at this show hide retrieve page. So let me just kind of show you a little picture of what's going on. So normally you're sitting here and you got your browser and you're using Python Anywhere and you're writing code and you're testing code, right? You're testing the code in the browser just like I was doing here. I'm just me in my browser and I'm doing stuff and I'm working in Python Anywhere, right? And so let's go ahead and make a console in Python Anywhere, and I'll say work on Django 3. Because I always say that. Oops, work on Django 3. And I'm going to go into CD Django projects, CD CRUD. And so here's my code for CRUD, right? That's the code that I've got for CRUD. You might be doing this with your full screen editor, but I am basically at this point, I am working up here where I'm in my browser and I'm working on Python Anywhere and I'm making changes. And I'm testing those changes in another tab, right? So the code that I'm running, right, is running right here. So let me just make a little mistake here. Autos urls.py, and let's just break both the update and the delete. I'm commenting these paths out. And then I'm going to go to my web tab. Oops. Click web, open a new tab, and I got to reload. So I'm going to reload CRUD. I'm going to reload CRUD. So I just messed my code up, right? So you can see, so the code is mostly working, right? But when I click the update, like add a make, it's going to work, right? I can make a forward, that part's working. But as soon as I hit this update button, oh wait, what happened? No. Oh no, it's the makes that I broke, sorry. I broke the makes. Now when I update this one, it's going to blow up. Okay, so I almost didn't, I meant to break it. So what'll happen here is I'm breaking it. I'm talking up here to the system. If I go and I run this in the autograder now, this DJ4E.com is going to make requests to Python Anywhere and get answers back. And sometimes it likes the pages that it gets and sometimes it doesn't. The safest thing to do is test it by hand. But now if I go back to the autograder, I mean, I saw this error, and what I should do is fix the error. But now I'm going to go to the autograder, and I'm going to rerun the autograder. And again, this takes a while, and the longer the more steps the autograder is taking, the longer it's going to take. Sometimes it'll take about 20 seconds. So I think it's done. So now we can see it's doing good. It logged in. It added a make. It's deleting makes. It's doing something. And oh, look. Here we go. Page may have errors. HTTP status 404. Did not find a form with a submit button. Now, you could just call your teaching assistant or me and say, what's wrong? Or you can click this button called Show and Hide Retrieve Page. And now it's saying, look, the autograder is looking at this page. This is the exact URL that it's looking at. You can even click and you can open that URL. You'll see it's exactly this URL, right? And so what you need to do is then you need to fix your application, right? Fix your application, which I'm going to do right now. I'm going to undo, oops, come back, undo, save that, and then I'm going to reload my application because I'm now going to fix it. Takes a moment. So now that I put those routes back in, this update will work, right? Now that code works. And if I run the autograder, because I got this thing to rerun the same test, you can redo it. So then it's running the test, running the test, and now it's done. So now it made it past. It's all green, it's all green, it's all green, and we got a good score. So the key thing is to get used to this idea that you should test your code, run through all the scenarios. When you run the autograder, it will take some time because it's actually doing all of the things. It's pretending to be a browser. DJ4E.com is pretending to be a browser in order to test your URL. And then at some point, if it has made it through all the tests it wants to do, then it sends the grade to the appropriate grade book inside the learning management system. But the key thing is to get used to the idea that scroll to the bottom, look for what went wrong, and then see what it was that it was seeing. This particular one is working, and you can see it. And the autograder is not trying to trick you, and it's not trying to mislead you. The autograder is as best I can do it, telling you everything it's doing, everything it's looking for, and when it can't find something, it shows you the page that it was looking at, and that page wasn't right. Okay, so you'll get used to the autograder. It's a good helper and a good friend. Make sure to look for the manual testing section in your assignments and do the manual tests. It will save you a lot of time, and it's just easier to fix your application by running your application yourself and then making changes to your application and then reloading your application, and away you go. So I hope this little summary of how the autograder works has been useful to you. Cheers.
I worked at this place, CWI, and for my then current project, which was the Amoeba operating system, which I was working under SAP and Mullender. One of our projects was to write application level utilities for this new Amoeba operating system. And so there was an operating system kernel, and it was very good at talking to the network, and it was very good at managing processes, but there wasn't much user level software. There was barely a shell. I think there was a ported, very old Unix shell, something like the original version, Unix version 6 shell. But because the file system model on Amoeba was so very different, we couldn't take an existing suite of Unix utilities. And so we wanted it to be self-hosting. And in order to do that, we realized we needed a large amount of user-level sort of applications, utilities, tools, whatever you call it, from an editor to a mail program, to a login utility and a backup tool. And one of the things I realized as we had a small team of people sort of working on those things, that it was very slow going writing all that stuff in C. And it wasn't particularly interesting or sort of novel or difficult, and often we also didn't really care how fast the code ran. All the reasons why you would write a piece of software in C didn't really apply. The only reason left was that C was the only language for which we had a compiler. there was this ABC language that I had in the back of my mind that would be a much better language to write a whole bunch of utility application tools for Amoeba. Except that ABC was so high and abstract that it really, it wasn't a good language to talk to servers and file systems and processes, and it sort of, the whole operating system thing was abstracted away from ABC. It was almost something like it, I don't know, in an alternate universe, ABC could have become the language of spreadsheets. It was very good for talking about a user's data and doing all sorts of clever stuff with that data. And it did that using very sort of general all-purpose data structures like lists and dictionaries. And of course it had very nice code structuring devices like a small number of simple statements that could be combined in any way you wanted to create other constructs, the usual function and procedure abstractions. It was not at all an object-oriented language, although the implementation had some objects sort of shining through. Anyway, ABC as it existed still wasn't usable, but I somehow, since I had worked on the ABC project, I knew exactly how it was built. And I had this idea in my head that given how much time we had available for our project, I could actually build a whole new language, design and implement it from scratch, given what I learned about both the design and the implementation of ABC, and start using it to implement our suite of tools and still be ahead of the game compared to a situation where we would just have sort of clunked on writing the things we wanted to write in C. For 3 months, I did my day job, and at night and whenever I got a chance, I kept working on Python. I believe that within 3 months I was to the point where I could tell people, look, here, this is what I built. And it had an interactive interpreter loop. So the first demos were all, let's assign an expression to a variable and print it back. And let's define a small function and call it. And let's put some things in an array and iterate over the array. And all those things worked. And somehow, and I don't exactly know sort of how fast this happened, but certainly my 2 office mates were almost instantly taken with it and started helping out. And they and a few others within the institute were very excited about this thing that I'd built. And started sort of course, we didn't instantly use it on Amoeba because it wasn't mature enough to actually write the Amoeba utilities that we wanted. But it was already instantly useful enough for to run on our Unix system. People within CWI, even outside my own department, started using it and recognizing that it was fun and productive to use, and they used it for small scripts. And people started contributing things like bug fixes. Somehow things went very quickly during that first year, because I think by the end of 1990, so a year after I started, we developed a plan to do an open source release of this language. And this was before the word open source had even been coined. So we didn't call it that, but we did have some models. We had like X11, the Windows system at the time, had a distribution that was one of the sort of open source examples. With 2 colleagues, I worked on sort of building a distribution, and we actually, It turned out to be very simple to get management to sign off on this release. That was an incredibly lucky stroke. I just sort of, I asked my manager's manager, what shall we do about this? And he said, oh, you got to talk to this and this person in the administrative branch of the institute. And I talked to this woman, and she was like in charge of all legal affairs, I believe. And I said, well, I have written this source code and I would like to release that, and I have sort of made up a license that's like identical to the MIT license. I could say MIT releases software under exactly this license, and we just put like the formal name of our institute in there instead of the regions of the institute. She asked me some questions like, did someone pay for this to be developed? And my answer was no. I started this all in my own time, and it was for this research project. That's sort of, my manager is fine with it. And so she said, sure, go ahead. And we did it. And that's so that in February 91, we did the first Python release. And it felt like, at the time, like an incredible milestone. We needed to post it to Usenet. There was this Usenet news group that would receive source code for random free projects. I immediately started getting useful, positive feedback from, well, initially just from random people who picked up free software from Usenet. And we quickly sort of got into a routine of doing new Python releases. And every time, I mean, there were the obvious improvements to the language and the library and bug fixes. A very important category of things that were often contributed were ports or porting fixes, where people had different architectures, different compilers. The Unix world was much less homogeneous at the time. There were lots of small Unix vendors that had their own compilers or their own hardware, all sorts of things. So the big things that happened during, say, the first half of the 90s was a community of Python users and developers self-organized. Then came the invitation to come to the United States for a couple months. From NIST, the National Institute for Standards and Technology. So I spent 2 months there. We organized the first Python workshop, which was hosted by NIST. Through that Python workshop, I met people who offered me a job, and from 95, I mean, I went back to the Netherlands for a few months, and then from 95 to 2000, I worked in the US, in Northern Virginia, at CNRI. And so there we worked through a lot of growth of the community and the infrastructure. We created the Python website. I got in touch with a bunch of people who are still active in the Python community, like Barry Warsaw. I think when I started there, Python 1.3 was about to be released. And then while I was there, we released several subsequent versions leading up to 1.5.2, which for some reason 1.5.0 was nothing, but 1.5.2 remained that sort of the standard, the gold standard of Python for a very long time afterwards.
everybody, it's Chuck, and here we are in Tokyo, just like I promised in the last video that we would find my way to Tokyo. It's surprising that I've not been here since MOOC started in 2012, but we finally made it. So, like always, I want to let you know let you meet some of the other students in class. I'll tell you their name and maybe a little bit of message, okay? So let's go ahead and start with you.
Hi, my name is Christian. Dr. Chuck teaches me. I teach my students. Thank you, Dr. Chuck.
I love it when teachers teach programming. To what age?
I teach middle school and high school students.
Great.
Hi, I'm Singawano. Dr. Chuck, I appreciate for your great, excellent class. Thank you very much.
I appreciate that you came. It's been great talking to you.
I'm Ben. I'm originally from Australia, and I've really enjoyed taking yoga courses, Dr. Chuck, so thank you.
Thank you.
Emmanuel from Uganda at Tokyo University of Agriculture currently. It's been a pleasure doing Dr. Chuck's course. I'll use it in hydrologic modeling and teach my laboratory mates Python, since most know MATLAB. Thank you so much, Dr. Chuck.
Welcome to the class.
Sure.
Hey, my name is Ahmed. I'm from Tunisia. I enjoyed a lot doing Python classes. Now it's great honor to meet with Dr. Chuck. Thank you a lot, and I hope keep continuing with you. Thank you.
My name is Jan. I'm from India. I'm learning Python in the right way from Dr. Chuck. Thank you very much.
Thank you.
Hi, my name is François Xavier. I use your course every day for data science, and thanks a lot for all those courses.
Thanks.
Thank you.
Hi, I'm Hiro. This is the first time experience to virtual reality becomes real.
Thank you.
Hi, my name is Shayla, and I'm taking Python. I'm really enjoying learning a new programming language, and I'm grateful for this course. Thank you.
Thanks for coming.
Hi, I'm Mizue. I'm running Python for everybody. I love Python, and I love Dr. Chuck. Thank you.
Well, thank you. So there we go. Up next in a couple days we'll be in Nagoya. So 2 in Japan after 5 years of not being here. So see you on the net. Cheers. Hello and welcome to our lecture on HTML, the hypertext markup language. So we're going to place this in the context of our request response cycle, and sort of here's us in the request response cycle in our browser and what we're seeing. We make a click, it goes across the network to the web server, runs some code, maybe talks to a database, formats up some new stuff, and we get the response. Then HTML comes out, and then that's parsed to make the DOM, and what we see is the document object model. And we're going to ignore most of that in this lecture. We are really only going to talk about this part here, and that is what this response is. It's HTML, and it is parsed, and it's read through, and it's used to construct the document object model, which then shows what we see. And so HTML is just a technique of using some special characters, less than and greater than, to add tags to indicate what we want to see, like the paragraph tag. The paragraph tag, that's a paragraph tag. Strong tag makes things bold. Emphasize tag and a paragraph tag. And so we have these tags and we just mark up. We're communicating meaning. If you're old enough to remember, word processors used to have ways to look at the actual codes that were being stored in the word processor file. So the web is, the HTML and hypertext transport protocol and all that stuff is a relatively recent invention, and we're doing so many cool things with it. It's continuously evolving, and really, we're less than, we're 20 years old, and so we're doing so much with it. It's continuously evolving. So HTML and CSS are really kind of at the edge. Looking back in the early days, if we take a look at what HTML was really intended to do, it worked on a Next computer in the early 1990s, and so this is the Next browser, which came from CERN, and it had everything in a new window. Images were not shown in line. And then there was the NCSA Mosaic browser, which was the first browser that was universally available on Unix, Windows, and Macintosh. And you see things like gray background and blue links and highlighted links that you visited in purple. And so in the early days, it was nothing like what we see today.
You know, in the early days, we were just amazed and happy that we could see a link and you'd click a link and something would happen. But today, money is to be made based on making stuff super beautiful, on the number of pixels and how things line up and how things are shoved over and how navigation looks. And so today we need to create beautiful web pages, whereas in the old days we were just amazed to have web pages that worked in the first place. And of course, computers have gotten much faster, capable of handling video and images. Back in the old days, images were costly, both for network bandwidth and for the time it took your computer to display them. And so that just affected how we did it. And it's kind of fun to use the Wayback Machine, otherwise known as the Internet Archive, to go back and look at some of these older web pages and realize that it's still amazing that a lot of them pretty much work. And in the good old days, HTML was kind of a Wild West. The browsers did not want to show broken HTML as broken HTML, and so they compensated for it. And so in the old days, we had things like tags that could be uppercase. We would have a paragraph tag that didn't finish. We would have LI tags that didn't finish. We would have attributes that didn't even have double quotes in them. So there was all kinds of stuff, and literally you can take this bad page and you could put it into a web browser and it will still display. So HTML, while it technically is a very precise language and you can make syntax errors, browsers are extremely flexible in terms of parsing it. Now, you're not going to get predictable results. The browsers can go into what's called quirks mode. And so in order to create the standards environment that we have today, Tim Berners-Lee, one of the original founders of the World Wide Web, helped found an organization called the World Wide Web Consortium, or the W3C. And it really decided that instead of just letting people write a browser and having HTML be defined by the browser, instead they would write a spec for what HTML was, and then multiple vendors could produce the browsers. And it took a while for this to become successful, but there was a need for every vendor to build a web browser, and so they worked with the World Wide Web Consortium. And like the mid and late 90s, 95, 96, well 94 through 98, 99, the World Web Consortium created a lot of wonderful standards around the World Wide Web. Now, once we started having rules, then we tend to want to follow those rules. And so tags need to be lowercase. Attributes like this image source equals have to have double quotes around them. You have to have open tags and closed tags, open tags and closed tags. And so there's a set of rules, and now we are much more precise about our HTML, and we try to write it as precise as we can so that we get the best performance and the best sort of rendering out of the browsers that we can possibly get. Because if you don't write precise HTML, then the browsers are going to make decisions as to how to render things, whereas if you write precise HTML, then you really are in control of how the browser lays things out. So up next, we're going to talk about HTML itself, look at some HTML documents, and take a look at the syntax of HTML. Welcome back. So let's talk about some of the basic syntax of HTML. The first thing is to look at the overall document layout. And they start with an HTML tag. You might have a thing called a doc type up here, and we can put in one if we like, but HTML is the outer tag, and then there is a head tag and an end head tag. And this is sort of non-printing information. We set styling up, we declare the title of a page, perhaps load some JavaScript, and then the printable page of the content is in between a body tag, and mostly what we're going to talk about is the stuff that we put in as page content. So you'll find that there are special file names that we use. It really has to do with the fact that what we do is we make a directory within the web server, and when we go visit the directory, the web server looks through a series of files that it's configured to look to, things like index.html, index.htm, or index.php, and each one has a slightly different order and a slightly different set of things. It might even be called default.htm or default.asp if you're on a Windows box. It is configurable, so different systems do things differently, but usually index.htm is probably the safest thing unless you're doing PHP, which we will be doing later in index.php. And so those are usually the safe bet. Now, when you're viewing things off of disk, which we can do, if you download all the code that I've got in html.zip, then you'll have to open the index.html by hand.
So we can put multiple files in the same directory, and then we can use them in what are called relative links. And so we can easily create links between one file and another. And so you'll tend to see, if you look at the zip file, that you've got a whole bunch of files in the same directory, and with little anchor tags, they point back and forth between each one. And so, like I said, you got tags like the paragraph tag, the strong tag, and the emphasize tag. They have to start, they have to stop. But another thing that's really important about HTML is the fact that most of the time we are logically marking up the text. And so we're saying we want this stuff right here to be a paragraph. But the end of the lines that we put in the HTML that we write are not really that important. What happens is depending on the width of the browser, if you change the width of the browser, the text will be rewrapped. And that's because there's still a paragraph, but we don't want to hard code it because we're not working on paper. Sometimes browsers are really large, sometimes browsers are really small. Sometimes you're on a phone, right? And on a phone, browser's really small. And so you don't want to tell exactly how many pixels it is wide, except when you start doing really fancy layout. But in things like paragraphs, you just say, hey, make it a paragraph and rewrap it. And that also, the rewrapping then also changes how tall the pages are, because the narrower pages, it kind of extends the page down. But the white space inside of the HTML is really generally ignored, and the lines are generally ignored. There are some tags, like the pre-tag, that changes that, so white space is respected and new lines are respected. But most of the time we just let the browser rewrap things, and it's good. You have beginning tags and ending tags. So here's a beginning tag, and then here's the ending tag. The slash is our indication of an ending, and they're paired. And they're also nested. So this P tag has a strong tag within it and an M tag within it, and that's totally okay because this whole thing is a paragraph and this is a piece of bold text. So they have beginning and end, and slash is the end. You can also have self-closing tags that have like an image tag that has like a slash, and that means that you don't have to have like a slash image over here. That's the same. You just put a slash here and it self-closes. Another thing that you will get used to is the fact that you can put on the opening tag attributes, so key value pairs. And you'll go define what you go read the documentation on the image tag, and it'll say, oh, put a source attribute on to say what picture, what file we want to display as the picture. The image tag is to show pictures, basically. So given that less than and greater than and other things are special characters, we have to have a way to print the special characters. So how do we print a special character? Well, we use ampersand LT semicolon, and there's a whole list of these things. HTML special characters. And you can look them up. And there's some that are kind of fun, like the special characters for the deck of cards. There's mathematical special characters, and you go look these up and you can find them. The key thing is they're cute, and you'll see that I'll use some of these arrows in the things that I'm doing. But the key ones that you really need to know about are less than, greater than, and ampersand. And just because ampersand becomes a special character, less than, greater than, or ampersand are really the special characters in HTML. And so to represent less than, you do ampersand LT, ampersand GT, and ampersand MP semicolon to get those things right. HTML comments, like in any programming language, any situation, the start of an HTML comment is less than exclamation dash dash. It's a little clunky, but we just want to make sure it's really clear. And so dash dash less than comments can go across many lines if that's what you want to do. So that works as well. Links is a critical element of HTML. It's why search engines work. It's why, when I first saw it, I'm like, I click on the thing and there's a new page. Isn't that amazing, right? And so hyperlinks is the H in HTML. It's the H in HTTP. And so it is how we, in effect, use this thing that we're sort of just scribbling on to create knowledge that Google then can extract. And so the anchor tag, the A tag, is the tag that we use to do these things. And so, there's a header one, a paragraph, and the anchor tag this is the start tag, and this is the end tag. And so the text that's clickable is second page, and you can see that it's clickable right there. It is styled with a underline and blue to indicate that it's a link. And so there's the href, which stands for hypertext reference, and then it's an attribute, so it's key value with double quotes, and then this is another URL. And so that's like, in effect, putting that URL up and going into that next page. So it's a hotspot. In the early days, and I'll show you a few of these links were like the coolest thing ever, and so we made them pretty colors, like the blue with the dash. People didn't sort of, when they first saw the web, they didn't know to click places, so we sort of styled them quite brightly. And then because you were often scanning and searching the whole web, because the web wasn't so big in the beginning, we would mark them as purple after you'd been to it. So you could sort of slowly but surely work your way through the whole internet as it existed back in the old days and keep track of the ones so you didn't have to go back to the ones that you'd seen before. And that was an absolute link, and here's one with a relative link, and that assumes that we are now in the same folder, same directory on the server, where we have href, and so here's the start tag, here's the end tag, and then first page is the clickable stuff. And you'll note that that is a purple link because I have already been there, because page1.htm was exactly where I just came from. And so you click on that, and then you can go back and forth, and those are the pages we played with in the HTTP lecture. And so these absolute references are references that start with, HTTP or HTTPS or whatever, and relative references don't. And so that basically means that this page1.htm file has to be in the same folder as whatever file we happen to be viewing right now on the same server. So if you want to switch folders or switch servers, you have to use absolute references. And if you are just moving between files on the same server, you can use relative references. Images are a lot of fun. In CSS, we'll see how to wrap text. One of my favorite things was to wrap text. There is an image tag, which we saw before, image, and then the source equals is the attribute, and then in quotes the name of the file. And it can either be an image that's all by itself. In this case, it's this paragraph is what we're seeing, and you can see that this image is a tiny image, but it's sort of like blah, 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 blah. The image right here works kind of like a character. You got to be careful because the images can be really big. That's why I made a tiny image. And you could even, for example, in this case, I have an anchor tag, and the clickable part of the anchor tag is an image. So if you click right there, that will move you to lists.htm. And so you can make an image be a hypertext reference as well. Now we're going to do much more with these things, and this is just, at this point, the basics. Lists are an important part of HTML. There's ordered lists and unordered lists. And so the unordered list starts with the UL tag and ends with a UL tag, and then that sort of bounds the whole list. And then each list element starts with an LI, list item, and /LI. And I want a little bit of spacing. If you don't put them in paragraphs, you don't quite get the default spacing. This blank line's really coming from the paragraphs. So I'm putting a list of paragraphs, basically. It doesn't have to be a list of paragraphs. You could make a little denser list with a list of links or something, but I'm putting paragraphs in. And so you can see that I have LI to end LI, LI to end LI. I'm putting some links in here, etc., etc. And so ... and it puts all the bullets in. It does the indenting automatically. We'll see in a bit how we can control all that formatting and do different things if we want to do those different things. But for now, we're just going to play with the default formatting and learn the HTML, which is our way of representing that we want a list on the screen, but we're not so fancy about exactly how it's supposed to look. So in HTML, we really are looking for the meaning of the page, not how pretty it is. Tables. Tables have a bit of a checkered past. In the early days, people tended to use tables to lay pages out on grids. And they would just put, a paragraph here and a paragraph here and then a paragraph underneath it, and they would move them around, and they would put images in some of the table cells. And that turned out to be really bad, and that notion of tables as graphic layout is long gone, and we use CSS now, which is the next lecture. But tables were always a good idea for tabular data. And so if you have something that sort of makes sense, is like a list of cars with some make, model, and mileage columns and a list, then you mark them up. And so the table markup is pretty straightforward. We start a table with the table tag, and then we have a series of rows using the tr tag, tr to /tr. And then if there's a header line, which can be formatted a little bit different, you know, we do a th to /th. And then this basically says it's going to be a 3-column table because we have 3 table headers, 1, 2, 3. And then we're going to put TDs for the data. TD stands for data, 1, 2, 3. And so that's the forward, edge, and then the mileage of that, and on and on and on and on as we go. And so it's not hard to build them. You kind of have to keep track of how many of these things you've got. And there are tricks where you can make a table that has like 4 things, but then in one row this expands so that that's, I can't erase it. Can't erase it. So there are ways to do things where a data element spans more than one column, call span, for example. But the key to tables is that we use them for tables. We don't use them for arranging things that are not themselves row, 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 row. So I'm going to stop there. I'm going to record some exploration of some sample code at www.webapplicationsforeverybody.com/code/html. And I really am intending that you will, these are very simple pages, but the idea is to look at them in developer mode and take a look at them, and then you can see how the various things work. And you can also then look at the source code and see, oh, here's how a pre-tag works. Or where's the pre-tag? No. Oh. Yeah. So we look at the source code, take a look at things, and show that the line wrapping does not actually matter. We look at pre-tag in another one. So I'll record some walkthroughs of all this sample code, but I encourage you to take a look at it because it has a lot of good examples of the basics of HTML. And so HTML is a continually evolving thing. It's a very creative space. It's a lot of fun. We have to be really tempted. We have to avoid the temptation of trying to make everything look pretty in the HTML, but instead delegate that to the CSS, which is what we're going to talk about next. Hello and welcome to Web Applications for Everybody. In this screencast, we are going to play with some of the sample code, and you can either download it and play with it on your own computer, or you can look at it in your text editor, or if you just want to browse it, you can browse it here and take a look at the version that I'm using. It's really been intended that you look at this in the developer tools, and so you can do things like, say, inspect element. And so here we are. We're going to, this will also be a little more valuable even when we're doing CSS, but you can see the document object model. Now the interesting thing here is it shows something I'm always talking about, is the difference between the document object model and the source code. So this is the document object model. It's kind of stylized. If you look at the source code, you have to say view page source. And so the source code, this is literally exactly what's in the file. And if you go look at this file in a text editor, you will see this. And if you're looking at it here, it doesn't quite look exactly the same, and some things have been done a little bit differently. You know, they kind of got this extra stuff, and this is kind of after the browser has looked at it. And we start talking about JavaScript and changing some of this dynamically. You'll see this part is the document object model, but the source never changes. The source is what was originally downloaded when the server sent this back to us. So let's take a basic look at this. I'll hide this unless I need it. I'll go back and forth between the source. So we have a basic document, HTML, with a head tag and a body, and then a header. And of course, here's our header. We're using default styling, and paragraphs are an important part of things. You can squeeze this up as much as you want. White space sort of doesn't matter, right? So this white space kind of doesn't matter here. The fact that this has got extra space, it doesn't much matter. And so you can see an anchor to a strong tag that leads to a boldness. Let's just go ahead and look at it here in the inspect. We'll go down here, we'll find like a strong tag, that's the bold. We got an emphasize tag, and if you look a little farther, you'll see there is the anchor tag, which is the whole anchor tag is this whole tag from the A to the /A list.htm. That's where we're going to go if we click on this text right here. And so you can see, now this is a relative link, and it
turns it into an absolute link, and that's because the browser knows where we're at, and so it sort of prefixes everything up to that to the relative link. But that's nice because if we look in folders, we will see that these folders are all here. Here, let me go find you that folder. It's pretty deep in my... Later, this will all make wonderful sense to you. I do a lot of stuff with web. Code, HTML. Okay, so here we have, after all that, here we have the files, right? And so this is index.htm, and index.htm is right there, and list.htm. And so if I click here, I'll go to list.htm, and that'll pull this other file up. And so these guys are all in the same folder together. It just means that I can use relative links to go moving between them. A tag that's really becomes more important, especially as when we're talking about writing code inside HTML and showing people code, is the pre-tag. And so the pre-tag, and you can just say inspect to hop right down to where the pre-tag is. The pre-tag respects spaces, so all these spaces happen, the new lines happen, and it also shows it in monospace font. Now you can change all these things once we get to CSS, but pre-tag, when we're printing debug out from, not in files like this, but when running code, sometimes it's good to print debugging out in with pre-tags. So let's go to the next page. And so here's a whole series of things we're going to play with. This is a unnumbered list. This whole thing is an unnumbered list from top to bottom. So when I highlight this, you see the whole beginning to end of the list. Then each item in the list has a start and end li tag, right? Down, down, down. You know, so here's this. We should learn about tables, and there's a href. There's another relative link, and so this is sort of my jumping off page to get to all those other things, right? Learn about tables, etc., etc. And so you can see these. We probably use just to take a look at the source code of this page. And so that's the source code that I typed in, and you can see the li tags, the p tags. I'm putting p's inside of li's to get space. Let's see if I can sort of show you that. So if you look at this and you look at the li tag, the li tag is that, and the paragraph is what actually creates the vertical and horizontal space, right? So that orange that you're seeing, that's paragraph. There's space that the paragraph tag has preset. So that's how I do that, putting paragraphs and hrefs, and so that's what this all looks like. So let's take a look at special characters. And so this is an interesting thing because it's not really what came out, because less than requires ampersand LT, but it's kind of processing that. So let's take a look at the source code to this one, because that'll be more instructive. So ampersand LT, ampersand GT, ampersand amp. This is an ampersand in HTML, and then just the letters AMP semicolon. Semicolon's not special. There are only really three truly special characters: less than, greater than, and ampersand. And you can put all kinds of fun stuff, clubs, hearts, and diamonds. And so you got the clubs, hearts, and diamonds, some arrows, stuff like that. What's nice is browsers just have these built in, although they're not necessarily the sexiest or coolest things. And I think what happens when I go back on this link is I go back to the list. So that's just special characters, and you'll notice that the default styling that says we've seen this one, and this is how the web worked 1,000 years now, back in the 90s, is you sort of, oh, it's kind of nice that it's turning purple. And you'll notice that Google does this as well when you're doing Google searches. It actually lets the links change color after you visited them. So let's take a look about links. We look at links. I'll view the source of this guy. Absolute link, href, right? And then /a. This is the clickable text, right, between the beginning tag and the ending tag. The attributes are on the beginning tag. Another attribute that you can add, and I do it all the time, is target equals blank. And that basically is the way we say open this up in a new tab. So you'll notice pop up in a new tab. And so that's where that one goes when it pops up. And so you can decide whether or not you want this to go in the same page back or in a new page. And then I got to close the tab to get back. And now I'll go back because that's just a relative link to list.htm. So I can go back and look at the next thing. Let's take a look at how images are represented. So so this is just a paragraph that has an image in it, right? So it's a paragraph, but there's the image. Source equals medium.jpg. If you look in my folder, you see the image right there, medium.png. You don't see the suffix because Mac is trying to hide it from me. And so that's just, you see this space here and here. The image doesn't have any space. We could add some with CSS later, but the paragraph is what's adding that space. Then we have just a regular old paragraph. I'm not supposed to use a center tag. We'll get to the how to center stuff, so that's what that is saying right there. And you can have an image that's right in the middle, so you see where that image is. I think of images, if they're right in the middle of text, they're like a giant character, and so that's how that works. And you can even sort of stick an image as the thing inside of a link. So here's the anchor tag. It's that bit right there, and then the anchor tag body is an image. And so if I click on that, it's going to go back to list.htm. You'll notice these all go back to list.htm, so I can work on the next thing, right? Tables. Again, you're not supposed to use tables for laying out like blocks of text, which we used to do. We used to do things like use tables to draw borders around things, which we'll see in CSS, but now that's totally verboten, and you're supposed to look at tables in a way that they're, you know, nice and pretty. So let's do a view source here. So let's see, there's our table, our slash table, and a table row. Now let's take a look at the DOM. So apparently I didn't put a T-body. We're supposed to put a T-body in there, and I didn't do it, but this is the DOM. The DOM put it in. That's put in by the parsing, and so clearly I made a little mistake in my HTML because I didn't put a T-body tag, and so that was added by the browser. As it was parsing and reading through this, like, oh, he forgot his T-body. So it just like slapped one in for me. And I think the mistake is this is my header row, and I think that should be like a T-head. So there I go, bad HTML. It's the story of my life. And then I've got the rows, and you'll notice that the DOM is kind of prettier. So sometimes I do this. The DOM is indented nicely. So this isn't really the source code. This is the data that represents this visual, right? It is the thing that you're seeing, but it read this from the file or from the server, parsed it, and produced the document object model. I only say that like a million times. Okay, so back we go to the lists. We're making pretty good time. So here's some really bad HTML. I'm going to view source on it, and again you'll see sort of the difference between the document object model. When you're debugging these things, you will have to sometimes view source. Sometimes document object model will be the only way to debug it, and sometimes view source. So this is the one that's got bad stuff, like H1 is uppercase. This paragraph tag is not terminated. This UL tag is uppercase. This LI is not terminated. I don't have double quotes here. So there's a series of mistakes that I've made in this HTML, but it looks pretty good. And you'll notice in the document object model, it's fixed all that. Now, each one is lowercase. The P tag is finished. There are double quotes, meaning the document object model is not just your HTML source code. It's like the sensible, parsed, pretty version of the HTML source code, you know. And so, you know, this UL tag, these LI tags are now done. The UL's lowercase, everything's lowercase. So it's like, I'll take care of your mess. I'll patch up and fix your HTML, and then I'll display it for me and make sense of it. So the document object model is not the same. It is sort of like a sweet, awesome, better version of it. But this is what changes that. So let me just show you something, how I can change the document object model. Let's see. Let me see if I can change this text. I change the document object model. That changes. So I'm actually, but that didn't change the source code here. The source that it was retrieved to produce it, but I can change the document object model. And later in the class, we'll write code that will actually change the document object model. So we'll change this. We'll call this be going to lists yet again. So I can change the document object model. Doop. So you see it changed it. So when we change document object model, what we see in the browser changes, but the source doesn't change. Did I say that enough times? So let's click on this and go back to lists. Okay, so some HTML can be broken so badly so that it doesn't render at all. Whoops, that didn't work so well. I'll do a view source on it, and then I will let you figure out why this doesn't work, why this doesn't show. You take a look at the source, you figure it out. I hope this has been helpful to you. See you on the net.
Last month I was off in Boston for the 4th Annual World Wide Web Conference, and I had the opportunity to talk to the inventor of the World Wide Web, Tim Berners-Lee, and I asked him a little bit about where are we going with this web stuff. And we have just a little bit of footage from Tim telling us where that's going to be.
You didn't see nothing yet, but you wait until people assume the web. When the web becomes something you can assume, when the infrastructure is all laid down, and we have an information space, then it will be time for the next revolution, and who knows what that will be.
It's hard to imagine a greater revolution than what we've seen. I mean, I go to the smallest places and everybody's putting up a web page.
Right, but the web could only take place, the web revolution could only take place because the internet, which had been a quieter, smaller revolution, but that had been the internet itself quietly being deployed throughout the world, had happened because the internet was something people could assume the web revolution could take place. When the web is something you can assume, then maybe a cultural revolution, a nicer cultural revolution than the cultural revolution, perhaps, or maybe we'll find ways of doing things better that we hadn't imagined.
Pretty neat, Rich. One of the things that I liked about it was he just said his idea was the next step is something completely different, a cultural revolution as compared to just a little more technology.
Hello everybody, here we are at yet another office hours. This one happens to come from New Orleans, Louisiana. We have a couple students who showed up in only a very short, less than 24 hours notice, and I'd like to introduce them and let them say a word or two to you, their fellow students, okay? So say your first name and what you took, and say something to the students.
I'm David Miller. I took the History of the Internet course with my son here next to me, and I live here in Salida, Louisiana.
Okay.
Hi, I'm Abram Miller. Yes, I took both Python for Everybody and the History of the Internet course.
Cool.
It was really fun.
Thanks.
Hi, I'm Emily Ashley. I took Python for Everybody in 2015, and now I'm a software developer.
What were you before you took Python for Everybody?
I worked in the nonprofit industry with a degree in urban planning.
And you weren't a software developer?
Nope.
And then what did you do between the time you took Python for Everybody and were a software developer?
I went to software conferences to learn what people were building and what they were using, and I learned it.
And you took some boot camps?
Yes, I took a boot camp.
And then you were a software developer?
And then I was a software developer.
Yeah, so what I like about that story, even though I had to tell most of it, is start with sort of a Python for Everybody, do some real intense boot camps, and what I like is going to the conferences as a way to meet people and kind of get to know a field and then find your way into a company. So I think that's pretty cool. So that's all we have here from New Orleans, and the next one I'm going to be in Japan, I'm going to be in South Africa, and I'm going to be in Montreal in the next couple of months. So I hope to see you there. Bye, PB. That was PB, the PB Garrett, the CIO of George Washington University, walking by in the background. So cheers, and a friend of mine. So cheers from New Orleans.
Hello everybody and welcome to our lecture on cascading style sheets, CSS. Of course this follows right on the heels of our HTML lecture. I'm going to use a bunch of examples from webapplicationsforeverybody.com and you can just bring these up in your browser. I love to place everything that we talk about in the context of the request response cycle because that's the whole web applications for everybody. You of course are out here, you do a click, it sends a request, a HTTP request, maybe talks to a database, gets some stuff back, sends some stuff back. This is the request response cycle right here. And the thing that comes back is HTML. And then that is parsed, put into the document object model. And the thing that you then see, the pixels you see on your screen, are from the document object model. And so that's what we've been doing so far. And so far, in that HTML lecture, we just talked about this, what the format was when you parse the response. So what we're going to talk about today is we're going to talk about, in addition to that, we're going to go and pull another file, a CSS file, CSS, and that is going to inform the document object model, and it's going to change how things look out here. And so, you know, we'll have some CSS in the HTML, but we'll also have some CSS in separate files that make separate request response cycles. So we're going to be putting files like our HTML files in here and our CSS files in here. So we're going to be serving them a little bit. But mostly what we're worried about is sort of the form, how to make the DOM look pretty. And that's sort of what CSS is all about. So in addition, I would like you to install this thing called Web Developer from Chris Pedrick. Chris Pedrick has been doing this a long time, before there were even developer consoles in browsers. And it's funny that the developer consoles don't do what this does. I don't use all of its features, but it has some wonderful features for CSS, in particular turning on and off various styles. And so it's a great way to sort of dig through CSS issues in addition to the Web Developer Console. And you can do a lot of sort of fine debugging, but there's some real nice stuff with Web Developer. It's just a plugin for your Safari or your Chrome or your Mozilla browser or whatever. So please install that. I recommend it. And some of the assignments actually require it. So like I said in the HTML lecture, the HTML started out with, we were just amazed in 1995 when we could see a page with a gray background and blue links, and it was lists, long lists of links, and the links turned purple, and we would click on a link and another page would come up and we were like, holy mackerel, this is the future, right? And we were so happy. And our curiosity was piqued. We did interesting things. But, you know, in the 10, 15, almost 20 years since all that, it's become a business. And in business, the look and feel for the average non-nerd user, they don't care that there's a request response cycle. They just want to do a thing, talk to their friends or look up information or whatever. And so the CSS is in the middle of this time frame, that the ability to precisely lay things out and make pages beautiful became super important for the web to take its sort of leap into commercialdom. So if you look at the Yahoo web page, for example, this is just a screenshot I took a while back. They do studies as to how much white space is in between those two pieces. And they'll add a pixel and take away a pixel, and they'll see how their revenue goes. And so these user experiences, these visual looks and feels are highly tuned and highly sort of taken care of. And so CSS needed to be able to precisely have a pixel perfect layout in every browser. And so CSS is a very, very precise thing. HTML has become precise, but we don't want to do our markup and layout in HTML. I showed you tables previously, and in really early versions of HTML, we used tables to create look and feel, and that was never good. So one of the things you can do with the Chris Pedrick Web Developer plugin is you can show a page without CSS. And what you should expect when you see a page without CSS is it's sort of beautiful even without CSS. It's beautiful in a logical and a structure. And so here's my Web Applications for Everybody website, right? It's got cool stuff. It's got these little things that go over there. It's got the little border. The color's gray here, and it's a little lighter gray, and this wraps around, and it looks really awesome, right? Well, turn CSS off, and you should still see a page that you could effectively navigate. It's like going back in time to a simpler time of, okay, I want to see this. This is really a list of links at the end of the day, and there you go, it's a list of links. And the default is I've already clicked on lessons, so lessons is purple now. And here's this video, and if you scroll up and down on this, I mean, it's really fun to go to a website and, you know, turn CSS off and see how good their HTML developers are and how pretty it is. And so it's supposed to be pretty in a simple way. And what's nice about this is it really leads to good accessibility, meaning some people do not see the graphics, they hear the page read to them. And this way, this is how it's read. And the simpler and more beautiful and elegant your HTML is, the easier it is for a person who has reduced visual ability to understand your site. And that is, I remember the joy of hearing from people who were using the web and Gopher in the early days, how they all of a sudden could go anywhere and see anything and do anything in a way that that visually impaired people could never do for like hundreds of thousands of years. And it's joyful. And then what happened was we ended up with this really nasty markup, and then it was like the web was simple and they loved it, and then the web became ugly and nasty and HTML became nasty, and they're like, the world is horrible because now you go to all these cool websites, but I can't go to these cool websites because I'm visually impaired. And now we're back to that. We're back to beautiful HTML, simple HTML, and then beautiful web pages, and CSS is the matter. Okay, I think I've done enough advertising for CSS and accessibility and beautiful HTML. So ultimately, if you look at how this thing is assembled in your browser, there is an HTML page that is pulled down, and then there is CSS, sort of both inside the document. Sometimes there's CSS in the document. If you look at this, not that it matters, there's a little bit of CSS in that document, and then a whole bunch of other CSS that brings all the beauty to this. Sometimes it even takes some JavaScript and whatever. And so we understand that the HTML does not have the beauty in it. The beauty comes from the CSS. And that is part of what we try to do, is learn CSS. So if you're going to be like a coder and you're not going to be a graphic designer, you still need to know enough CSS so that you don't write horrible HTML, so that you know what a really good CSS developer is capable of doing on your behalf. And on large projects, including like Sakai project, which is an open source learning management system, this allows separation of concerns. And you can have people that specialize in the back end and the HTML, and then a web designer can, the web designer, so if you think of the developer, usually there's a back end, and then they generate, from the back end, they generate the HTML, and then the designer will build the CSS. The designer will often have skill enough to sort of tweak the HTML if the developer built bad HTML. So they kind of meet in the middle at the HTML, with the developer mostly being responsible for building the back-end developer. And then the front-end designer can then tweak the HTML a little and then tweak the CSS. And so the HTML is where the back-end developer and the front-end developer come together, but it means that you can have lots of people working, and you can develop highly specialized skill sets in larger projects. I know that my skill set is in this side. I am not skilled in this side, right? I can clunk my way through CSS, and everything that you'll see is my CSS, and you'll be like, whoa, that's not very good. And if it even looks pretty of mine, I'd probably use Bootstrap, and I cheated and found a CSS framework, and I didn't build it, I just did it. Now, there are people who are smart enough to build Bootstrap. They can build such gorgeous websites, and my job is to build beautiful HTML that then they can add CSS to and make it super gorgeous. So the CSS basic syntax is different than HTML, right? HTML is less thans and greater than. CSS has curly braces. I don't really know who invented the first. I should find that out and go videotape that person. But it has curly braces and semicolons, so it kind of looks like a little bit of C. And it's really a set of rules. And it's not sequential, although the order does matter, because what comes later has more importance than what comes earlier in CSS. But it's not like code that gets run. And so the anatomy of a CSS rule is that there is some kind of a selector. And in this case, the simplest selector is the tag that we want to affect. We want to affect the body tag. Now, there's only one body tag, but you could have a P for a P tag and say, I would like to do this to all P tags. And so it's implicit, kind of like SQL, in that a body tag means for all body tags. There's an implicit loop for the whole document. And we'll see how to reduce that later to it, so it's not always the whole document. But for now, a tag means a tag there by itself means every tag in this document. And then there's a series of rules, and so this is really when to apply. This is sort of what aspect, and there's a whole list of aspects that you can have, and then what you want to do. I want to make the font size 100%, I want to use Arial, and then sans serif, etc., etc., etc. Holy mackerel, my little pen is undoing itself. And so then these end in a semicolon, and you can have a bunch of these, right? You can have just one, you can have more, but that's the basic idea. Is a CSS rule is go find a part of this document and paint it. I like to think of this as like, go find a thing and then run a paintbrush over top of it that is this paintbrush. That is the paintbrush that you go select a piece of the document and then paint it yellow or paint it bold or whatever. That's kind of how I think about it. Now, I'll admit I am just I'm really a very weak CSS developer, and I need a cheat sheet. And if I'm going to do CSS, having this, even a single page cheat sheet, is super helpful for me, just because I don't use it all the time. And so the attributes like background color and the border dash bottom, you know, for me, they're all very self-explanatory. They're really easy to understand, or if you don't understand them, you just Google and you go Stack Overflow. But like for me, I'm like, is it border bottom or bottom border? I just can't remember that stuff, and so I just have to have a cheat sheet whenever I work. And this is one cheat sheet that I happen to like. And these are the kind of properties that we're going to be playing with. Color, the background color, how to align it vertically, how to align it horizontally, padding, which is space on the sides, etc., etc., etc. So there's just tons of CSS properties, and there's tons of great documentation on each of these CSS properties with little samples all over the place. And I have my own samples as well that I'll do some recordings and walk you through like line by line on my sample code as well. But this is the kind of stuff that we're going to play with in CSS. So up next, we're going to talk about how we connect CSS and HTML together. So welcome back. Now we're going to talk about how you use CSS within HTML, how you take these CSS rules and apply them to the various parts of HTML. And there are three basic ways that we do this. One is we take an HTML tag and use the style attribute and just put those little CSS key value, CSS settings right there, very close. The other thing is you can put it in the background of the HTML document, usually in the head area. And the other, probably most common thing, especially when the styles get large, is an external style sheet that's a separately loaded file with a separate request-response cycle. So we'll start with sort of the simplest but sort of least used of these things. And that is, like I said, you can put a style attribute on any tag. And you say any attribute, you say it's got a double quote and a bunch of stuff and another double quote. And in there is a series of CSS rules that are basically CSS setting like border style, colon, and then the border style setting that you want. And so in here I'm saying I would like a solid border, I would like it red, and I'd like it to be 5 pixels. And that effectively determines how that particular thing gets painted, right? In this particular one, I said font family monospace for that particular paragraph. So this paragraph is painted with a font family monospace. And so you can just put these things here. I put on the body tag, I want an Arial sans serif font. So the whole body is not Times New Roman, except for the fact that this particular one is monospace. And so these two tags are rendering opinions about what the font's supposed to be. But because this one is closer, the monospace wins here, but the Arial wins everywhere else because none of these other tags render an opinion. And so that's kind of the cascading bit, meaning the closer it is, the more priority that it has, unless of course they put important up here. And important is something we'll talk about later. You can make the farther away override the local, but it's not something you want to use too much. If you're using important, that's a trouble. But don't worry about important right now. Just imagine cascading means the closer, the higher priority. Closer to the tag the statement of CSS is, then the higher priority that it is. So another place that you can put the CSS is right there in the header, right? So instead of putting it on a tag, we can use a style tag in the header. And so here we have the header of the document, right? The body starts down here. And up here, we're going to set a set of rules. And now we're using the thing where we have to say which tag it goes to. So now I can say the body tag, even though there's only one body tag. We want a font family Arial sans serif. And because they're all inheriting from the body tag, then all the paragraphs inherit from this, and the headers inherit, etc., etc. So it's like body on down in this particular case. The header 1, which is this, is blue, and paragraphs are supposed to have a solid border, red, 5 pixels. And so border style, border color, etc. And that means that each of the 2 paragraphs here are away you go. And I'm going to dig into the anchor tag, and here's my little anchor tag, and I'm telling the anchor tag that I would like to have a green font, and I would like no underline. The default is to underline them. If you look at links, they're always underlined. I'm overriding that. And then I want the background color of that text to be light gray. And so this is a set of rules. All that HTML is down here, lower down, and there are no style tags. There are no style attributes on the tags because we have basically said for all paragraph tags, for all anchor tags, for all H1 tags, and for all body tags, and we put it up here in the top of the document. Now the problem is most websites have multiple pages, and this gets really frustrating after a while. So you really want to pull some of those widely used or repeated things out into a file and include them. And all we do is take pretty much that same set of CSS rules and we put them into a file. And in this case, we'll put them in the same file, same directory, same folder as the HTML. Although you can pull these things off of a website if you want, so http:// or whatever. But you put a link in here and tell it's a CSS, and it's going to be a style sheet, and then you give it an href, which is then going to pull this file in and sort of expand it as if it were right there in the middle of a style tag. And so it knows it's a CSS, and it pulls it in. So that's how you change your HTML. So now if we take a look at the next example, we see that in this next example, we've got a link, right? And down here, we've got no style. Ignore this little thing. That's how we're putting this little, don't ignore that page. But in the real stuff here, we've got this. We've taken our, we got our pre-tag. We've moved it in. We've got some things here. We got all that stuff that we've done, right? And if you look, here is that rules.css file. Rules has all that same stuff. H1, border color, a tag, all that stuff that we put in the head now is sitting in this rules file, and we're just pulling it in right here in one fell swoop, and it accomplishes the exact same thing. Okay? And so this, including in a separate file, is by far a superior way to do it than putting it in the head tag. So, but sometimes you have to change 2 things and you put them in the head tag. And it's up, you use all 3 of these ultimately, but generally you tend to start with a large amount of CSS in a file, and then you tweak in the head, and you might tweak on a tag here and there. And that's kind of how these 3 things tend to work together. And the whole cascading thing works out well. You can put the link first and then style tag second, and then it kind of overrides some of the stuff that are in the linked, and then you can have something on a tag which overrides the stuff that's in the head. Unless, of course, it says important. So, as the world went from hacking look and feel in HTML to, finely tuning look and feel in CSS, all these tags, paragraph, H1, body, they all had default styles that had kind of evolved, and links and all that stuff that evolved, and a lot of pages depended on those default styles working. And so they couldn't say, welcome to CSS, and now all the styles, a paragraph that's unstyled will look terrible. Not that they look great. And so we couldn't take the paragraph tag. Everything had a style. That's the problem. All the existing tags had something on them. So they had to make new tags, and the new tags that they made are the span and the div tags. The key to the span and the div tags is span is an inline tag that has no styling associated with it, no default styling. It is defined as having no styling, and the div tag is a tag that has no styling associated with it, but it's a block tag. And so we sort of use these to sort of mark text, but don't inherit, without inheriting any styling from some long ago 1993-94 defaults. And so the span tag is, span tag here, that's kind of broke over a line. The span tag has no styling except that styling which you add. In this case, I'm adding it with a style attribute. And the same thing is true for a div tag, right? The div tag, and also divs can be within divs. So this is a nested div, right? There's an outer div and an inner div. And basically you know that styling, the div has no style whatsoever, right? The span has no style whatsoever. So if you just put something in a span tag and you don't do any, you don't sort of render an opinion about what it looks like, the span doesn't change it. It just is, it inherits from whatever else is there. And so if we take a look at this, right? So here we have a p tag with a green border, 1 pixel border solid. Now the interesting thing is you say, well, did the paragraph tag have styling? It turns out it does. It has some margin in padding to make it look better, right? And so the paragraph tag is not an unstyled tag. It is expected to create blank space around itself. And so, yeah, we got, so the paragraph tag has a default style. It's supposed to have a default style. But then if you look at the div tags that we've got here, like this div tag, this div tag, remember, goes all the way down to here. This div tag, I just put a blue around so you kind of know what's going on, right? So this blue goes from here to here. But you can see right away that the div tags have no padding or margin or sort of little white space to make them look prettier. And that's okay, you've got to do that. You've got to add the padding and the white space. They just start with nothing. It's just a block, right? And the span tag, this one here, changed it green because we put a style color equals green right there. And okay, so we did that. And the div tag, and you'll notice, interestingly, these, because the divs I'm using end up with a 1 pixel border as their style, meaning they started with nothing. You can even see that if you look really close, it's impossible, but you can zoom in. This orange border, the blue border takes up space, and then the orange border's on inside of it, and that's 1 pixel wide. So I'm adding to these through the style attribute, I'm adding CSS to them, but they start with absolutely nothing, and they kind of look ugly when you just like put something in a div, it's like right next to each other, because they didn't want anything. And again, they're nested, and there's reasons, because we'll use divs to say, this is the main body, and then there's divs within the main body, and then this is the navigation, and this is the footer, etc., etc., etc. And so we have, divs are ways to describe blocks without adding CSS styling by default, and it's, as such, letting you define all the CSS for these things. So these are cool. They're like the non-tags, the untags, the tags that don't cause anything to happen but let you cause everything to happen. So they're really important. They're really important. So the next thing I want to talk about is making a sort of finer selection of which tags that you want to apply a rule to, right? A rule to. And so if we look at this tag right here, this is the body tag, and that basically says I want everything from body to /body, then everything inherits. So unless it's overridden, I want Arial sans serif to happen. Okay? And I can do that with a paragraph tag, but I want to show you this other thing. So there's a way to mark a tag. Let's find this one. Where's first? First right there. So there's this ID attribute. An ID attribute is an attribute that was added kind of specifically for CSS as well. And so you can only mark 1 tag per document with an ID. And then there's this class tag, and you can mark as many tags as you want in the document with a class tag. And the idea is like ID tags are for chunks, like main page, like left navigation, top navigation, or something that's only going to appear once on the page. And so if you want to sort, in effect, what # means is look through the whole document, find a tag. Where's div ID equals first? Where's that stop? Div, right there, right there. Find the tag that's got an ID of first, and then paint it with those rules. The class can happen more than once, but more space, let's see, class is more space here, that's there, and so that basically says, let's change clear and change color here. More space says look through all the document and find all the class. There's that paragraph. Ooh, do I not close that paragraph? Oops, mistake on my HTML. Here. Yeah, so that basically says change the margin left. That means shove this in, and change the margin right and shove it in. So we'll see all these things. And loud, and then you can also see a situation where when you put classes on, you can have more than one. And so this basically will respond both to the shout and to the loud class. Okay, so let's take a look at what this page looks like. So here we go. It's a little busy. So if we take a look at first, it grabs this tag here, the div tag is first, right? And then if we look at like more space, this more space is affecting this one, and it's shoving it in both on the left and the right, and that's because it's this paragraph more space. Okay, shout, let's find the shout ones. Well, we can see them right here. They're all the loud ones. So that is red. No, that's shout and loud. Oh, here's one that shout. Oh, entire has been shouted, and all has been shouted. So you'll notice these guys are lowercase, but shout is a text transform to uppercase. So you can even change the case of things. And then in third, for example, where's third at? Third says within. So this says find the third div, which is right there, and find all the p tags within the third div. This p tag and this p tag, and then apply a background color yellow to all those, which leads to this right here. Okay? And so # means find ID and apply. Dot means find class and apply. You can have multiple classes, right? Pull in the definitions from two classes, shout space load, go find the whatever's in CSS. And then you can kind of have hierarchical things, and this is quite useful because you don't have to get special. It saves you putting classes on. It saves you from putting classes on all the paragraph tags here. You don't have to do anything, but you're not affecting the paragraph tags outside here. You're only affecting the paragraph. I think of this as go find third and the paragraph tags within third, and then do something to them, and that way, otherwise you'd be making more classes than you need to be. And so this is a very well-liked technique for really fine-tuning your selection, your selector for CSS to touch only the things that you want to touch. So up next we'll talk about images and colors and fonts and a few other things. So welcome back. Now we're going to talk about making our stuff look a little prettier with images and how we can play with images, colors, and fonts. So CSS and images are a lot of fun. We can fool around with them. We can move them around. Actually, this for me years ago was the thing that in 1994 that made me fall in love with the World Wide Web. So what made me fall in love with the World Wide Web was the ability to take a picture of me, and I love pictures of me, and then float it to the right, and then I put a little border around here. And so that's what I've done with CSS. So let's take a look at how I've done that. So if you look in line here, the navigation, which I'll show you when I go through the code walkthrough how the navigation works. But at this point, at the end of the navigation is right here. And I put this image in. So if you were to watch this inline, the image is right there. But what I do is, when I say float, that actually, and there's other things that we'll see when we start looking at fixed and absolute positions, you can pull it out of the regular stream. And so this is like pulled out of here. It's as if it didn't exist. And it floats to the right, but then it's vertically aligned. So the next thing you see is this header 1. This header 1, oh, there's a typo there. I got to fix that. So I'll pretend that was an H1 there, but that's okay. So this header at Quarks mode, I should run this all through the validator to make sure I'm okay. But okay, so the top box of this CSS and images H1 is right here, and then this floats over, but then it top aligns. Now you can change this alignment if you like, but it top aligns here, and then it actually looks at the width, in this case the width of the picture, but you can also control the width up here in the CSS, and then it carves out this space, and then I do a margin of 1em. And so on M, you sort of sometimes wish they would put default formatting on, but then they kind of tend not to put default formatting on, because if they did, then you have to turn that off. And so I wanted some white space, and so I had to put some white space around it. And so I said I'd like a margin of 1em, and so that puts a little bit of space here and here and actually here as well. So you see that this lines up over there. And then that talks about what is a 1em. So 1em, I could have said 5 pixels, 5px, and that would have been fine. But 1em is basically the width of the letter M, roughly. It's sort of, it is a width that changes with the size and nature of the font. I think of it as the width of an M, and I think that might be a soft definition of it, but I don't think it's a precise definition of it. But that's what I did. So float right hoists it and sends it over here, and then shoves this over so that this text is now, it reserves this space so the text is wrapped, basically. And then I held out some space just for prettiness, right? And so that's like CSS is making it look pretty. Now, what happens here is sometimes you want to basically force, after this float has happened, something back to the left margin. And there's this clear equals all that says clear any floats is what it's really saying. And so it means that even though this, if it wasn't for clear equals all, this next paragraph would have been kind of up in here. And then maybe it would have wrapped if it was long enough. And when you play with this, you can resize it and see how the wrapping changes. But no matter what the size is, after the BR clear equals all, this is going to format back to the left nav, right? So that clears that hanging wrap, that sort of, but you don't have to. You could not do this, and then it would wrap and wrap and wrap, and then it would get longer and it would continue on. But if you want control over that, you can with the BR clear equals all. And of course, you can have images right in line, and this is just from the HTML bit here. There's nothing fancy CSS here. Images kind of are like big characters. I sized that one so it sort of fit nicely, and you could even make this a clickable link. But that's really just, this part here is just HTML, not CSS. But I could have, if I wanted to, change the width and the height of this. That'd be kind of fun. Make this guy be like the width of an M, and then you'd see it more like a character. So there's a bunch of colors, and the colors have to do with, there's the simple thing for us simple folks. You know, we just put in things like red and green and stuff like that, and especially if you're doing a developer and you're just trying to get basic stuff working, I often use colors in my testing, that like put the border red. I do that all the time to say, where was that div at anyway? So I'll throw a 1 pixel border around it, red border, like, oh, that's where it is. Although the Chris Pedrick plugin has a thing where it puts 1 pixel borders around everything for you automatically. But whatever. These are not necessarily most graphically beautiful colors, even though I like them because they're super primary in terms of primary colors and strong. You'll see that I kind of use those colors in my slides a lot because I'm not a graphic artist, of course. I just like, oh, the greenest I can be is good. So there's 16 official colors, and they're here. Once you get a little more sophisticated, you can use precise colors from I think this is a, I don't know, 32-bit. Yeah. So this precise colors are the ones that start with £. And so £, and these are hexadecimal numbers. These two numbers are effectively 0 through 255, but they're in hex. So hex is like A, B, C, D, E, F are actually numbers. 0 through 9, this is actually 10, 11, 12, 13, this is 15. And so E is bigger than 9, and F is bigger than E. But basically these are 0 through 256, that's a three tuple of 0 through 256 numbers. And so the more red you put in, the higher this is, the more green you put in, the higher that is, and the more blue you put in, the higher that is. So RGB, red, green, blue. And if you're playing with like a slider inside your UI, you might be changing this, but you're just changing these numbers ultimately. And so you can find these things. You know, so white is all Fs, and so if you turn it all on, it's white. If you turn it all off, it's black. The absence color is black. Red, green, so you turn, that's max, max, and max, and so you can make sort of a pure red, pure green, and pure blue. Picking these advanced colors is sort of way beyond my ability as a graphic artist, and people will pick colors. There are sites that help you pick palettes for your pages, etc., etc., etc. There is also a sometimes these colors can have a transparency, and there's a fourth set of two numbers that have to do with how transparent the color might be. So fonts are also important. The default font is a Times Roman because that's what computers had in 1994. And I think they're ugly, especially on screens. They're not so bad on print, but they're ugly on screens. And so I tend to want a sans serif font. It's too bad that and maybe they have changed on some browser default for sans serif. I just change it to sans serif all the time. I want. Now, if you look at fonts, the font family is kind of a special tag in that you ask it a set of fonts, and what you're really doing is you're setting a priority. And the problem is depending on whether you're on Windows or Mac or which version of Windows or which browser or what fonts they've had installed, fonts might not be there. And so what you basically do is you basically say, okay, I would like this. I think this is a Microsoft font. And if that font's not there, then I would like this font. And I think that might be also a Microsoft font. And if that font's not there, then there's Arial. See how much I know about graphic arts? I have no idea. I think this might be a Mac font. And if that font doesn't work, default into the fallback font sans serif. And there is always going to be a serif font, Times New Roman-like, sans serif, Arial-like, monospace, which is Courier-like, cursive and fantasy, which are whatever. And so all browsers are supposed to have those fallback fonts. And so you tend to see them here at the very end. And so when you see me, I usually will say Arial sans serif or something like that just to get sans serif. Although it's quite common. The more sophisticated a page is, the more likely. And the other thing that's increasingly the case is people are downloading fonts and having special beautiful web fonts, and then they download them and then they put that font in here, but then they probably still have fallback fonts. So font family is kind of a weird and unique and glorious thing that leads to some really gorgeous web pages because so much graphic and arts work is going into making web pages beautiful, and we're going way beyond the operating system installed fonts and having pages that download their own fonts. Things that you can do is set the things to bold, italic, text decoration. Remember, links have underlines and we can turn them on or off. Font sizes are kind of troublesome in that you can set them to pixels, but then you're in danger if you get to a certain kind of a screen size or people start zooming the screen and stuff. And so you can tend to use these relative ones, but they're not as guaranteed as you might like them to be. And so just these are a little bit tricky. Absolute font sizes are a little bit dangerous. I tend to just go like, here's my font, here's the one that's a little larger, here's a little smaller if I need that. So most of the time I'm tending to do things that are like smaller. If I'm putting like a copyright statement and I don't want to distract from the main page, I'll just make it a little small. I'll say, okay, make this small or extra small. And what if it doesn't turn out to be that much smaller? It doesn't matter. I'm just kind of trying to so I'm not an expert in how to use those. I tend to use them as simply as I possibly can because they're not as predictable as it would be nice if they were. So links were a big part of the early web, and it's called hypertext markup language, hypertext transport layer, hypertext. And so links got really special treatment. They used to be blue before you clicked on them and purple after you clicked on them. The blue was to jump out at you and say, please click me. And the purple was to say, I've been there, because a lot of what you did in the early web is you wandered from place to place to place to places like, oh, I found a new thing. Let me explore this. And so you were always like exploring by clicking links. Once we got to the point where people assumed the web, these links didn't need to be blue and garish colors to teach us these things because people just clicked on everything. And so it became more important to make things pretty. So we have a lot of control as to how we style links. We can say the A tag, we've already colored an A tag with just the A at the top. You can basically say an unvisited link is supposed to have the color black, After the visit, it's supposed to be gray. While you're hovering over top of it, it's supposed to have text decoration and none and be black, white with a background of navy. And then active is not so heavily used. It's once you've clicked on the link while the page is loaded. So it's a way to kind of, you know, maybe disable it or turn it a color so people think, oh, I better wait until this next page loads. And so when I do the recording, you'll see this. It's a lot easier to see this dynamically. And so there's a whole bunch more samples that I have, and I'll record some walkthroughs of every single one of the samples, and so you can take a look at that at Web Applications for Everybody or in the recordings. So this has been a zoom through CSS. You know, CSS is quite the art and science, and it's evolutionary. I mean, people specialize in this. They're very good at it. It's a modern form of graphic arts. The basics are there, and I think every programmer who does anything on the web should know the basics of HTML. You know, they keep moving things better with things like nav tags and Bootstrap, etc. And while there will always be like edgy new things in CSS, and so sometimes you'll see CSS with like these Moz fields, which are for Mozilla for the Firefox, but people are always pushing that boundary. And before you couldn't put rounded corners on things, but then the browsers added extensions to put rounded corners on things, and then everybody kind of agreed on that. So CSS is kind of always going to get better and better and better, because for the mobile and desktop, they really want to create as beautiful experience as possible and use standards wherever possible. And so the basics are there. You can do so many wonderful things, especially if you pull in something like a Bootstrap that just kind of cleans up the rough edges of HTML and makes it generally pretty and takes a lot of responsibility off of you. But you can certainly make a lifetime study of CSS if you like. So I hope you found this useful. I will see you on the net. Hello and welcome to Web Applications for Everybody. We are taking a look today at cascading style sheets. You can download the source code and unzip it on your computer if you like, or you can browse this code and just play with it in the browser, because it's all static content, so it's just as easy to play with it in the browser. And of course, we're going to want to take a look at this in the developer console. It just makes a lot more sense to get into this, and so here we go. We're taking a look at CSS. There's a couple of ways to do this. We can see here, we can see the style attribute. Style color equals blue, and there's all kinds of various CSS parameters. Color is the parameter and blue is one of the values, and you gotta look all these things up. One of the nice things that we can see is we can see over here, as we move between elements in the document object model, we can see what the CSS values are. And so Arial Sans, like for example, this is cascading. The body on here is Arial or sans serif, and that means an Arial font if we can get it. Sans serif is a fallback font. And so that this H1, this little bit right here, this H1 is being colored. This is ours. Browsers have their own default, so display block, font size 2EM, which is twice as big as the rest of the font, etc., etc. And so this came from the browser, and then this came from the style sheet. So this is cascading, and the bottom ones here are this is the most important one because this is the one we said that's closest, and that's how the cascading works. Yeah, we already saw that. We already saw that. And then the cascading is, again, we take a look at this little guy here, right here, and so the closest one is we want a monospace font family, but the body said the font family is Arial and sans serif, but this one has been overridden, and we can kind of see that, and that's why this particular text is monospace. Another thing we can do is we put border style. Now when I'm working with this stuff, I tend to remember border a lot because it's a good way for you to mark something out and say, what am I doing here? And we'll see, like when we're moving text around, border, solid border, a red border, and a 5-pixel border. And so that's what we see. And you can also see that there's some extra padding around there as well, or some extra margin. And margin top, that's another one. I'll scroll this up a bit. Margin top throws 5 ems of space above the text, and so this is a normal paragraph. We got 5 extra M's. Now what's an M? M is the height of a character in the current font. And so M's is a really convenient measure. There's M's and pixels and percent. So margin before, that's 1 M over here. The paragraph already has an M. Margin before, and then, well, hang on, come down here. Down to here. We've added the margin top. So this margin top overrode the margin top that was part of the paragraph tag automatically. So that's these style rules. So let's keep on going. While this is technically possible, this would really be overwhelming to put a style on every tag. And so one of the things we tend to do is we want to put style rules that are generic. So we'll say we would like the body tag, and this is a style rule. This is the selector, body, and then font family. And again, font family works as please give me the Arial font, and if that's not available, give me sans serif font. Curly brace, H1 tags. Go through the whole document and paint H1 tags blue. Go through the whole document, find every paragraph tag, set the border style to solid, border color to red, 5 pixels. So you see that every paragraph, and we're going to change our anchor tags to have green and have no text decoration because they're defaulted to have underscore, and we're going to make the background color light gray. Why? Just so we see it, so you can see that particular thing up there. And then if you look down into the text here, we have paragraph tags and an anchor tag, and no style equals down here. So what we've done, ignore that little part there, that's what puts this little thing in the corner, so that's not what we're talking about. We put no style tags whatsoever, and we put all the style tags up here, but now we've also done something that all the paragraphs have to have the same style, which sometimes is what you want, and sometimes it's not what you want. Now what happens again now, if you have multiple pages, as we have here, it gets a little tiresome to put this text in every page, and so what's really common instead, so now we have the same basic rough paragraph stuff here, nothing in here, we have a pre-tag, of course, we have a paragraph tag, there's no style equals on these things, but up in the head we have one line right here that basically says, let's take a look at this style sheet, and if we were to look at the style sheet.css, it is in the same folder, rules.css. It's in the same folder as that HTML file, and it's exactly the stuff we had there. It's just a set of selectors and then a select of key values we want, color blue, border style, border color, etc., etc., etc. And so it really is the same as what we showed before, except now that we have to put this into every file, and you'll see we'll put this now from now on in every one that I'm looking at. And so, but now our problem is that we've done something with this to do all the headers, right? All H1s, all paragraphs, but we need better ways to mark text. And so, we have these tags, and these tags that we use just to put handles on. In the old days, like this paragraph tag has this border. See that has the margin up there. I mean, it has the border, but it has this 1M margin. That's that space that you're seeing that makes paragraphs look good. I mean, it's not a bad thing. And so if you look at that, we have all these colors. We've got the strong tag. By default, the thing uses a serif font. I don't like that. So let's get down to here, and this. Well, let's just look at it here. The span tag, inspect element, right there. Okay. So the first thing is the span tag is an inline tag that has no styling. The problem is before CSS, which is a long time ago, all these tags had default styling. But the span tag is an inline tag with absolutely no styling whatsoever. And then the div tag is a block tag that has no styling whatsoever, and it can be nested. So it's kind of like a paragraph tag, but it has no styling whatsoever. Now I've added a 1-pixel style, and you'll see that these div tags don't have any extra space, like the paragraph tags came with space. Now some people would go and turn off the space on a paragraph tag, and there's even CSS files that you can to take all the styling, default styling off tags. But you'll notice these divs don't have any space. They're really kind of a block. When I put these pixel on, you see the border. If you look really close, you'll see that there's a 1 pixel blue line and a 1 pixel orange or Santa line right there. But the divs can be nested, and they don't themselves start. So you'll notice that here they don't start with any kind of formatting that comes from the browser, whereas if we look at paragraphs, there is formatting that comes from the browser. And so the div tag and span tag are just are ways to put handles around blocks of text or chunks of text and then style those. But then we still have to figure out how to grab our handles and make it so that our styling doesn't just touch one thing. And so here I've got a couple of things. I've got the body tag, and I'm setting font family. You'll see me do this all the time. And now I have a pound sign, and this says go find all the tags named body. This says go find all the tags with a attribute of first, ID equals first, ID equals second, and then class and shout. So if we take a look at the text, there is the notion of an ID tag. Okay, an ID tag that is unique within the document. So we're going to call this div first. We're going to call this div second and this div third, and they correspond to first, second, and third. Okay, and so first is monospace. What is it? First is monospace. Second is green. So everything that's in this block that's second has been green. And then, but you can only have one ID named first. But class you can have all over the place. So we can have, we can put the more space class on a couple of different tags. So this tag, more space, all more space does is shove it in from the left and the right, margin left and margin right. So it kind of pushes this in. And so you can put this on here, you can put it another place, and so the more space pulls in something here. So here's another paragraph that's got more space. That one has more space. This one has more space. See that one? And so you can put more space on as many times as you like, and then div third. Right. And so the hierarchical section means, in this case, this one's a little bit, and loud is red, so where's loud at? So let's inspect that one. Inspect element. Yeah, so that's the loud is not only red, but it's also forced uppercase, text transformed to uppercase. Shouting and loud, and you can have more than one class on on a tag, and then you can be even more precise with your selection. This is basically, this says find a third ID, and then only paragraphs within that tag third make their background color yellow. And so that means that background color yellow does not apply to this tag, it doesn't apply to this paragraph, doesn't apply to this paragraph, but when you see div ID third, we have selected this paragraph, and they have a background color of yellow. So continuing on, let's take a look at a simple navigation bar. Now, there's this nav tag that's an HTML5 thing, and if you look at most navigation on pages, let's go to the next one. They're pretty and they got colors and they move around and stuff. But what we want to be careful when we build our HTML for these kinds of things to make them very, very simple. And so what I've got is a navigation is usually, we describe it, we use a nav tag, which is a block tag that says, hey, this is our navigation, useful for screen readers, etc. And then we're going to say we're going to have a list of two links, and so that's what we're doing: unsigned list, unordered list, and a list element that's just no paragraph here, just an include, just a anchor tag, and we're going to put a class equals back and class equals forward, so we can style these two things differently in the future. And so this is what this looks like with no CSS whatsoever. And so this is a nice, elegant, clear HTML. And so if you were just looking at this HTML, like a screen reader might be looking at, you can see what this really intends to mean. Now, then what we do is we add a little bit of HTML to this. And so for now, we're just not going to bother, but in navbar.css is the HTML or the CSS that makes this pretty. And so there's a whole bunch of stuff, and we'll come back and take a look at that in a second. Okay, and so there's our styled navbar. So I'll come back in another video and pick up right here. So welcome back. Now we're going to take a look at some more examples. We're not going to, the one thing we're not going to look at is exactly how this navigation bar works, at least until a little bit later. So the next thing we're going to take a look at is how fonts work. And there's a couple of ways that you can put fonts into a file. There are default fonts that every browser is required to produce, like serif, sans serif, monospace, cursive, and fantasy. And so you don't exactly know what's going on, but they're often used as fallback fonts, and so you can have those. There are any font that is on the system, like Arial or Helvetica, and so if you're going to use Arial, not all systems have Arial, although most of them do these days. And you have to have more than one font. Now, another thing that's really common these days is to include a font somehow. You find out about a font, and here's a Lotto font. And you go look it up on the web and you find, oh, include this. And so I included this link because I found this really cool font, Lotto. And this extends the browser. The browser then learns about this font, it downloads the font, caches them, and keeps them in the browser. And then I can make a font that's Lotto. But just in case I'm off the internet, and I can't download this thing, I have sans serif as a fallback for Lotto. So Lotto is a fancy font, etc., etc. So there's Arial and built-in fonts, etc., etc. And so that's how fonts work. Colors, there's a lot of cool stuff about colors. There's a couple different things. We'll ignore the nav for the moment. I'm just using span tags here. There's some default colors in the earliest of browsers. These days we have all these fancy ones, and you can go look these up and you just Google for HTML colors. And there's a bunch of names, and then they're consistent across browsers. But there's like 12 or so really solid names that are in all browsers since the beginning of time. But more modern browsers have a better palette of colors. Although really good graphic artists want to have much better control of colors. And so this is, the pound sign says that this is a hexadecimal number, and it's got 2 digits. Hex means they go all the way up to F. So F is A through F are numbers. 8B is the red level, 45 is the green level, and 13 is the blue level. And so this is a brownish color. And then there's what's called web safe colors, where you just have, this ends up being 88, 44, 11. But it sort of reduces the number of potential colors if you were mixing colors from various sources. And then in HTML5, you can see this color picker when you have a form, which we'll talk about in a bit. It's a color form for modern browsers. And then you can pop up with this button, a color picker, and I've got a little thing to print out what the color would be. And so it just, when I pick the green, it basically puts 00FF, that's red, green, and blue. It puts that into this thing, which then the program could use. Could read this, or JavaScript could read it, or server code could read it. But right now we're just kind of playing with the picker, and we pick a different color. And so that magenta is all the red, none of the green, and all of the blue. And orange is all the red, some of the green, and none of the blue. So those are all just really strong colors. And so that's what's called an HTML color picker. Anchor tags. In the old days, anchor tags were kind of funky. They were blue if you hadn't yet visited them, and they were purple if you had visited them. And so this one I've obviously clicked on. And so we have a whole series of styling mechanisms that we can have. If we take a look at these, I have put these all inside of an ID tag of cool. So this is basically saying find the ID tag of cool and then style anchor tags to make them a font weight bold. So let's take a look here. So I got one paragraph that has this one here, and then I have a paragraph with an ID tag of cool, and that's basically so I don't have to style. Usually you wouldn't say I'm only styling the anchor tags inside of, you know, if I'm only styling the anchor tags inside a tag that has an ID of cool, but that way I can have the default on this one. That was my way of keeping the default. So normally you would just say A. So A links is red. If it's visited, it's orange, and so this one's been visited, so you don't see the red. It means it's unvisited. Hover, you can change it, so you notice when I hover in, the text decoration goes away, the underscore goes away, and I have a color of text font color of white and a background color of navy. And then there is one last moment. Can I click on this one? Oh, that will click. There's one last moment that's really hard to catch, and that is the moment of active. If the web was slow and you clicked on it, then it would tell the user, in the old days this made more sense, that it would turn red and then blink away. I don't know if we'll even see it. It kind of saw it, you sort of saw it. And so there was a color while you click on it. Yeah, there it was. You might not see it in the screen, but that's what the active means, is you've clicked on it but it hasn't yet been retrieved, and then like a moment later the whole page goes away. Another thing we can do is we can play with images, okay? And so here is an image. One of the things that's really fun to do with images is float them to the right or float them to the left. And then what happens is that the image, the text is drawn around the image, so it wraps around the image. And you'll notice where I floated this left. Oh, I kind of got rid of everything. I floated it left before the H1, and so what happens is the H1, top of the H1 and the top of the image line up, and then all the text afterwards, wraps around it. And so you'll notice that I've got the image first and then the H1 second, and but the float sort of disconnects the image from the normal line of flow, floats it over, and then takes this next thing and the next paragraph and saves the space for the image and shoves the margin over so that it comes over here. Now once you start floating images, you got to learn about this clear equals all, because if we want this next paragraph, like this one, we don't want this paragraph for whatever reason to be on the image. Now if it goes far enough, you see this paragraph here moves back to the left margin, and then this next one starts there. But if the browser is wider and the text is, there's not so much text, we don't want this to be up in here. And so you say BR clear equals all. So between this paragraph and this paragraph, we do BR clear equals all. And you can put images right in the middle of the text like a character. You don't have to have them by themselves. And you can even make an image that's a clickable link. And so you can click on that image. Now, C in CSS stands for Cascading Style Sheets, and so the idea is that the tag that's closest has more precedence than a further away tag, unless you say important, okay? So here we have some style. Here we have a body tag, border style of dotted, red, and red, a border color that's red and important, and border width that's 5 pixels, background color, which is kind of a grayish, that's that gray, and an extra padding, so we've got put some extra padding all the way around it, and extra margin. And so if we take a look at this, we take a look at this paragraph right here, we see some things, and we take a look at what we've got. So we've inherited this, we got a border style of color, it wants to have a border color of green, but it doesn't because it says the border style is solid. So the border style of solid is down here in the second style tag. So the second style tag has precedence because it's closer to the paragraph. And so we tried to say border color green, but that one was overridden. So otherwise this would have a solid green border, except that this red important is up there, and so that the red important wins. And you can see it really easily here that this was overridden, and this is the one, this border color from the previous one is taking precedence. Okay? And so this is the second one, and it would normally take precedence over this one, except that this important is sort of like it is overriding the one that's closer. So another example of closer is the style tag. Okay, and so here we go. This is border. This is we're putting this. I mean, style attribute. We're saying border style equals dash, border color equals blue, and so the border style equals dash holds on, but our attempt to make the border color blue is overridden again by the red important, right? So important is up above that. Okay, and so this dashed is winning and this blue is not winning because there is an overriding red above it. I mean, there's an overriding red important above it. And so if you want to override an important tag, yay, we override an important tag right here. We basically say I want a border style dashed. Come over here. Border style dashed, and I want the border color to be blue, and this is important. So now this one's closer, and it says important. So among all the important ones, the closest important one wins. So now we see that the border color actually takes here, and we are overriding the far away. This one here from farther away got overridden because of this one. And so you can do that. Now, in general, while I've shown you how important works, you shouldn't do too much with important because usually you're taking CSSs from other places and you're patching it, and you can end up with really inconsistent looks and feels with important. Usually when you see important, it means kind of something's wrong and you're fighting with a framework or something else. So let's take a look at some blocks. And so let's see, background color, my H1's colored blue. And I'm going to put some padding and a margin. And so div P and H1 sort of live in a box. You have sort of like the actual, so let's take a look at, say, this paragraph right here. That's probably the thing to do. This is just a plain old paragraph. Nothing special, right? There we go. That's a paragraph right there. So let's talk about the padding and the margin, right? So working from the inside out, there is the actual text that is, and it's wrapped. And so if I change the width of this whole block changes, right? It gets taller and narrower. But at some point, the inner part, this inner part right here is, the inner part is however large it becomes. And that, in this case, it's 318 by 38 pixels, right? And then what happens is we sort of work from the inside out. So I'll go down here and see the box model. So the inside of this, the actual text is 619 pixels by 19 pixels. And then I've asked to add 10 pixels of padding, and that is between this sort of text and the border. And then the border itself has a width, and I specified that border width. Right, I said I want a 5 pixel border width, and so the border width takes up 5 pixels. And then there is, outside of that, there is margin. And so margin is space. Notice that the padding and the text itself has the background of the block, border has its own color, and then the margin has the background of the color of the background document. Okay, so this is the margin here, it's the color of the background document. Right, so content, padding, border, margin, and then, but the padding inherits from the text in the box from a background, and the margin inherits from the background document. And you can have different background colors, etc., etc., etc. This is an, oh, by the way, this is an ordered list that we've got going on right here. Okay, so that's CSS boxes. We can change the size of these boxes. It's a little tricky. So and so here we have auto sizing div where we're not mentioning anything about the height. If we take a look at the box model here, we see that this one is simply, you know, the size of the text plus the padding plus the border plus the margin, and that's sort of how that box gets sized. You can say that you want to set the size of the box. Okay. So I'm going to set that to be 3 M's. 3 M's is 3 characters. But if you look, I have too much in here. And so you'll see that even though this box is 3 characters tall, it's 4 lines, and so the 3 would fit, but the 4th one doesn't, and so it just overflows. You can also, so 3 M's, it's good to set sizes in M's when you can, because then if someone makes the screen larger, oops, I didn't mean that. This one, if someone makes this larger or smaller. Now the problem is, well, I don't know about it, if we'd call it a problem, but in the old days, if you set a height in pixels and you zoom the screen, the box where you set height in M's would zoom, and the one that you set in pixels wouldn't. But they decided to make zooming work, otherwise so many people made boxes in pixels that they made it so that the zooming would pretend that pixels are really M's. So it kind of converts pixels to M's, but you're supposed to avoid using pixels when you really mean characters. If you want 3 lines, don't look at your font and say, I'll make this 40 pixels in order to do that. And again, in this box, we still have overflowing text. And so we have a couple things we can do when we want to change the overflow. We can tell a box that we would like the overflow to make a little scroll bar. And so here's that same stuff, and you can see we got a little tiny baby scroll bar, and it didn't sort of blop out of the box, right? And even if the scroll fits, you see you get little scroll bars, but you can't scroll it because there's only 1 line there and it fits in the box. And then another thing that you can do is you can just say chop it off, right? Chop it off. Now one thing with some JavaScript, you can put a little more here and that expands the box or pops a bylog or whatever, but we're not going to worry about that for now. For now we're just saying overflow hidden means lay this out as much as you need and then, you know, throw this text away. It's just not there anymore. Like, where did all this text go? But it doesn't show it because we told it to chop it off. Okay, so on to the next one. You can move these things around. This is a little messy. There we go. Let's make this a little different. Okay, so by default, I'll show you the HTML in a second for this, or maybe just do view source. Let's do view source. Okay, so if you just say div, they just follow after each other. And I've given them border because to make them a little picture, give them some border, some padding, and some margin just so they don't touch each other too much. So by default, blocks so I got a little border both on all sides and a little bit of space between them and a nice. So they, you know, however big they get, this one gets bigger, and I put a width on them just so that they wouldn't move around, and there's a width on it right there, 10 M's, 10 characters wide. So they just follow each other. And then you can say, okay, you know, this block right here, this number 3 would lay out right here, but I have told the number 3 block, that I want to move relative to where you would normally be 20 pixels to the left and 20 pixels down from the top. And so this block, it lays out exactly as if it belongs right here, and then we shoved it over and moved it down. And it came over top of the number 4 block. And so there you go. And so the text afterwards, this number 4 block, just comes next, and it's basically, it's as if this laid out without the position relative, and then this came afterwards, but then we sort of just shifted it, and that's why this overlaps, because this corner here is where 3 would have finished and with a normal layout. So you got to be careful with relative. I mean, you don't usually want to make it so that they sort of blop on top of each other. Okay, and so now we're in 4, and then we're going to look at 5 and 6. And so 5 is what's called fixed text, and you'll see the 5 comes right here, but because I've got this as position fixed, this is fixed relative to the window. So it's 20 pixels up from the bottom and 30% of the way from the left margin. So you can see that this is 30% of the way from the left margin, and it's the bottom of it is 20 pixels up from the bottom. And you'll see that that green box never moves, and that is because the fixed text is relative to the window. And that's how we actually get this little link that never goes away. And so there's a link that never goes away. Absolute text, I don't know why they call it fixed and absolute, but absolute text is a little bit different. it's relative to the parent element. And so in this div right here, the parent element is the body tag. And so when it's saying I would like this to be 40 pixels from the top and 30 pixels from the 30% of the way from the left, that means it's relative to the body tag. And so the body tag starts up here, and so this has been sized 30% from there and whatever, 40 pixels down. And notice that that one goes with the scrolling, right? So that one goes with the scrolling. And you'll also notice that between 4, 5, and 6, there's like, it's as if there's nothing here. But if you look at the document, 5 and 6 are sitting there. And that's because they are plucked out of the normal rendering stream, and so they don't take up any space between 4 and 7. So they don't count in sort of the normal layout as the page is being laid out. And so, here's number 7, for example. Actually, number 8. So here's number 8, and so this is positioned relative with a left of negative 1,000 pixels. And so in a sense, this stuff right here has been shoved off the screen to the left. And so that's how we often will put text on that nobody sees. Just move it to the left. But it takes up the vertical space anyways because it was just relative. It would have normally laid out here, but the left shoved it over there. And so that's basically some layout. And so now we're going to talk about z-index. Let's take a look at the source code here. And so z-index is the ability to what happens when things overlap, okay? And so this is a div. Number 1 has a z-index of 100. Number 2 has a z-index of negative 100. 0 is sort of the background document. And it works out pretty straightforward. And I'm just moving these so they have to lay on top of each other. You know, and so you see this one here is negative 100, so it's kind of behind everything. This one is positive 100, so it's in front of everything. And this number 3 is, yeah, it's in it. I just put that there to be in the original document with no z-index whatsoever. And so it's behind this thing that has a z-index of 100. Okay? And so that's z-index, like this little note way over here by the right margin says, z-index is kind of tricky. Everyone tries to be on top. And you'll put z-index of 100 and then you'll find that the navigation put itself as z-index of 1,000 or something like that, right? And so z-index is hard to debug and hard to fiddle with, but at least now you know that z-index is when things look weird and they're overlapping in weird ways, z-index is what you're taking advantage of. And so now we'll take a look at kind of how this navigation works, okay? And so here's a couple things that the navigation does. The body, of course, is font family Arial sans serif. The navigation bar itself, I guess I'll do a view source on this so we can look at the navigation bar. The navigation bar itself, this block, it's a block tag, right? That has a position of light gray, and I've given it a height of 3em, so it's like 3 lines. And if I zoom this page in and out, right, that gets bigger and smaller. I'll get back to 100%. It's 3 lines tall, and I guess I didn't need to say Arial sans serif. I did that in case someone else wanted to change the body tag, I guess. So then I have I want UL tags within the nav, and that's one of the nice things about this nav being its own tag. I can style just the ULs inside here. Okay, and so what I'm doing here is I'm saying I don't want any little circles, little dots, little bullets. I don't want any of those. I want to take away any padding that it has by default. This is one of those things that this UL inherits. Let's go down here and take a look at this, and you'll see that this UL right here. So what's happening is this is the things that I've said in my CSS, and I'm overriding some default things. It's normally would be display. It's a display block. That's okay. And so I overrode the list type style. And continuing on, the list item inside of nav, that's what it is, nav and list item. I wanted to make that, so let's inspect this guy right here. inspect. So if you look here, and I've got a class of back, and so I have this positioned absolute, which is relative to the parent right here, and I have it 20 pixels to the left of that upper left-hand corner, and so that's how this comes over here. And then I have it colored dark blue because it's a nav, an anchor tag within an anchor tag within an li tag within a nav. That's what this is saying. Dark blue text decoration of none, and so that's where I get this color blue and no underlines. And then this is the dot back, and so I use a back class to position this right here, and then I use the forward class to position this relative on the right, 20 pixels from the right. And so that's how I make the navigation bar work. And CSS is really a lot of work. We learn a lot about CSS, and this is just a really short introduction to get you a sense of what the basic mechanics of CSS are. Thanks for watching.
So I was laid off or fired, depending on your, how you want to describe it. And as it turned out, it wasn't really possible to take my place. And I continued as a volunteer, and the Netscape engineering organization, it was very clear whose leadership they were most interested in following. And so we had to work out a way in which the management at Netscape AOL that remained and I worked out sort of a way to work together enough so that they could ship the product they wanted to ship, but that I continued to lead the project. And I think that was a surprise, not so much to me, I think. And so I worked as a volunteer on the Mozilla project, for a number of years, including the years in which we shipped our first product, which we called Mozilla, and which we were very proud of technically. And for its day, many people were surprised at how good it was, but it didn't have a good user experience. But eventually I ended up working on another open source project with Mitch Kapor for a while, and that was lucky. He had started this open project and reached out to talk to Brendan and I about it to learn something. And the day that he was scheduled to come down and talk with us was the day that I was laid off. And so it was an odd set of timing. By any chance? Yeah, that was Chandler. It was pre-Chandler, but OSF. So I worked on that for a while, and Mitch was always a supporter of Mozilla, even before Firefox, when he didn't like the product. Right? But he recognized that we were an important part of the ecosystem. And that went on until 2003, when AOL decided to stop investing in the client almost completely. And fortunately, they knew that just killing it wasn't good. They knew enough about Mozilla and the name and the brand to think it would be good to do something with it. And so eventually, I ended up working with them, and some of the people there knew Mitch as well. And I was working with Mitch, and they knew him, and so we all, spent a chunk of time trying to figure out what was possible. And my partner Brendan was still at Netscape, very eager to make a move, and many of the key people we wanted were also desperate to keep working on Mozilla. And so we ended up getting a $2 million seed money from AOL, and Mitch was helpful with that, and a few other things. The trademark, name Mozilla, and the 4 giant servers, which were so important to us at the time, and which had taken us almost 18 months to get through the purchase cycle at AOL. And so I think we still have those boxes sitting around because they were so important to us at the time. And so in 2003, the Mozilla Foundation was formed.
So hello everybody. We're here at ITT Tech Fest, and this is wonderful. I gave a lecture here, but then we've been here for about 45 minutes to an hour just talking and asking questions just outside the lecture hall. I keep worrying they're going to kick us out because we're making so much noise during the next lecture. But I just wanted to say hi and give everybody a chance to wave and say hi to the rest of the class. Okay, so here we go. So we'll say hi.
Hi.
Say hi. You can say hi.
Hi.
What's your name?
Bhuvika.
Okay, we'll come back and talk to you later.
I'm Pankaj.
Oh, nice to meet you.
Hi, Komal.
Hi, I'm Advait.
Hi, I'm Shreyans.
Oh.
Hi, I'm Shreyans.
Okay.
Sushmita.
Okay.
Hi, I'm Anan.
Yeah.
I'm Shabazz.
Otherwise known as TensorFlow Man.
Hi, I am Himanshu.
Hi, I'm Dinesh.
Hi, I'm Sumit.
I'm Manali.
Ritik.
Hello, I'm Samantha.
Hi.
I'm Nisha.
Okay.
Hi, I'm Samar.
Go blue.
Go blue.
Hi, I'm Anand.
Yeah.
Hi, I'm Vipul.
Hi, I'm Anuja.
Yeah. How are you guys back there going to be in the video? Okay. Don't run away.
Hi, I'm Devang.
Okay. Hi, I'm Aniket.
Hi, I'm Abhay.
What's up? I'm Jay.
Okay. Let's see.
Hi, I'm Prince.
There you go.
Hi, I'm Yashwardhan.
Yep.
Hi, I'm Vijay.
Okay.
Hi, I'm Neelam.
Yeah. Okay, did we get everybody? Okay. So this is Chuck, but here we're in India, so we have to, this is sort of an American thing, because in India, there are cows. So we're at IIT Bombay, having a great time, and we have pictures of cows. So I'll see you next time. Cheers. Hello and welcome to our lecture on SQL. So this is a very, very short introduction to SQL. I love SQL. I was talking to a student the other day and they were like, SQL is my favorite language. And I said, I have to agree that SQL is my favorite language too. Because SQL is so beautiful, you don't even need to write loops in SQL. We write loops in languages like Python just because we have to. The problem is that SQL is perfect, but it's not the way we could write something as complex as Linux or Python. And so SQL is not really the way computers think. We have these things called database engines. And these database engines make things work really, really well. And so SQL is a great way to organize data, but a lot of work has gone into keeping that data organized and making it simple. So it's like there's this abstraction, and it's a lot of work to make that abstraction work. So I want to start out with a little bit of history, sort of before databases. And you might think, wow, before databases, how could that be? Well, yes, in the old days, and if you watch old computer movies featuring computers, you see pictures that have these tape machines in the background, and they're spinning, and the spinning of the tape machine is the sort of physical manifestation of computation. And it had to do with the fact that in the old days, computers did not have enough data to store all of their data in the memory or on a disk. We didn't even have disks in the early days. In the early days, tapes were what we had. And we used kind of a variation of audio tapes, and instead of on audio, they contained data, zeros and ones. And so the way things would work in the old days so that you could have a database, as it were, was the database was all of your data recorded onto a tape. And the key thing to a tape is that it was a physical thing, and so you had to rewind it and go forwards and backwards. And most of you probably never even seen a cassette tape or an 8-track tape or a reel-to-reel tape, but it's a physical, long, 1,000-foot piece of plastic, and to get the data at the end, you had to spin it until you got there. And so it wasn't what we call random access, which means that in a random access, whether it's memory or the disk drive, random access allows you to get to any place roughly in a fixed amount of time. Whereas if you're close to something on a tape, you can get to it very quickly. If you're far away, you got to go boo and then wait and then come back. So this led to a pattern where every night we would take the tape from yesterday's account balances. Let's just say we're a bank, and people coming up the window, putting in money, taking out money. And then what we would do is we would put all of the transactions, sometimes on physically punched cards, and then we would sort them, right?
and let's just say we have 26 accounts, and you know, person C shows up with a little, adds $10, and person F shows up and subtracts $10, and et cetera, et cetera. And then what we would have at night, we would get these all sorted, and there were physical machines that would actually sort these in the earliest of days. And then we would have the old balance, A, B, C, D, E, F, sitting on a tape in order, sorted in order. And we would start a process after the bank closed where we would read the first record off the tape, like A. We would read the first transaction off the cards, and we would compare them. And if the tape was earlier than the transaction or lower, we would just copy it. So we'd copy it. And then so the B would compare to the C, and B would get copied, and then C would come across. And then we'd realize that the C data, we would have to update the C data and add $10 to the balance. And then we'd write that. And you'll notice as we're writing this, we are sorting, it's in sorted order. Then we would copy D, we have nothing for D, and it would just get copied. We would copy E, we'd have nothing for E, and it would just get copied. And then we would have, oops, forgot to put F on this picture. We would have F, and we'd subtract 10, and we would copy it. And then we would be done. We would be done with the kind of stuff that we had to do that night. And then what we would do is we'd have this new updated data that was all sorted in account order. And then the next night we would move the tape, the new would be the old tape, and we would do it over and over and over again. And sometimes these processes would run for 4 or 5 hours because the tapes were long, or it got to be multiple tapes. And so a lot of computing was done sort of after the banks closed at 5 o'clock. Then a group of people would come in, we called them operators, and they would mount these tapes and run these jobs and just sit there and watch these tapes spin as the data was being copied from one to the other. And so, yeah, that's pretty cool. Thankfully, that's not how we do it anymore. The thing that made it so we don't have to do this is the invention of disk drives. And disk drives are a magnetic media, just like tape drives, but the difference was they were on these spinning platters. And so what you could do is the data was in series of concentric circles on these platters, and then you had a head that could move in and out rapidly. And so the speed at which you could access data was a combination with the speed at which the head could move to a certain cylinder, and you had to wait until the data came around. And so sometimes you would have a 5,400 revolution per minute, so that means that 5,400, 5,000 times per minute, which is 100 times a second. Did I get there? Yeah, 100 times a second. Yeah, 100 times a second. 100 times a second, you'd wait 1/100th of a second for it. And so this is way better than waiting like a minute and a half, 2 minutes, even 10 minutes to spin up a tape. And so the problem is then we're like, okay, now that we have this wonderful technology, we can store all of our nightly data on a disk because it's enough space. How do we build technology to make really good use of this? And a lot of research, a lot of computer science, a lot of vendor research went into understanding how to best use this new disk thing. I remember talking to people because we used to use floppy disks, which they were much slower, so they didn't go 5,400, so it might take a quarter of a second to move the head, and it might take almost a second to spin it around, which was still way faster than 10 minutes, right? So it's like about a second to get to anywhere on the floppy disk. And we would build approaches to storing data, and we would start with this physical thing, and you'd hear it grunting and moving and grunting and moving, and then you would come up with a better way to store the data, and then it'd grunt and move less, and your thing would go faster. So this was like a research thing. It was good old days when computers actually made noises, and you could change your code inside computers. And the first thing, of course, we did was just took those sequential master updates and put them on, but that turned out to not be the best. And that was sort of the research, is not just how can we do what we used to do on data that couldn't be randomly accessed, and instead say, let's take advantage of it. And so a lot of research, a lot of vendors, there was a lot of very expensive software that people bought to say, look, you're a bank and you really and truly want to, know how this works. And so what happened was in the 60s and 70s, the computer vendors were fighting, and they would come up with a technique which you know, compared to our current database technique, was just trivially simple, but it took a lot of work back then. And they would fight with all the other computer vendors, and they would say our index sequential mechanism is better, and vendor 2 would say our networked approach is better, and then they would sit and they would sort of struggle with each other, and then the poor customers would be like, I don't even know what you're talking about. And so then they would just buy the stuff from the vendor who took them out to golf or the best lunch, or took them on a trip to Florida. And then they would just, you know, adapt to whatever that vendor did. And so it was really kind of scary, because we were moving into a place where you were locked into a vendor. And then once you're locked into a vendor, you're in bad shape. And so the US government in particular had a ton of money, and we're buying tons of computers, both, you know, for normal data processing and for strategic things like, you know, military stuff. And so they were buying tons of computers, and they knew that these vendors, if they got to the point where they locked them into a single vendor, that the vendor would just be able to dictate the price. And so the federal government, through NIST, the National Institute of Standards and Technology, decided that databases needed a standard. They needed a way so that we could talk to any database from any vendor using the same technique, and not have to you know, do one vendor, and then if you switched vendors, you had to completely rewrite your software. And so the NIST didn't specify how this abstraction, the standard, was going to work. They just brought the vendors in and said, we're going to stop using your software if you don't come up with a standard. And it was a perfect time, because even though the vendors thought they had everything was perfect and wonderful, there was a lot of upside. And in particular, there was this concept of relational databases, which back then was more of a mathematical theory of a better way to store and retrieve data than it was a practically implemented available technology. And so SQL, and this is Liz Fong, who I went and I did an interview at NIST. She talks about the early days. It's a great interview. The early days of how this SQL standard really made so much sense and really fixed the industry and got the industry working really nicely. And I recommend that you take a look at this video just so you can kind of see. Now, what SQL basically said is that let's not worry so much about where that data is actually on disk, because the earlier database approaches were, we programmers would know that there was cylinders and positions, and we would place things in certain ways, and we would make indexes, and we would look at the indexes ourselves, all kind of different things. Or we would read to one place on the disk, and that would have an address of the next place we're supposed to read on the disk. And they said, you know what, let's not worry so much about the physical storage structure on the disk, but instead, let's come up with a language by which we can express what we want to read, write, update, and delete on the disk, and a really simple language. And then we can build a piece of software that there could be many disk formats underneath that, and then we could all sort of just use this language, and you could buy vendor A and use this language, and vendor B and use this language, and then you could even benchmark it and say, here's a bunch of stuff in this language, which vendor can run this faster? And so the NIST also had a series of benchmarks, TPC, or some of the benchmarks. And so what they did is they basically made it so that this was like a beautiful and simple language, and it's what we call SQL. I think at some point it was called the simple query language, and it is the language that we use to talk to databases. And the interesting thing is what SQL allowed us to do, really in the 60s and 70s when it first came out, was to talk to the old style databases like index sequential and network style databases. And as this new form called relational databases, which had like this awesome mathematical underpinning, but was implemented badly in the first time, we could just say, oh, we're kind of, this is all, when the performance of relational databases got to the point where it was as good as the other databases, then we could just switch and we could talk the same SQL. So it allowed an amazing innovation over a 10 or even 15-year period where the abstraction allowed us to improve databases in a wonderful way without really having to change how we as programmers used them. Pretty dang awesome, I'll be honest. And so I've been talking about this idea of relational databases. And relational databases, and I'll admit that when I first saw relational databases in the early 1980s, I'm like, this is crap. Because again, I could hear floppy disks and I knew that we were moving a thing and I had so much awareness of what was going on and I loved that awareness. And the relational databases sort of like hid what was going on behind this layer. And it turned out that whenever I used it, it was slower because it wasn't yet clever. And so relational databases started out as a mathematical idea as the theoretical best way to represent networks of data with columns and rows and connections and joins, and we'll talk about all that eventually. And it was a beautiful idea, and the mathematics was right. It just took a long time to get to the point where it turned the superior mathematics of relational databases worked out better than the highly cleverly optimized previous generation database systems. So there's a lot of common database systems that you'll run across. Some of them are open source, some of them are commercial. Postgres and MySQL are open source. Postgres is probably the more intricate and complex and rich. Oracle is a intricate, complex, and rich database that's available for lots and lots of money. And Microsoft has a database called SQL Server. And all these databases that we're seeing evolved, in a sense, after the SQL spec existed. So they just kind of built SQL. There was legacy databases that kind of learned SQL. And there's lots of other databases. SQLite is what we're actually going to use with this course. And it's super cool, super fast, and on your cell phone you probably have 40 copies of SQLite, and in your car you probably have 40 copies of SQLite, because it's a real tiny embedded database. It's not really good for production scale when you got 100 users simultaneously hitting a website. Postgres, MySQL, or Oracle or SQL Server are really kind of online multiprocessing databases. But SQLite is great because it's really simple. It stores everything in one file. We can move the file around, etc. So I love SQLite, and in this class and in this thing we're going to talk about SQLite, but everything we talk about applies to all of these different database systems. So the first thing that you've got to do when you are going to work with a database is you got to come up with a contract between you and the database as to what the shape of the columns are, how wide the columns are, what kind of data you're going to store in this, and it then informs how the database software is going to structure that database, like on the disk. And part of what you're doing is you're allowing the database software, MySQL or Postgres or SQLite, to super optimize its storage. I mean, it's so much smarter than you. Something like Oracle or MySQL or Postgres probably represents $1 billion, if not more, of research and development about the best way to store and retrieve data. And you just don't even need to know any of that. You just say, look, I'm going to have these columns. It's going to have 100 characters of text, then I'm going to have an integer, and then a floating point number, then 3,000 characters of text, and you worry about all that detail. But the key is if you just say, I'll store anything I want, then it can't optimize. And so there's this thing where you have to make a contract at the beginning and say, this is exactly how I'm going to lay out the data as I talk to the database system, and then you can figure out how to lay out the data in the actual disk. And so that's called the schema or the database model. And building a database model is itself a cool thing. So if you're building a complex application, you have these models and they have connections, and we'll eventually talk about all that stuff. But it's a critical thing to say that that's a contract between you and the database software, so the database software can optimize the storage of the database. Now, once you have given the schema, then you can write queries that depend on that schema. So you might have a column called email and a column called name, and then you can insert data into the database using that schema. You can retrieve data using the schema. You can change data sort of somewhere deep inside the database, and then you can delete data. Hang on a sec. Whoa, hi there. What are you doing down there? Oh, dang it. Sorry. You are a bad creature. Look at that. I was wondering what that noise was. Come here. I gotta introduce you to all these folks. Come here. You are not behaving. So this is Shelby. Hi, Shelby. This is Shelby. This is my puppy. I'm trying to keep her out of the cage and let her sit and get by my feet. And she's got some chew toys. Hi, Shelby. This is Shelby, and she is interrupting. You're interrupting my lecture, but you're cute. So quit chewing on the pen. Chew on your chew toys that I gave you, okay? Let me get through this lecture. Okay, you can get down. Just quit chewing on a... Sorry about that. Dog interruption. I was just hearing chewing noises, and I thought I took everything, but then there was one pen on the floor, and so the pen, poor pen, meets Mr. Puppy. Oh well. Okay, where was I? SQL, CRUD, create, read, update, and delete data. And so our next step is to actually do some SQL and create a database. Okay, so now we're going to actually play with a little bit of structured query language, SQL. Now, you can grab, at this URL, you can grab the instructions that I'm using, so you can cut and paste it in. Now, the key thing that you've got to do is you've got to find your way to a shell. If you're using something like Python Anywhere, you go ahead and open a command line. Now, if we're using Python Anywhere, most of what we're doing is running Django applications, but you can really just use Python Anywhere as a Unix platform. And so get to a $ prompt. These commands can run on a Mac. They can, I don't know if you can get them working on Windows, but any Linux system, but you can also run them on Python Anywhere. So there's a command to Linux called SQLite3, and then you give it a file name. So SQLite, as I mentioned, is a very simple database because it does all of its work in one file. It's not a slouch as a database in terms of its performance and scalability. What it's not good at is handling hundreds of people hitting it at the same time and having the database software resolve all those simultaneous accesses. But if you type SQLite, you end up in a command line where you get this prompt, SQLite, arrow, and there's commands you can type, like .tables says, hey, in this database, which is in this case zip.sqlite3, in this database, what tables exist? And it says there are no tables. And then you create some tables. Now this is our first SQL statement. And so you'll learn something about SQL as it looks a little different than other programming languages. And so you say create table. That's one statement. You can create things other than tables, and then you have a table name. And then you have some parentheses, right? And then you have a series of statements about the table that you're working with. And so there's just this little language, and there's a name of a column. So these are 3 columns that we're putting in: ID, name, and email. And we have a type. This is an integer. Varchar means variable length string field. Not null means it's required. Primary key means that it's an auto increment, meaning it's going to be supplied by the database. It gives us like a handle for every row. And then varchar 128 says it's up to 128 characters. Now, a key to this is that we're making sort of a contract here. And so when we say you got to do this with 128 characters, you can't put 129 in. You can put up to 128. And if you put to 129, your database query blows up. And you're like, oh, that's not very nice. And the answer is, well, you told it 128, so it could optimize how it's going to store the data on disk. If you made it this 1,000, it might store it in a different way than if you store 128. And so the key is you can make any contract you want, but you got to live by the contract that you make. And so it's not the database hates you. It's you said I'm going to do 128, and when you do 29, it says you're violating our contract. And so it's up to you. So this whole create table ending in a semicolon, that is a single SQL statement. And so we can type it in. We can type it in multiple lines, and you can kind of see how SQLite's using this ... thing to tell you that it's in a continuation. And then finally you finish it all and you put a semicolon at the end, and then it does it. And then we can ask using .tables, we can say, oh, is there a table? And yes, it says, yes, it's users. And then there's a command, an SQLite command called .schema. And that says, tell me the schema of users. Now that's in case you hadn't just typed in the create statement. It tells you what create statement it would be. And so part of what the database stores in this file SQLite is not only the data for this table called users that you just created, but it also stores the schema. And so you can say, hey, what schema is it? So if I sent you one of these files, like you might upload to my AutoGrader, for example, I can inquire into that file using SQLite, and I say, what schema, what tables are here? And then I can start looking at the tables. As a matter of fact, that's how I grade these assignments inside of the computer. And so this is just sort of going through some. There's a lot of SQL, but the basics is actually surprisingly easy to understand. And so insert into, one of the things that SQL does is it tends to use more than one word. And it wants to be something. I've met people who have used SQL in their jobs, and they just like type it, and they don't realize how amazing what they're doing is. They're like, well, I just insert, or I delete some stuff, or I select it to read it. So it was designed to be easy, because if we go back to the basics of SQL, it was like, look, there's a lot of complexity down there. We want to hide that complexity. We want to hand something easy to users. And I write a lot of very complex SQL, and it's a very sophisticated skill. But simple SQL is something I think literally everybody should know how to do. So insert into, then you have a table name, and then you have a parenthesis list of the columns. Now, these are the columns that you named in your create statement. And then values is a keyword, and then there's a one-to-one correspondence between the values that you're going to put in the columns. And these happen to be strings, so we have little quotes around them. They could be integers, they could be dates, they could be all kinds of things, floating point numbers, etc. And then this has to meet the schema. You can't go putting a number into a string field or a string into a number field. And again, so that would blow up. If you can make all kinds of errors. You can either have syntax errors, like you forget the word into or something, or you can have errors that are bad, that your data is bad, right? So that's the insert statement, and that adds a row to the end of a table. The delete statement says delete from, and then a table name, and then a where clause. We're going to see where clauses a lot in SQL. And the key thing is that every SQL, I sort of mentioned at the very beginning that there's kind of no loops in SQL, and that's one of the reasons that we sort of love SQL, is you don't have to write loops. And that's because there's kind of an implied loop at the beginning of these commands. So when you say delete from users, that means delete all rows from users, right? Delete all rows, delete everything from users. So if you don't put this where clause on, if you don't put that where clause on, it actually deletes everything in there, because it's like delete all the rows from users. That's the way you can kind of phrase it that way, delete all rows from users. Now the all rows part isn't really there, but that just means that it's really important to have a where clause so that you're not actually deleting all the rows. It's saying delete all the rows from users where the email is equal to ted@umich.edu. And so what that is there's an implied loop of all rows on this delete statement, and the where clause reduces that down to actually one or a couple of rows, depending on those rows where this is like an if statement. So this whole thing is like a loop with an if inside of it. That's how it works. And this is why a lot of people like it, is because you don't have to write loops, because these things sort of like are loops. They have loops built in. So but this would delete one or a couple of rows, depending on whether we had more than one row in this where the email was ted@umich.edu. Update is really kind of cool. You can really zero in. You can zero into rows and columns. And again, update users, which is the name of the table. Set is, and then name equals, which is the field name and new value. And so you can do all the columns, you can do one of the columns, you can really zone in on this. And then there's a where clause, because if you don't put a where clause on the update, it implies that this is for all rows, and you don't really want to set the name to be Charles for all the rows. You just want to set the name to be Charles where this is true, because again, this, you could think of this as like update all rows in users set where. And so you just always got to be thinking that so the reading is done with select. I wish that it would be create, read, update, delete. The create is insert, read is select, update is update, and delete is delete. Select is the way that we read stuff out. And so select basically takes a list of columns, like select name, comma, email, or select star. And from, and then a table name. So this select star from users is almost always the first thing you type. Select star from users, select star from books, select star from whatever. You can also put a where clause on a select, because this again has this implied all rows kind of a thing going on. And so select all rows from users where email equals c7umich.edu. And that reads much better when you kind of add that all rows logic to it. Databases are good good at searching. We can do things like add indexes to the databases that make searching and ordering even better. So we might say that email, please, while you're maintaining this data, in addition to maintaining the data, maintain an index that has a sense of the order of these records. So if I want to sort them ascending or descending, then I can get that, and I can get that to be efficient. And so the order by is just a thing you throw on the end. You can add a where clause here as well, and you can have ascending and descending sorts, and it worked great. So this is sort of the first 60% of any SQL is the basic insert, delete, update, and read. And so that is not hard. And the beauty is this essence of SQL, the middle part of SQL, is portable across all the databases that I just described, because every one of those databases that's a modern database was invented after the invention of SQL. And so life is pretty good. Now, there are differences, because when they first built SQL in, like, I think 87, I don't know, forgot that time, but when they first built it, they did not realize how powerful they were going to be, and so there's a bunch of features that got added by the vendors that were extensions, and some of them were sort of standardized. There's another round of standardization, but then there's a whole bunch of features that are a little different, but they have, because of competition, they have conceptually the same ideas. Like there's like a limit clause that limits the number of rows or starts after a certain number of rows, and it's a little different from one database to the other. So, but this is just a summary. You should know this. You should just know this forever and ever and ever. And then as you run into a different database, then you'll learn different features for that. A tool that you might want to install on your laptop if you want to start playing with these SQLite files and not just using the command line is called SQLite Browser. You can download it. It runs on lots of different systems. You can then open these .SQLite3 files, and you can do stuff to it, including execute the SQL commands right in there. And so a lot of people find this a more interesting and easy way to interact with these files. And so that kind of sums up our really quick introduction to single table SQL. Up next we'll talk a little bit about multiple table SQL and relationships, and then we'll also talk about how we connect this all to Django through an object relational mapper. So see you soon. Hello and welcome to another Django for Everybody walkthrough. Today we're going to take a look at some SQL. Walk through some SQL. So the handout for this is dj4e.com/lecture/SQL01 basics.txt. And we are going to do this in a Linux bash shell sitting here in my Python Anywhere account. So I'm sitting here in my home directory, and I've got my samples checked out and on projects. We're a little ahead of that. For now, we're just going to work in this home directory. So SQLite is a very simple database, and it does all of its work in a single file. It's not the greatest multi-user database, but it's great for a class. So I'm going to run this command. SQLite is a Linux command, and then I'm going to give it a file name, zip. This is just a file I'm going to throw away, but with an SQLite3 suffix. So now I'm in a command line. I can type help to see what things are available. And away we go. I've got some of these commands all put in. And so you can do things like ask what tables are in there, right? What are the tables? Well, there are no tables. So let's run a create statement. This is a create, this is SQL, create table users, with name and name and email, but then there's this special, and each database does this a little differently. This is the auto-generated ID field. That's going to be our primary key for each of those rows. So create table users. So just copy this over. And semicolon ends these. And so you can, this is a continuation prompt. So it's prompting until it sees a semicolon. But now if I say .tables, by the way, you can see me cursoring up to get to this. So I have a users table. Yay, we're good. So then I can say schema users, say what is in that table. So it looks like a create table statement, but basically this is you can come back later and say, hey, what's in this table? And it teaches you this or gives this to you in the form of a create statement. So the first thing that you tend to do for anything is you run the select statement, the R of CRUD, create, read, update, and delete. And there's nothing in there. So let's put some stuff in. Let's insert, right? Do an insert statement. So of course we've got the table name, we've got the 2 columns. We do not have to specify the ID column because that's auto-generated by the database. And then the values keyword followed by 2 values, which is 1-to-1 correspondence in the same order as the columns. And so that happens. Now I can do a select star from users, and you see that I got a record that has Kristen and kf@umich.edu and a primary key of 1. And so that's pretty nice. Now we can say, I would like to see this not with those vertical bars. The vertical bars are kind of nice and condensed, but if I say mode column, I can say select star from users, and it gives me a little bit more white space. Okay? And so that mode column is just an SQLite commands to make it a little easier for me. Now I can just put in all these other records, copy them all, and SQLite happily runs them in order and finishes them with a semicolon statement. So now I can say select star from users, and there they are. So I'm sticking them in the database. What's amazing to me is that it's so beautiful. I mean, I just think SQL is just so beautiful. I mean, people avoid it. There's a delete statement, right? Delete from users where email equals ted@umich.edu. Goodbye, Ted. I can do a select, and you can see that now I have record 4 is now gone. I could have said delete from users where ID equals 4. That would work too. I'm going to change my name in the Chuck record from Chuck to Charles. So update users set new key equals value where email equals, and the where clause is really, really important because otherwise it would have updated all the records maybe right before I delete all the data. You can see that the Chuck now has become Charles when I do a select star from users. So far, so good. You can use a where clause on a select statement, select star from users where email equals csev@umich.edu, and at that point we only see record 2, which is me. We can order by select star from users, order by email, which now we see the emails in ascending order, a csev, cvl, kf, nicely in ascending order. We can do DESC. We can say select star from users, order by name DESC to make it be descending. So now you see Sally, Kristen, Colleen, and Charles in descending name order. And away you go. And so we could drop the table users, but let's play with this data a little bit, right? So let's just say I did an update. Update users, set users name equals Charles with no where clause. Watch what happens. This tells you something about SQL. Now if I do a select star from users, now let's just do a select star from users. Select star from users, everybody's named Charles because the update applies to all rows until you tell it not to with a where clause. So we always type the where clause without even thinking, but you do not have to type the where clause. And the same is true if I say delete from users with no where clause. Watch what happens. Normally we put a where clause on delete. And then we go select star from users. Away you go. Okay? Now I could also say drop table users, and then it will all go away. Oops, users. Okay? And so that's it. .quit. I will log out. I hope that you have found this particular walkthrough for Django for Everybody useful. Cheers.
And there were products that are growing from wild. And then we realized that, hey, I want to buy a product. What kind of a feature do I need? Another one of the things that I have done is the feature analysis. So we have about half a dozen of products, and the standardization are really building a consensus. We brought from a matured technology that are ready to be standardized, where people say, do I buy IBM or do I buy Oracle, or shall I buy a cheaper one? This kind of a decision started emerging. And the selection of how many variety of application you can build on top of a software foundation, what I call database management system, is too varied. And so you want to have some sort of a standard so that your application can work on different platforms. We work with files, and we call it the file system. The files were hierarchical. There was the IMS, the IBM Information Management System, which is a tree structure, and the debate was going on whether there should be a tree or a network or flat file, and we are still debating whether the data have a self-describing tag, and later on we known it as a metadata, and now people call it the schema. So the database system study group come up with a reference model or a specification for a minimal functionality of a database management system. In order to be a database management system, you want to be able to store data, retrieve data, modify data, organize data, delete, manipulate data, and it becomes a spec. And during that time, there was a birth of we initiated a birth of an ANSI group. It's now called NSIDE. The ANSI is American National Standards Group, and it's called the X3H2, of which the Don Deutsch and people like Len Gallagher all participated in that. That group is called the Data Management Language. In order to standardize anything, you realize that you can have a lot of light bulb, for example. You can have red light bulb, white light bulb. The only thing you want to standardize is when you want to talk to another person, a communication interface, or a area where both of us have to understand a common vocabulary or whatever. So the standard, the only standardization of a software system is not the capability but a language. And relational database at that time was IBM, Chris State, and he's talking about normalization. He started talking about flat file, and he called it a table, and it's a very easy concept that everybody understands. So in order to retrieve a table, you say select from a column such as such, from a table of employee, and there was a birth of a simple query language. Testing part is also a very important aspect of when you adopt the standard. You want to certify that the product conform to such and such version of ISO standard, JTC1, whatever it is. So that gets to be, if you're, otherwise your app won't work. Your application, let's say you build a student course record, and no matter you got Oracle, you got a Sybase or Microsoft SQL, you want your application to work no matter what. And that's what the marketplace wanted to go. The user, of course, Oracle or Microsoft say, buy my product. Oracle will say, buy my product. And in the procurement, you say, I want to be compliant with SQL. And so you have to have the conformance testing certificate. And we have the NAV labs. It's a laboratory that's certified and give you a validated product list. Here are the list of products that has been validated that they conform to it, and you can buy from that list. But there is a requirement. This is strictly user. You're buying because you're paying the money, not us. Timing is everything. You can't standardize a thing too early, or you drive a lot of innovative concept away because people say, hey, there's no way for me to get into your market because you already decided, and even though it's not very good, I won't get into that business. So you killed innovation. And if it is too late, you miss the opportunity. You get too many variety of things coming up, and the choice is too much. But of course, SQL is one of the success stories that list we have.
Kitchener, Ontario. I'm here working with a learning management system vendor called Desire to Learn to help them work on their implementation of a protocol called Learning Tools Interoperability, which turns out to be the way the auto grader sends grades back to Coursera. So I want you to meet some of your fellow students, and they can talk a little bit about the course and tell us their name. Hi.
Yeah, hi, Tahsin Saleh. I finished the first 4 courses with the Python for everybody. I'm waiting for the capstone. Hopefully things go excellent.
Thank you.
Hey, how's it going? Louis de Bourbon. I just finished the first 2 courses of Python there, and super stoked about meeting Dr. Chuck and the rest of the community and learning Python, and looking forward to continue learning with the Coursera products. And
well, thanks for coming up from Toronto.
Yeah, no worries.
Yeah.
Hi, my name is Jigar. I'm doing the Python for Everybody course and completed the first 2 courses of Python, and super excited to do the 3rd one as well as the capstone course. Thanks to Chuck.
Cheers.
Hey, I am Herman. I'm doing Python for Everybody from Coursera, and I am on course 2. It's really exciting.
Cheers.
Hi, I'm Dave. I just finished Python for Everybody and the web design for everybody, and I'm looking forward to doing the Django course when it's available.
Cool. Yeah, so I don't know where I'm going to see you next. It's coming up on on-campus teaching in the fall this semester, and I'm teaching a Django class, which I hope to turn into Django for everybody in the upcoming. So I'm going to be kind of busy building auto graders and all those kinds of things for my Django class. So I hope to see you sooner or later at an upcoming office hours. Cheers. So in this course, we're going to look at the structure of a Django application. You're going to get tired of me showing you the same picture over and over and over again with the models and the views and the urls.py and all those things. We are
I want you to understand that a Django application isn't just a bunch of folders with a bunch of stuff in it, and you throw something in here and you throw something in there. I want you to have a comfort level of why things are laid out the way they are in a Django application, and it takes a while. And so I'm going to sort of repeat this over and over and over, what file's here and how this file works and how we go through this file and how templates work, etc. And so at the same time as we're exploring the structure of Django applications, we're going to understand model view controller. And Django, if you ask the Django people whether or not Django is model view controller, you'll get sort of a shaded answer, right? Whether is it or isn't it, etc., etc., etc. And so, but it is mostly a model view controller application, and most web applications are some variation on a model view controller application. So we'll look at Django in the context of general purpose model view controller applications. So the assignments for this are based on the tutorial from djangoproject.org, and they just kind of walk through a number of really good topics that are the basic fundamental pieces that make up a Django application. Now I want to talk a little bit about a concept, model view controller. It's not super essential to understanding how everything works in web servers, but it's a great set of terminology that we use among web developers. And I think as you move into your role as a web developer, you ought to understand this. So this is a picture of the request response cycle. At the bottom we have the browser, and at the top we have a web server talking on port 80. The user clicks on a page, clicks on a link, the browser intercepts that link, opens a connection up to the web server, sends a GET request, the web server does its work, and returns a web page. And so that's sort of the basic request response cycle. And now we're going to, as in much of this class, really expand what we're going to do when we're in that web server. So that's where we're going to take a look at this. So basically, model view controller is really a set of terms that allow us to say this aspect, this part of the work that's going to be done in the web server, it's either the model, it's the view, or the controller. And so it's the most value that it has is to say, oh, that part right there, that's controller. So model view controller is independent of the programming language that you use, independent of the operating system that you use. It's pretty universal across as a concept, as an architecture, as a way of talking about web servers. So the three parts of it, it'd be probably better to call it controller view model, or model controller view model, or something like that. But model view controller rolls off our tongue better. So the definition in my mind of these terms is the controller is this sort of abstract idea of what happens next, what is the sequence of events that happen, and then where do we start from, what do we do when we get a request, and then afterwards, where do we go at the end of that. The view is all the stuff we see. It usually is at the end of the request response cycle, we produce a view and we return the view back. And one of the things that the request response cycle often does is either interacts by storing data in a database, like an insert, or it edits something and puts it in a database, or it just reads stuff from the database and shows it to us in the view. And so that's called the model. The database itself and sort of the notion that we have persistent storage inside the application, that's what we call the model. The view is what we see, and the controller is kind of the glue that puts it all together. So the controller orchestrates all this stuff. And so it's, sometimes you don't say that's the controller, but the controller is like several places and the actual shape of your application. So when we receive a request, we have a number of tasks that we often have to do for each request. Sometimes if it's like a form that's been sent to us, we have some data that we have to receive, validate, and then process, and then store it in a database maybe. And so that's often thought of as the model work. Then once we've done that, we make a decision, like I stored this, where do we want to send the user? What do we want to show next? What page to show next? Maybe we show them, a thank you page, or maybe we send them back to the top page of the application. And so once we know what page we're going to send back to them, then that page has some data that we might have to pull from the database. And so we retrieve that using the model, and then we produce, perhaps using a template, some HTML response, and then put it back. So these are the four typical steps that we break down to say, in comes an HTTP request. First thing we do is if it has data that we're supposed to do something with, we handle it, maybe store that data in a database, then we talk to the database and retrieve more data to produce the next output that we're going to make, and then we produce the HTML or the other form of output and we send it back to the browser. And so if we take a look at this in our Django application, the Django application is pretty much a model view controller application in that, you know, the routing is very much the controller. It is that which it's like, here comes a URL, it's a request for something, where do we go? And so when you write urls.py, you're informing the controller. So the urls.py, I would say, is part of the controller action, the controller activity. The views is named the view. So the view is a little bit controller in that sometimes the view is storing some data in the database. Sometimes that's the job of the view. Here comes some data before the view produces the next output. It actually has to store what came in on this request. And then the view will do some controller activity, like it might decide, you know, I don't want you, this is the wrong page now that we've processed your data. I'm just going to send you over to some other page. That's kind of a controller activity. So it might say, I'll store the data. It might, let's see here, So it might say, you know, here I go, I'm going to store some data, and then I'm actually just going to send you to a different place. I'm not even going to give you any HTML. And we'll talk about that redirect. That's called a redirect in a bit. Sometimes there is no data, and so sometimes you get some data, you route it to the right view, and maybe some data has to be retrieved from the database, merged together, and result is processed. So when we think of views.py, that is to me both the controller and the view production. So sometimes it's making decisions about where to go next. Sometimes it's just handling incoming data or sending data out. And similarly, the models is taken from model view controller because the models.py is where we basically do all the work to talk to the database, whether it is storing stuff in the database or retrieving stuff in the database. We use the Django model capability to implement the concept in model view controller of models. So just a quick summary. I like to think of urls.py and some of the views.py as the controller. The models, of course, is all the things that talk to the database. And then the views are like the second half of views.py. So produce using templates and forms.py and et cetera, to produce the output and send it out. And so that's how I map the model view controller onto the Django architecture. And again, Django architecture was probably inspired by the model view controller, and that's why it takes some of its names of some of its capabilities from the model view controller concept. Hello and welcome to our lecture on simple Django models. Now, as you've seen in previous lectures, we talked about SQL, structured query language, and that's how we talk to databases, and it's beautiful because it allows portability up to a point across databases. And we talked about all the create table stuff, and so this is just a bit of review where, you know, we can type these commands to SQLite. We run SQLite, we run a create table statement, and you know, we do it to say .tables, so we can ask kind of schema users. We did all this in a previous lecture, and so that's basically how SQL works. And here's a series of SQL commands from a previous lecture, just kind of as review. It's pretty simple, CRUD. Now, one of the problems is as I mentioned, is that different databases like Postgres and MySQL do all this stuff identical, but then some more subtle things like how foreign keys work, which we'll learn in a bit, or how they do limits, like pulling like 25, next 25, next 25. That's a little bit different. And so if you want to build an application that talks across more than one database, you got to think a little bit. And one solution to this, also to kind of limit the fancy SQL you have to learn, I like to say that you know, you can learn the first 60% of SQL in about 3 hours, and the last 40% is literally a lifetime. I mean, and so it's advanced SQL is difficult to do It's really hard to teach a class in advanced SQL. I can teach you advanced features, but then there are so many features that you just can't learn in a class because which database you're using, and they're different for every database. So one thing that's happened in the past decade or so is the emergence of what's called object relational mappers. And that is you have the physical database layer, and then you have SQL, which is an abstraction. It's an imperfect abstraction. And then Django builds another abstraction on top of that called object relational mappers. So we just create a Python object, and we ask that to be placed in the table. Now the object may have a name and an email address and a birthday or something in it. It can have all kinds of data in that object, and then that maps into a name and an email address, and we have to tell it, like, do we want this to be indexed and all these other kinds of things. We communicate through the ORM, so we leave the ORM alone. Now in Django, as we get more advanced, you can also sort of bypass the ORM because the way the objects are mapped into the tables is predictable. The names of the columns is predictable, and so it's kind of like it's a shortcut for, I like to think it's like the 80% of the most common things you do with a database are easily done with an object relational model, but object ORM. But ultimately, once you get to the more advanced things, you tend to not be able to do that with an ORM. You get to the point where writing the SQL is easier than using the ORM. But for about 80%, writing ORM code is way easier than writing the SQL. The other thing that ORM does is it allows you to have multiple databases because the ORM code inside of Django knows the difference between SQLite, Postgres, and MySQL. And so you could actually start an application that uses SQLite during all your development, and then when you deploy it to production, you just go like, you know what, let's just use MySQL or Postgres instead. And that's quite cool. I find them limiting, and so I want you to know both how to use objects and how to use SQL, but understand that most of what you're going to do is to use the object relational mapping, and we get a lot of power with this. So if we look at sort of the way we communicate to the database, or the way we define the database, in SQL we create a table, and that right there is portable, but once you start doing things like adding auto increment columns and things like that, it stops being portable. And so that's the way we do it. But in Django, the way we do this is we have a file called models.py, and it's in the application folder. And then we are going to use object orientation. So we're going to, from Django.db, that's a package, we're going to import models. And models is now a class. And we're going to create a class called user. This is going to be equivalent to the name of the table. And we're going to, in the definition, we're going to extend models.model. And so there's a lot of, this is called extending, it's called inheritance. We're going to get a lot of features and functionality, excuse me. We're going to get a lot of features and functionality from this code. So there's probably 20,000 lines of fancy code that we didn't write that we're using. By extending models.model, we're getting all that. And then within here we create a couple of attributes that basically says give me a character field. Models is a class, char field is a method within that class, max length equals 128, and that gives us the name. These two things are equivalent, and what happens is when we build this and we do what's called run a migration, then Django will make this table for us, but then we have this abstraction that we can use to talk to it. So this is called a migration, and so you have to be in the projects folder. And so once you create a migration inside of your Django application, then you go up into the Django project and you say Python 3 manage.py. Now manage.py is kind of like the thing that starts everything. So make migrations is actually creating files, because the idea with migrations is that you would debug your migrations like on your development environment, and then once you know, you would move them to production. So you'd make the migrations in development environment, you'd get them right, and then you'd like check them into GitHub perhaps. And then in production, you would pull your migrations out of GitHub, and then they'll migrate. So to make migrations, The make migrations bit, that is creating a set of migration scripts. And you can see that it's making these files, and they're actual files, and you can go find those files like 001 initial PY. And then the migrate is reading the migrations and then actually changing the database. So that's the one where you might be able to make a migration, and it doesn't matter what database you're going to use. Could be your development in SQLite and production in MySQL. You would do migrate in both of those, and in your development it would make an SQLite database, and in your production it would make a MySQL database and put the tables in. And the SQL might even be quite subtle, and it will be subtly different between them, but you don't care. So migrate is the act of creating the database. Now in our development environments, we're going to be creating a file called db.sqlite3. And so if you get all messed up, you don't have to remake your migrations. They're just sitting there kind of as part of your source code. And you can like get rid of the db.sqlite3 file and then run the migrations again if you get kind of messed up. So the make migrations reads this and creates these other little files. You can take a look at them. They're kind of like Django's internal files. They're Python. It's just you're not going to write them by yourself. But then the migrate reads the 001 initial.py and then actually creates SQL commands and runs those SQL commands for us. And so if we jump after we've done this, we see this file db.sqlite3, and we can jump in and take a look. Again, you have to be in the right folder, so you'd be in the Django_projects and then the folder of the project, but there'd be a file called db.sqlite3, go into a Linux command line, type sqlite3, db.sqlite3, and you will find a whole bunch of things. And when you go into SQLite and you type .tables, you will see that Django has a bunch of migrations that are all there from the sessions and stuff we're going to learn how to use later, authorization, etc., etc. But then the particular data model that you created, which is a user data model, there's a table in there for that. And if we use the schema command of SQLite3 and we say, hey, what is in that user model underscore user table? And you see a create statement, right? And so this is the actual create statement that the Django sent to SQLite to create the table. And I was talking about some of these things are quite predictable. The name of the column is quite predictable, ID, name, email, etc. It adds the ID field for you automatically. And most of it's portable, like this part here is quite portable, but this ID statement here, primary key auto increment, turns out that if you're in MySQL or Oracle or Postgres or SQLite, that's a little different, but literally the migrate takes care of all that because the migrate knows that thing, and as MySQL changes, that particular syntax doesn't change very much, but as MySQL changes, then the Django stuff changes and it all kind of works out. And so you can sort of run these commands and then sneak back into the database and you can see what they've done, but it's all very predictable. Don't want to spill my coffee on my computer. So you can also you're talking at the low level when you run the SQLite command, but you can also be in that folder, same folder that has db.sqlite and manage.py, and then you can start what's called the shell. So this is different than the Linux shell, and you see the prompt change from $ to three chevrons. And it's not the same as the Python shell, although it is the same as the Python shell with a whole bunch of Django libraries that are pre-mounted. Okay, and so if you just say Python 3, you'll get this, but this next command that is from user model models import user, that will fail unless you let manage.py start your shell, because again it loads a bunch of objects and classes into your space, and then all of a sudden user model.models works, users there, etc. Okay, so this is pulling from your models.py file that you built, and so user model is the application name and models is the models.py file. We import the user model, which is in this case a class. User is a class, and we're going to do a constructor call. And so we're going to say let's make a new user, set the name to Kristen and the email to that email. And this actually has not done anything in the database. This creates, in effect, just a Python variable. And then to force it to be written to the database, we call u.save. And so save is a method on this new user object. Capital user is a class. We're using a constructor to construct from the class, an actual instance, an object, and then we get that into U, the instance object, and then that object sits in our memory until we say save, and then it also pushes it back to the database. Now, one of the things that the save does, it assigns, in effect, a serial number or a row ID. If you look at these, they start pretty predictably at 1, 2, 3, 4, 5. But if you're getting a bunch of things coming in from a bunch of places, then the database just assigns each object, each row, and that's part of that whole auto increment thing. Come on, go back up. This whole auto increment thing that says, hey database, I'm going to put records in, I'm going to give you the name and the email, and you come up with a number, but then when you're done, I want you to tell me what the number is. And this is how you get that number, by saying, oh, print u.id. Now, if you printed u.id before you did the save, it wouldn't exist. And then print u.email, you can see this email is just the data we put in, but now this is not only in your u variable, but it's also in the database as well. Okay? Now, we can dig a little bit into how this object relational mapping is working. And so if you're in the middle, you're doing things like that last statement, you can from Django DB import connection and then ask connection.queries. And then what it does is it just shows you a little bit of debug data and what it did, how it started, the fact that it ran an insert statement. And again, this looks kind of familiar. This is it's making up SQL for you for that insert, the save statement, right? That save statement there. It's making that insert for you, and then you can actually see what it's doing, right? And so this save, set up a thing and save it. You don't need to know insert into or whatever, because the object relational model does it for you, right? And this is kind of what we did before, insert into capital users by hand. And so again, you'll find this ORM is going to save you a whole bunch of time for 80% of the things that you do with the database. And so you can do basic CRUD operations with this object relational mapper. The save is the insert. You can select is basically user object values. That's like select star, so give me all of the objects. A where clause is user objects filter, and there's your where clause. This is email is a column name, and c7@umich.edu is a value in that column. Values is actually go get them, so you can create kind of a query. So if you don't put values on, you get sort of a query that's not yet executed, and then values says, go do it now. So you can do a different, you can delete something where you say, and so this is a little different syntax. This is kind of a selector that says these are the variables to select, and dot delete says, the rows to select, and then delete those rows. So value says retrieve the rows, delete says get rid of the rows. And then you can, again, the same kind of thing. This is kind of like a where clause. User objects filter email equals c7@umich.edu dot update, and then change this column in a way. And you can, go retrieve all the values. And there are things that correspond to lots of the SQL, like give me all these values, order by email, etc., etc., etc. So it's kind of a one-to-one mapping, and you will, again, you're going to do a lot of programming using this ORM in Django, and every once in a while you'll sneak down to SQL. And that's why I sort of teach you the SQL first. And there's lots and lots of fields that might not actually be represented exactly the same way in the database. So for example, an email field. Databases commonly don't have email fields. There might be some databases that have emails and others that don't. But because the object relational mapper is a layer between you and the database, and you say, I'd like this to be an email field, then it can add rules and stuff like validity checking, etc., to say, you know what, that doesn't look like an email address. And so there's all of these things, and these are very useful. And later we'll talk about connecting tables, and we'll use things like foreign keys and many-to-many fields and one-to-one fields, and those are less about the data and more about the connections between tables, which we'll talk in coming up soon. And so just to give you a sort of a bit of a sense of where you're at, this is our application, right? And so we have a browser on the left-hand side with a user doing some clicking. By now you may have created a urls.py file, and that takes the the syntax of the GET request, slash this, slash that, slash whatever, and routes it to a particular view coming from the views.py file. You may or may not have made one of those. Templates and forms help produce output. But the models are our interaction between us and the database. And so the actual code we write in Django can talk through the models to the database, which you may not have done yet, but this shell is talking through the Django models to the database as well. And if you're starting to use the admin user interface, the admin user interface talks to the database through the models, and it's informed by the kind of things that you add to admin.py. If you want to use the Django admin interface and have your model shown a particular way, it's got a bunch of defaults, but often you want to override those defaults, and so that's what you put in. And the model.py file informs this connection between the database, and it also sort of informs the kind of code you write here in a view code in Python or in the Python shell. That's kind of the Django shell, which is a Python shell with all that stuff added to it. Okay, so this model.py is critical to defining our relationship between all of our Python code and the admin user interface and the actual database. And so you'll see a recorded demo where I go through a bunch of those things, which I kind of just showed you. It's just actually doing it in a demo form, but it's all mostly in this lecture. And so the Django model is Django's version of an object relational mapper. You can write Python code after a while, especially if you have an IDE that can show you what objects have and stuff. It's a lot easier to write, whereas SQL, you have to know it and write it. You gain database portability. You can create these migrations to both build your initial schema in your database and then evolve that schema as your application evolves. That's one of the more valuable things. If you're building straight up SQL, going from like version 1 of your database to version 2 of your database, it is kind of frustrating and difficult. Sometimes migrating and evolving a database is harder than actually writing the SQL code in the first place. And Django gives you right out of the box this really cool administrator interface. The models.py and admin.py informs that. And later we're going to have all this automatic form generation. And so what we're doing here is it seems like we put like 3 lines of code into some file and then a whole bunch of magic happens. And that's really how Django works. And the idea is that way you as the developer can focus on the columns of your database and the forms that you want to put up and spend less and less time sort of manually building HTML that's very sort of brittle and SQL that's less brittle but still brittle. And so that's the idea. And so it's a little hard when you're getting started because you're like the amount of code you write is so small and the amount of what that accomplishes is so great. But after a while, when you get all these little tiny pieces figured out, then all of a sudden you're like, okay, now I want to solve that end user's problem, and you can spend all your time solving that problem rather than just making databases and those kinds of things. So, see you in the next lecture. Cheers. So it's pretty easy to get confused when you're first looking at data models, migrations, and the database itself. And so I want to go through this in a little bit more detail. So the make migrations is what reads the models.py files, and then it creates what are called migrations. And the key thing is this is guided by the list of applications in settings.py. So if you make a new thing and make a new application and you edit the models.py file and you try to run and make migrations and it doesn't see anything, you're like, what did it just do? Well, did you edit your settings.py? Because there is a thing called installed apps in your settings.py. Now, migrations are portable across databases. This means that the migration is a logical description of what the tables should look like. And they're an evolution. What they mean is like the first version of this table from the first models.py when migrations was first run is 001. And then if you change models.py and you run a migration again, it looks at the changes from the migration 001 to models.py and then 002. And then 002 is not like wipe it all out and start over. It's like, oh wait, you just added one column, I'll go ahead and add that column. But it's not done it in a way that's actual SQL. So migrations are themselves kind of Python-like. And they're portable across databases, which means that you might, on your computer, use SQLite, and in production you might use MySQL, and the migrations are the same for both of them, because they're just saying, here's the columns, here's the types, here's what they're supposed to be. Now, contrast that with a migrate command. The migrate command reads all the migrations, and then knows what database it's talking to, and runs the SQL commands to create the necessary tables and or evolve the necessary tables. So it looks and says, oh, here's the first migration, here's the second migration, here's the third migration. I'll make the table, I'll change the table, I'll change the table, I'll change the table, and at the end of all the migration, the migrate then goes through all the migrations and then has a database table that reflects the sum total of the migrations, which also reflects the latest models.py file. So it's a little complex. It has to do with database portability and the fact that we want to separate out the portable parts of this from the non-portable parts to this. So if you look at the make migrations, and here's in DJ4E samples, my little sample stuff, there's lots of models in there. And if you take a look at all the models.py, you see that for every application in the DJ4E samples project, you see a models.py file. And that's a Python code, that's class, book, blah, blah, blah. That's very portable, and that's how we, in our Python code, in our Django code, see the database model. And when you run the make migration, that produces these migrations files. And they're just in like autos migrations, 001 initial.py, etc. And so you see some of the ones I have here, there's actually two of them. So it sort of made the first one, and then I must have changed the models file, and then I ran make migrations again, and it showed, it recorded how that model changed from the first version of the models file to the second version. If you can look at these, don't edit them, you can check them into GitHub, but don't edit these. But take a look. They're a very portable representation. They kind of look like the models.py file. You're not supposed to change them. You're supposed to generate them with make migrations. And again, those can go into GitHub. Now, the migrate basically reads all those migration files. And not just one, but if there's a sequence of migration files, it applies them all in order as needed. And if the database has the first and second migration applied, but not the third one, it knows that and says, you know what, I'm going to just tweak this database that already exists, that's already running, and then add a column or change the width of a column or whatever it is that you've asked to be done by editing your models.py. So when the migrate is done, you then end up with a whole bunch of tables in your database. And they're all based on the name of the application and the name of the model within the application. And so somewhere in here is book one book, book one instance, and book one lang. They're all sitting there. And so those are all the tables. And we took a look at those tables before, but that's the migrate. That goes from all the little migrations spread across all of the applications in this project, and then puts a database together that has all those things. And I keep saying that the migrations are all about evolution, right? Because if you take a look here, you see one little table called Django Migrations, and what Django's doing in that Django Migrations table is remembering which of those migrations have already been applied to this database. So as it's going through the migrations, it says, oh, here's one that's not yet done in this database, so I got to tweak the database just a little bit. So it remembers the migrations that have been done. It's pretty fascinating, and in these little tiny applications, we don't always need to be so clever about that. So sometimes what you want to do is just like, I'm confused. I'm going to rerun the make migrate. Because you're not really running production, you're just really doing it over and over again. So you can rerun the make migrate. And the way you do this is you basically simply delete the file. You can delete these files. I would delete all the ones that start with 0, right? If you're going to rerun make migrate, just rerun make migrations. Delete all the ones that start with 0. And this is in application migrations, and then get rid of all these. And then you can rerun the make migrations, and it will read your models.py file, and then it will do all of the necessary things to recreate the migration file. Right now, that's not the database. That is the instructions on how to create the database. Okay, so that's how you rerun make migrate. you can run migrate from scratch, this is actually easier. So you can kind of wipe out the migrations for one application, and I did that, just wiped out the book 1 here. That's what I did and started over. But you can wipe out the all the migrations and all the database and everything by just removing the file, in this case, because we're running SQLite. Just wipe out the file rmdb.sqlite, because after migrate, that's where everything ends up, is in that file. So then you wipe that out, it's gone. Now you might have created an administrator account or something, and you're going to wipe that out too. You're going to wipe the data out, you're going to wipe the tables out, it's all gone. That's one thing I like about SQLite. You remove this one file, and it's literally all gone. And then you rerun Python manage3 migrate, and it reads all the migrations and makes you a nice, clean, perfect, empty database. So if you're kind of stuck, and you're not afraid of losing your data, which in most of the beginning programmers, it's okay to wipe out your SQLite thing and run migrate again. Just go ahead and try it. Like I said, if you made an admin account, well, you got to make it again. But that's the worst that you can do. So at least in these beginning applications. So now that we've talked about how to come up with a data model, how to encode it in Django model.py, how to do migrations, and how to migrate stuff, and how to make a database out of it, now we're going to talk about the kind of Python code that you can run to update these models in the database. Hello and welcome to another walkthrough for Django for Everybody. Right now we're thinking about data models, and I'm going to show you how you can walk through and run this particular little example in the Django shell. So let's go ahead. We're going to Python Anywhere. I've already got a bash console. I love the idea of this bash console. This is Linux. I think that everybody should be learning Linux. So if I start my home directory, cd ... means go up a folder, ls -l. I got some folders here. I got DJ4E samples, which I try to convince you to check out so that you can edit your file, edit my files, look at my files, use that as sample code for your own work. There is instructions on how to clone that, and so, but we're gonna assume it's already there, and follow the instructions. So we're going to go into that folder cd, and then we're going to type a git pull. And the way this works is this is in GitHub, and that way if I've made any changes or fixed any bugs in my sample code, you've always got the latest code. And I've already done this, but there is a bunch of, so, oh, by the way, I got to switch into my Django 3. I got to switch into my virtual environment. You'll notice I didn't have virtual environment, now I do. And that's because this next command, this pip command, not Django 3. This pip command is going to change the Python configuration, and it's literally best if you do this in a virtual environment, so you're not like messing up your overall Python install on your system, whether it's your desktop or Python Anywhere, with my particular requirements. With my, this is installing a bunch of utility code, etc., etc., etc. And is there some new? It looks like I got some new version here. And most of it's already there from a previous time that I installed all this stuff, but it's good that I ran this to make sure that I have all of the Python requirements needed for this. So now it's done, and it's installed all of my requirements. I'm going to type the clear command to kind of clear up my screen. Okay, so there we go. So then the next thing you run is this command that we run. We're going to run a lot, especially in Python Anywhere, is this python3 manage.py check. And what this does is it reads through the urls.py and the applications and a whole bunch of other things, and it blows up. And so if you get no issues, that's good. The point is you do not want to continue down this other path unless check passes, because make migrations starts to make changes. So make migrations is Django reading through all of the models.py files and creating migrations. Now migrations are not SQL, they're actually Python code, and because this was checked out from GitHub, all of the migrations are actually sitting there, right? There's a way if you want to remove the migrations and remake them from scratch. So the migrations reads models.py files like vi users models.py and reads these and then creates migrations. And then the next thing that happens is we're going to actually, I'm going to get rid of my database.sqlite3. You can, that throws away your database. It actually tells you to do that right here. And then migrate reads the migrations. Migrate doesn't read the models.py files, it reads the migrations. And then it creates the database. And so it's going to create a database, and it is going to create a bunch of tables in that database. And so you see for each of the applications that I have in this Django project, it's creating a bunch of tables. And so here, for example, is users one initial. That is the table that I'm going to mess with up to that point. So now I've done all this stuff, and it's time to actually run Python manage py shell. So what this is it's like starting Django and loading all the Django libraries and reading all the Django configuration files. So there could be a bunch of errors that happen at this point. And if they are, go back and fix those errors, okay? You can't just like, oh, I think I'll ignore those. This is what the manage py check did. It sort of did that. But now it's like you're in a views.py file, which we'll see in a bit. You can type Python commands that Django, inside Django. It's not just Python, but Python with Django and all of your Django application preloaded. So that's why it takes a bit of time to get to this point. And now it's pretty easy. So now we're going to type Python, right? Now we're going to import the user model, and that worked. And now we are going to create a new user object. So these next two commands are really important. So what that user says, name equals Kristen, email equals, that is going to create a new user model object in Django's Python's memory and give it back to me in the variable u. At this point, it's not stored in the database. So if I say, where did this store in the database? Oops, u.id. There is no ID currently, because if it was given an ID in the row, it gets a serial number basically of the user after it gets saved. And u.save says, see this u variable that I've got in memory full of data? Well, store it in the database. And now I can say u.id, and I can see that it was stored in the database at position 1, which is exactly what you would expect. These numbers are pretty simple. They start at 1 and they go up. And we'll see as we do a few more folks. Let's put a few more folks in. We'll reuse the variable u. I'm just going to copy and paste all these at the same time. And now I can say u.id for u.name is Sally. That's the last one I did. And then u.id is 5. It's the 5th one. So now I have 5 models that have been persisted, stored in my database. Now if I want to retrieve those, user objects. So user is the name of a model. That's actually a class. Objects is a attribute in there which has a method of values. So I can get back all the values, and you see what I get is what's called a query set, but in all intents and purposes it functions like a list, and then in that list there is a series of objects, and it looks exactly like the data that I put in, but it pulled that from the database. And the thing that's in there now is the ID is now in there. So this data has a primary key for every other one of the rows that I put in there. And so I can say that. So I can add a filter. And so you'll see this pattern where user objects, and then I sort of throw these things in, and then the dot values comes at the end. And that's because filter is a method that returns a thing that has a method. So this is the values method that the filter returns. And you can just keep putting these together. So I can say this is like a where clause in SQL. So this basically says give me only, and it's a query set, so it's a list, but there's only one object. Now, there could have been more than one because we don't have any uniqueness constraints on email. There could be more than one record that matched email c7@umich.edu. You can delete, so this is basically, let's go grab that record, but then run the delete method on that model object, model instance. So this will get rid of the TED record. We can go retrieve all of the objects and we can see, oh, there they are, but there's no TED. There was a TED before, and now there is no TED. We can update. So let's check this one again. Let's grab that and pull out. So this, we're going to change this name here. This is in the database, and so we're doing CRUD here. And so we're going to update, create, read, update, and delete. And update's the last one we got to do. We deleted. And so again, we're going to grab all the objects. We're going to filter them down with a where clause to the ones where email c7@umich.edu. And then we're going to set new values. And so if I now say, what is this? Well, the name has become Charles. So it switched from Chuck to Charles. And it's in the database, right? This is not just in memory. This is Django writing all this stuff to the database. Now, just a little bit more, and you can go read up on this, and we'll have lecture after lecture and all kinds of example codes, but you can sort of sort this stuff by email ascending. So A, C, Colleen, CVL, and then K comes later, or we can descend. We can see them descending. So did I get that wrong? Oh, that's in descending order by name. So S, K, C, CO, CH. So they're descending by name. So that gives you just some of the kinds of things that you can do in the Python shell. Let's say quit parenthesis here. Yeah, there we go. Okay, so I hope that you found this this Django for Everybody walkthrough useful. Cheers. Hello and welcome to another walkthrough for Django for Everybody. This is kind of a supplement to tutorial 2. In tutorial 2 you're playing with models.py, and if you go through the tutorial they'll have you do a thing and then they'll do another thing, and they're kind of showing you migrations and how the migrations happen. And if you get them to have a mistake, if you make a mistake, then you can get to the point where you need help or whatever, and sometimes it's easier to just like wipe out your database. But if you've added a question or added some choices or built models, you got to do all that stuff. But it's sometimes just easier to redo some of those things. So I'm going to show you what to do if your model/database gets messed up, and like your manage.py make migrations and migrate are not doing what you think, or they're giving you weird errors. Now if they're getting a syntax error, make sure you do a Python manage.py check right before you declare that your database is messed up. So let me go into my go into my site. So here I am. Here's all my files. So just so here I should do it before I declare that the database is a problem. Manage.py check. And oops. Oh, I messed that up. I'm in my virtual environment, of course. Okay, so we got no issues now, so that's good. So I got a couple commands here. Let me explain this. Before I'm going to actually delete these, I want to show you where the migration. I probably showed you this. So I have a thing called polls 2, and I got all the polls running. So this is like in tutorial 2. The migrations are in files with a number, and they're Python files. So if you recall, migrations are portable representations of what happens in the database. And then the migrate creates the file db.sqlite. So you need, if you want to really start over, you got to get rid of both the migrations and the db.sqlite file, and then you can start completely fresh. If you, I mean, you could sort of do parts of them, but I'm like, if you're messed up here at tutorial 2, it's probably easier to just get rid of them both. So at this point, my application is going to stop working. So I get rid of the migrations, and then I get rid of my database. And so at this point, the only thing I got that has to do with anything to do with my database is a few models.py files. And this is where we are editing our code. And so this pulls to models.py. In my particular example is the code that's going to be effective, because I've got all the versions running at the same time. That's why you're seeing this. So the next thing to do is Python 3 or Python manage.py make migrations. So what make migrations is doing is it's reading all these models.py files, and it's writing this file. So I got rid of that file, but now if I do an ls, you'll see that it's come back. And sometimes you might see an 002, etc., and then you throw it away and you make it fresh, and you should only see an 001, and then you can say Python manage py migrate. And then that, well, if you do an ls, let me control C there. If I do an ls, you'll see that there, oh, wait a second, how come that, oh, the db SQLite 3 is 0 size. So I'm going to do Python 3, or Python manage, sorry, my Mac, migrate. So that's reading these files, plus a whole bunch of other ones, and actually creating databases. And so now if I say ls-l, my db SQLite 3 is back, and I might have to create a super user. If I created a super user account, then I'm going to have to create one again, right? And so I'm going to do that. DJ4E Chuck at umesh.edu. I should make my passwords easier to type. Now at this point, things should start working. But again, if I created any data, like a question or something, it was gone. It was gone at that moment. When I got rid of that database, db SQLite 3, it is literally gone. So it's gone now, and away we go. And so and again, this is just if you can't seem to make these migrations or migrates work, back up, start over, and then redo some of the work. And that probably will be a good way to get things done. Cheers.
Yeah.
Hello, here we are at yet another successful office hours for all the web applications for everybody, Python for everybody, web design for everybody, internet history for everybody, just like MOOC mania. So like always, I would like you to meet your fellow students. So we'll go around and folks, you can say your name and say hi to the students to the extent you want.
Hi, my name is Valerie. Nice to meet everybody.
Okay.
Hi, my name is Emma. This is the best Python course. You have to take it.
I agree.
Hello everybody, my name is Shu Lee. It's really nice to meet you.
Nice to meet you as well.
Hi, my name is Anthony. Python is the greatest and this course is the best.
Thank you.
Hi, my name's Robert. Dr.chuck rocks. He saved my career.
I saved my own career too.
My name is Rosalie and welcome to the course and I hope you enjoy it.
Thanks for coming.
Hi, my name's Matt, and this course helped me get back into coding and move from Milwaukee out to California, so I love it.
Cool. Did you get a sticker?
I did not.
Okay, that's your sticker.
Hi, my name is Lana, and I hope you enjoy this course like me.
Thank you.
Hi, my name is Nick. I hope you enjoy the course as much as I do.
Hi, my name is Ben. I just want to say thank you, Dr. Chuck.
Ben, I don't think you got a sticker.
I did not. Thank you.
There you go.
Hi, my name is Bomik, and this course got me into computer science. Thank you so much, Dr.
Computer
Chuck.
science?
Yeah.
That's awesome. That's really awesome. And I think you didn't get a sticker either.
No, thank you.
So you get a sticker.
Hey, my name is Bobby, and I really like this course, and hopefully this course is going to help me to make a transition in my career.
Yeah, I mean, I hear that story a lot, and I'm really proud of you, and that's really cool.
All right, thank you.
Hi, my name is Alex, and I'm so excited to be here.
And there's some like random anonymous people back there. Oh, never mind.
Hi, my name's Ryan, and I really enjoyed this class.
Now Ryan, I think you already got a sticker, right?
I did get a sticker already.
Okay.
Hi everyone, my name is Andy, and I really enjoyed Dr. Chuck's course, and it's really great to meet Dr. Chuck.
Great, and I enjoyed having Andy in class. So the other thing that we sort of do as a tradition is we give a big round of applause. Did I?
Yeah.
Oh, whoops. And we got a new person. Hi, Wendy. Okay, come on in. So we'll get you just time for the.
Oh, hi.
What's your name?
Wendy Madzinski.
And say hi to the students in the class.
Hi, everybody.
Okay.
Hi, my name is Natalia, and I really recommend Python for everybody. Thank you.
Thanks everybody for reminding me that I screwed up. I mean, I screw up all the time. I screw up all the time. So the other tradition we have in these things is we give a big round of applause for all of the teaching assistants and help everybody out.
You're fine, you're fine.
Oh, I'm fine, okay. So let's give her a big round of applause. So that's another great office hours on the occasion of Web Applications for Everybody launching, and we'll see you next week in Raleigh, North Carolina, I think. So cheers. So now we're going to start producing the actual output of our application in the views and using templates. And there's a lot to cover here. So up till now, we've been starting to talk about URLs, which are simple. It says when you get the request with a URL of this format, choose a view and send it to that view. We're going to talk a lot about views.py and templates. In an upcoming lecture, we'll talk about forms. And we spent a bunch of time talking about models.py and how the models can talk to Python code, talk to the shell, how the models can inform how we write to the database and how we read from the database. So we're starting to fill parts in. As we put the views together, we're really starting to really create our entire application. And I know it's taken a while to get to the point where we can update get to the point where we see the whole thing. So I just want to say that from time to time, wherever you have DJ4E samples, whether it's on your laptop or whether it's on Python Anywhere, you should do a git pull from time to time, because I'm always working on these samples and I want you to make sure you have the latest copies of these samples. Sometimes I add little bits I don't change the samples, but I add bits of documentation as I'm like, ooh, I should have added that. So views are like the core of the application. I mean, the URLs find their way to views. Models tend to serve the needs of views, act as this layer to allow views to write and read the database. And so the views.py
has a model aspect in that it handles incoming data. When we get to forms and post data, then we copy that into the database. The views.py decides sometimes whether or not to send the user to a different screen, or if it's going to produce the actual screen, the HTML, it produces that HTML, often using a template, and then sends it back. So the views are where the work really gets done. And what you see is you write a lot of code in the views. You write one line in the URL, few lines in the models file, and then lots of stuff in the views. And I consider the templates kind of part of the views as well. So the first thing that Django does when it receives an incoming document, a request for a document, it basically parses that URL. And the first thing after the domain name is generally the application. So remember that Django has a project, and then underneath that there's one or more applications. In each of the DJ4E samples, you see lots of applications, each application kind of to show a little bit of sample code for a topic. And so that second part of the URL, that is the application name, and for all intents and purposes it's also the folder name within the Django project. Now within that, usually the next chunk is the view. And so that view within application, the view within application is defined in urls.py. And then after that, there are two kinds of parameters. One is like a key value parameter that comes after a question mark. It also uses ampersands for that. And then sometimes we just put after slashes. This is more of a REST style URL that's very pretty, and you put the parameters right on the URL rather than the question mark, which is sort of the old school for doing all this stuff. So there is this thing in Django called the URL dispatcher. I sort of call it router on my picture. It's basically to get you to be able to define the URLs and how those URLs are to be parsed and handled, and how those URLs to be routed to the various bits of view code. And so we do this in urls.py. There are three basic patterns. First, you might route a particular URL pattern to a predefined class, and you'll see the example of that coming up. Or there's sort of functions, really old school function that take this request, which is an object that captures all of the data, the parameters, the URL, whether it was a secure request or not, what host it came from, what's the IP address it came from. All that stuff is wrapped up into this request object, which we'll talk about in a second. And that view function looks at that request object, decides what to do, talks to the database, maybe, and then sends back a response, whether it's a redirect or some HTML. And the function is kind of the low-level thing, but you can also then define a class. And defining classes, as we'll see, is really quite nice. The classes have methods like for get and for post, depending on the kind of incoming HTTP request that we're handling. And it also, in those methods, the request and any other URL parameters can also be sent in. So let's take a look at a sample urls.py from views. And we see examples of all three kinds of these routes. URL patterns is a global variable. It's just a list, but it has very special meaning. This list has very special meaning to Django. And you see these path commands, and there's other ways to describe these things. And then you have the path, and the blank path means sort of just slash right after the application name. And then we have which view to send it to. And so this template view as view, this is basically to save you from writing code if all you want to do is take a template out of the templates folder and return it. So you don't have to write your own code in views.py. And so it's already there, and that's why we go into Django Views generic import template view, and we're going to say, you know what, I'm going to route, I wrote that template, but I just don't want to write the code to go send that, just read that template and send it back. And so this is a predefined bit of Django that does this for us. Sort of the more old school thing is this syntax right here. And basically from .import views pulls in views/views.py. And then this, you will see our functions inside there. And then these are classes also from our views.py for this particular application. And the syntax is a little weird. This is the module we imported. This is the class from that. And then as view is a static method that returns a function that then can respond to the incoming requests. And we'll see these as we kind of go through these. So up next, we're going to actually look at the views.py and take a look at the views. So now we're going to take a look at the code that actually writes the views, the code effectively in views.py. Now the first view that we're going to take a look at is one where we're not even writing any code at all, and this is that predefined view, that template view. And again, template view is code that a class that's given to us from Django, template view, and you pass it a parameter. So we're actually kind of calling a function here and passing a template name to it, and that is a file, views main.html. So if this is the application views, there's a subfolder called templates, and then I'll talk about this in a bit. We repeat the application name twice, so that's a little bit weird, but it has to do with the fact that these names are global across all of the applications, and so you want there to be possibly more than one main.html, and so that's why you have this extra folder name, and you put this there, even though that feels a little bit redundant, but it's okay. And so this is just a static HTML file. I'm not going to read any data from a database. I'm not going to write any data to the database. I'm just going to read this file and send it back to the browser. And that's a common thing where we just have a file that we want to send back to the browser, and so we just don't even have to write any Python code other than add this entry into the URL patterns in urls.py. So that's a view where you wrote no Python code. Now, for the parts where you're going to write Python code for a view, you're going to be passed in variables. The variables are all about the request object. The request object is all the data coming in, and the response object is something you produce in the view and you send it all back. So the request object is an object instance of class HTTP request. This is a predefined Django, and there's just a whole bunch of things. The scheme. Now, what is the scheme? Whether or not it's secure or insecure HTTPS. The body, it's a string. So there's like about 20 or 30 attributes. We're going to use some of them, but you don't have to use all of them. But you can go look up the documentation, and the more sophisticated your application becomes, the more likely you're going to have to go digging in to find some little bit of the incoming request. You could think of this request data as all that data you see in your browser debugger about what data was sent to the server. That all ends up somewhere in this object. Now, when we return from a view, we have to send a response back. And so the response is something that we create inside of our view. It might be simply text that's HTML, or it might be a redirect object, redirect response that says, hey, go to a different page. And so we make that the main job at the end of the view is to produce a response and then return it back to Django. And so here is a very simple view. So here we're saying, we're in the views application. We're going to go to the view funky, right? And so in the URLs PY, we say map/funky to this function named funky. It's a funky function. That's why I call it funky. And so when it sees this, all the data coming into the request shows up in this variable that is the first parameter sent to that function. So that's what this is saying in urls.py. Take everything that goes to views/funky, gather up all the request data from the browser, put it in an object, and then pass that request object in. Now in this, I'm not really going to do anything with that request object because I'm always returning the exact same thing. And so I just have a nice triple quoted string of some HTML with less thans and greater thans, and I'm going to basically return, it is my job in the view to give back a response. There's a couple, two main types of them. One is an HTTP response, which is just like a body of text, and that's what I'm sending here. I'm sending an HTTP response. That's a constructor. We're constructing a HTTP response object, and taking that string that I put in there, and away we go. Okay? And so that basically, if you hit this path, you're going to get this page back, and it sort of looks like that when it's all said and done. Okay, so now we want to talk about how we can get at parameters. So I mentioned that this request object that comes in to your view function has all the data from the request. Well, if we send to a view with this question mark, key value pairs, that's guess equals 42 on there, and we're going to route danger to views.danger and urls.py, and so all this data is wrapped up in this variable called request, passed into the function named danger. And so inside of request is some data. Request.get is a dictionary of the key value pairs that are on that URL. So to pull the 42 out, we can say request.get bracket, quote, guess, quote, and that pulls that out. And so that's all we've got here is a really simple HTML page, and we are replacing that little chunk with 42. And so whatever this number is comes back out in the output. So your guess was 42. So that's how we pass get data into a view. Now, up next, I'm going to explain to you exactly why it is I called that function danger. So it's important from time to time to talk about ways that you as a web application developer have a responsibility to create secure web applications. And so I want to call your attention to places where you write code that seems like on the surface that it's what could go wrong, and then you realize, oh, wait a sec, that could go wrong. So it turns out that you take data from the user in the request object, whether it's from a form or from the URL, and, like guess equals 42 seems innocuous enough. And then what I did is I just concatenated that into HTML and I sent that back. And so the problem is what if somebody with ill intent tries to produce data that actually does something? And the problem is if I take data straight from the user and put it back in the HTML response, well, HTML and JavaScript are programming language. Your browser is being programmed, and that means that a user typing data into your system can program the browser. And what's even worse is that, having them program their own browser, not such a big deal. But in a way, what they do is they put some data in your system that turns into code, and then they kidnap someone else's browser when they take a look at data that came in. This is called cross-site scripting, where in a sense what it's doing is it's trying to run code so that it can read stuff from your site and then hand it to a rogue site. And so we have to protect against this, and it's a very simple thing. So if we take a look at the code that was bad, basically we have this parameter guess, and in the last time I showed you that was 42. And we just took this request get guess, which is this stuff, and we simply concatenated it into some HTML. Well, if I carefully construct my guess with %C3, blah, 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 all the blah, 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 all that stuff, well, that turns into, this is a URL encoding of less than, B, bold, greater than, bold, slash, so that turns into HTML. So I passed into this application some HTML, and I as the developer took that and I concatenated it together, so the response source has HTML. It's HTML that mostly comes from the application, but this little bit of HTML came from the person who put it in. And like I said, it's not such a critical problem if I in my browser put stuff to take over your browser, but it is if someone, you can move that into someone else's browser. So what happens is the browser sees this bold text in HTML, and instead of showing us the less than and the greater than, it actually shows it to us as bold. Now this seems innocuous enough until you do something much more clever. And that is, I am going to carefully construct some code, JavaScript. And so what happens is this here is encoding of that line right there, the script alert owned /script. And so what happens is that came in and it was concatenated straight out. And if you run this page, you won't see the data, but actually JavaScript will run and it's going to show up an alert box that says owned and OK. Now, you can go ahead and look at the Wikipedia entries on cross-site scripting. Generally, the idea is once you're in JavaScript, you don't just say alert that I've owned your browser. What you do is you do something like grab a cookie and send it to a third party, or you call, say, a web service on the system with a cookie and do bad things. Like you can convince a teacher to log in and change someone else's grade or delete all the grades in a class. Once you're into a person's browser in JavaScript, you can do a lot. So that's really quite scary, and there's all kinds of scenarios where you're taking data from the user, and you got to be careful because, yes, I said the guess is supposed to be a number, but if it's not a number, if I concatenate it without escaping it, it's a problem. So here is a safer version of that. So I've got another view function called game, and it takes that same request, and it still pulls that get data off, which is this bit right here, but then it calls a function, and that's Django utils HTML escape, right? So what that does is that concatenates that into the HTML, but escape processes any dangerous characters and turns them into what are called HTML entities. So less than becomes ampersand LT, greater than becomes ampersand GT. Right? These four things with ampersands are a safer version of it. And so that means that even though I put in the data for bold, it comes out with the less thans and greater than showing, and it's not actually interpreted, right? So this whole notion of escaping or HTML entities, converting data, running the data from a user through an HTML entity's automatic filter ensures that the user cannot provide you data that turns into code in their or someone else's browser eventually. So that's the kind of thing you have to think of as you're concatenating stuff together. And the key thing is the request get guess, that came from the user. And so we think the user's going to be nice, but a user with bad intent can send data that they carefully construct to cause the maximum trouble. But if you just escape your data before you concatenate it, there's nothing they can do about it. So another of the views is where we're going to parse the parameter off of the URL itself. These URLs are a little prettier sometimes than the question mark keyword equals value. And so, so let's take a look at this. The way you do this is in your URL patterns, you have a path, and instead of just having the path name, the view function name, you actually have this bracket, int colon bracket, guess bracket. And what that is, and you can go look this up in the Django documentation, there's a whole series of these things, that says the parameter after the word rest is an integer, and please pass it in as the parameter guess. So I've chosen the name to pass it in as a parameter, and then once Django sees this, it pulls that 41 off and hands it to us. So we don't have to tear the URL apart. Actually, in this request object, we do get the URL. We can do a bunch of splits and fool around, but nah, doesn't matter. Let's let Django do all that work. Let's just tell it we want that parameter after the word rest. It's supposed to be an integer, and pass it to me in the variable guess. And then that same 41 comes in. I am cleverly escaping it before I concatenate it, and then I return a text-based HTML response with some HTML back to the browser. So this escape is there just because of cross-site scripting. I'm still taking this value, still coming from the user. So if any value comes from the user, you have to properly escape it before you show it to them. Now, those are all function-based, which are sort of a lower level. We haven't got to the point where we're talking about forms, but eventually in those lower level functions, you have to check whether you got a get request or a post request. Post request often comes from forms. And so this class-based view allows us to give a method for get and a method for post and let Django pick whether it's a get or a post. And this is an object, and if you're a little rusty on objects, I've got a URL there on pythonforeverybody.com to review just like what a self is. I'm not going to cover all that. In the path command, you just have a string that comes after the application, routing to this. The main view, as view, is something you got to add to it because main view is a class, not a function, but as view is a function. And then we have to create a method get. Self, of course, is just part of Python's object-oriented work. Request is that first parameter, right? And so this one here is just a stock response, and just like the other ones, I return an HTTP response. Now this looks a little more complex than the other one. Did the same thing, but it turns out there is tons of things that we can do. And inheritance, the fact it's a class. There are so many things about object-oriented programming that over the next few lectures we're going to really take advantage of this, and we ultimately will rarely write the old school function-based view. We'll do class-based views. And so we can also pass parameters to class-based views just like we can pass them to function-based views. You say, okay, with a prefix of remain, slug is a kind of string, and then guess is the parameter, so that says pull the string after the word remain off, right? Views is the name of the view, remain is the view within the application, and then this third parameter is the guess, and it's automatically parsed and handed to us in guess, and then we're going to respond to a get request. Self, of course, is the object-oriented thing. Here's the whole request, and guess is that little piece that comes off of the end of the URL. We're going to create a response by escaping the user-provided guess bit so that if the user puts something nasty in for cross-site scripting, we stop them from doing that. And so that produces the same kind of output. Your guess was ABC12342XY, So talking about return values, everything we've shown you up till now is your basic 200 OK, which means you asked for a page, I gave you a page. You're probably familiar with 404 not found, which means you ask for a page, that page doesn't exist. There is another kind of response that's not actually a page, which is a response header that says, you know what, it's not like you made a mistake, but you're at the wrong place. And we call it a redirect, and 302 means I know where you're supposed to be and it isn't here. And it was originally used for sites that would move. And it's all handled by the location header on the HTTP response. And so we send a redirect response, which is a 302 with the location header being set, and it uses our URL. And when the browser gets that the 302 and a location header, it doesn't show you what it just got, but it immediately re-gets that URL and then shows you that URL. And the original idea was that if you renamed a domain or something, you wanted to have the old domain redirect web browsers and search engines, you use these 302s. There's also a 301 header that can be used to redirect all this stuff. But now we use it for all kinds of things, and it's very much a controller function. If you go to Model View Controller, controller says, okay, we're done with that, but I want your browser to go over there. So that routing, that sort of routing the browser, changing the browser, putting the browser where you want it to be, that's part of the application's controller phase. So we can send a redirect from a Django view, and so here we go. If you go to this bounce, it's going to actually not end up at this, it's going to bounce it to somewhere else. And in the path we just say if we go to the bounce view, run to this function. This is not a class-based function, this is an old school function, and so the request data is passed in. And instead of now returning an HTTP response, which we would put in here HTML, we are doing an HTTP response redirect, and now we put a URL. And what we're saying with this whole thing is, you're at the wrong place. Please, browser, when you get this response back, go here. So it's like it bounces to the browser and then bounces back and then reads that URL. So and you can have some output, but folks generally don't need output when you're doing a redirect. So if you take a look at that bounce, watching it in your network console in a JavaScript debugger, what you see is you see a set of 3 requests, actually just 2. You'll see the first request is going to bounce, and if we take a look at this request, we see that it's a 302. It's kind of small. You see we got a 302, which tells the browser something's wrong, I'm not at the right place, and then also the server sends the location header that says this is where you're supposed to be, and the browser immediately turns around and does a get to that URL, simple.htm, and then that's what we see. And then this 404, interestingly, the 3 statuses I talked to you about, is because at this new location, dj4e.com/simple.htm, there's no favicon. Remember, the favicon is the thing that shows up like right there in the top tab bar is the favicon, and I don't have a favicon, at least not now for DJ4E. I should put a favicon there, but we get to see a 404, and all that means is the browser looked for a favicon and didn't find it. So we see a 302, which is moved with a location header, and then we see a get, which returns then a 200, which is a success, and we see the document, and then we see a 404 because it tries to grab the favicon. And so the HTML you get back from dj4e.com simple.htm, that's this simple page with a simple link. Okay, so that's how the redirect works. So that's a series of views, both the input, class-based, function-based, and to both the HTTP response and the HTTP redirect response. So up next, we're going to talk about how building templates makes us do a lot less concatenation. Hello, now we're going to talk about the other half of the views, the templates. And the templates are our way of creating HTML. And again, just to ground everything that we've got here, we're in the views, and the views are really sort of the code, the Python code that we drive. We're going to get to forms in a bit, but views kind of merge stuff from the templates, merge stuff from the models, send stuff in and make pages, right? So this is going to look a lot like HTML. It doesn't have to be HTML. It can be things, but other than HTML. But templates in our class will mostly be HTML. And so they're kind of the last little piece of the puzzle to start building user interfaces. And from this point on, we're going to be making user interfaces rather than introducing the parts of a Django application that have the user interface. So this is the text from the Django website. It's about convenient ways to generate HTML dynamically, and there's a couple of different templating engines. We're using the default one, and there is some data that we pass into the template. There's a process that's called rendering, and then we get the HTML back, and we return to the browser with that HTTP response, which we've already been doing. It's not the request response cycle is the same. The difference is, instead of writing Python code to concatenate a bunch of things together, we are going to use a template engine. So this is the kind of stuff that we've been doing all along. We have a class in a view class, REST main view that extends this view. In comes perhaps the request object, and then maybe even another parameter. That's not changing. What we're doing here is we're using concatenation. Concatenation, these little plus signs. Escaping, we're doing all the escaping and concatenating, and then we are sending back a response. So what goes back as a response, what comes in as a request, what goes back as a response. We're still going to do that. We're just going to get rid of that middle bit and make it a little prettier and make it a little more sense. If you look at that, if you look at it, you got to get it syntactically right. You got indentation problems. That's 3 lines of Python. I'm using triple quotes. I'm using plus. I got to get all that matching together. And then, eventually, I'm going to be in the HTML is going back. I'll be using single quotes and double quotes and all those kinds of things. and JavaScript's going to look really ugly here. Indenting of the HTML kind of will fight with the indenting of the Python. So this is just general. I mean, I've only done short ones because I only wanted to show you a little bit before we showed you templates. So the basic process is a bit of software, a template software that Django provides us. We're using the built-in Django one. And basically template is some HTML with some hotspots in it that says put data here. And then the rest of it is just HTML. And then we pass the data in some kind of an object, dictionary, etc. And then a bit of code pulls all that stuff together and then produces the HTML with all of the data placed in it. Often the render data that we're passing in is coming from a model, for example. We might talk to a database, load up a bunch of rows, and then put it in. But in the simplest form, what we've got is we've got like a little dictionary. Call this the context. You could call it the render data, and then you have the render template. So the render template is really HTML, and that's what makes it a lot easier to look at because you're not putting double quotes around anything. There's no concatenation, but there are special characters. And what the double curly brace surrounding it says is instead of that, take this bit out and replace it with whatever's in the variable dat from the render data. And so that's how, when it's all said and done, this is replaced in the fun stuff, replaces curly brace dat in the final output. And if you thought about it for a while, you could probably write a render engine. They're not that hard. Now you'll see they have some sophisticated features eventually, so you probably don't want to write your own render engine. But you could imagine a Python assignment where I say, write me a function that takes a dictionary that looks like that, and then with key value dat fun stuff, and then take some text file and has curly brace dat curly brace, and then find that and then replace it with that string. You could write that code. You don't want to write that code. Django has already written that code for you. So here's the code in action. And so this is we're going to call this. We're in the application named TMPL temple. And so we have the application temple, we have the view game, and then we have a number 200, and that's what we put in our urls.py to route the game view and take one parameter. Remember that slugs are a special version of strings that are letters, numbers, and dashes, I believe. And so the entire request coming in from the browser is coming into the variable request. This number 200 is coming in the variable from the URL is coming in the variable guess. And so instead of us concatenating together, we are going to create a context. What I call a context, which just is a dictionary of key value pairs. And the key for guess is GUESS. It's a string. That guess will matter inside the template. And then we pull this number 200 and we convert it to an integer, and then we pass it in. And this render, we pass it the request object, we pass it the name of a template, and then we pass the context, the key value pairs, to be substituted in that. So let's take a look. So if we look at this template, it has a series of curly brace, like hotspots, places where you would replace stuff. And so the double curly brace just says retrieve the string that is under guess and put it in. And so that's how we get your guess was 200 in the ultimate output. And then we have curly brace percent all the way to percent curly brace. And this is a series of if then else's. So you can put logic in here too. You don't have to just take this string and put it in. So what we're doing is we're basically saying if the guess is less than 42, we print out too low. If it's above 42, we print too high. And of course, if it is 42, we print out just right. And since our guess was 200, it prints out too high. And so basically this makes this view code a lot simpler and doesn't put a less thans and greater thans and concatenations. It's all substituted by this render routine. Now the render routine returns an HTTP response request. So when we get that back, we just return it. So we hand back to Django the HTTP response request, and then the page is displayed in our browser. Remember that we have a Django project, and this is the Django project. In my case, the Django project is DJ4E samples, and I have a bunch of little applications. All these things, as a matter of fact, Temple is the one we're working at right now. Those are just the different pieces of sample source code that I built for this class to talk about. And so those are applications. So it's just that Django terminology. project made up of one or more applications and folders. Okay? And so the problem is these templates, when Django starts up, based on the settings.py, it loads all these files up, loads them all up. And so it loads them all up, and the templates are actually global, and we'll see this in a bit. They're global across all of the applications. And so the problem is that if you have a template name like detail.html and you have a whole bunch of applications like I do, all of which want to have a template named detail.html, it doesn't work, because which detail.html, it'd be template/detail in two folders. It's not clear which one you're talking about. So we've adopted a convention that we take the application name and we make a subfolder inside of templates. That's the application name. And then we use this favs/detail.html or pics/detail.html as the name of the template. So in a sense, we're introducing a subfolder. It's a little jarring at first because you see there it's the same. It's a good convention. I mean, it's unfortunate we have to have the convention, but because these names end up being global across your entire Django project, in each application, and to get them a name, to get them properly named, it's necessary to introduce this extra level of redirection. And when we get to logins, there's templates that are stored outside in other applications. So sometimes you want to get a template in some other application. So there's all kind of reasons. This is a great idea. It just isn't the prettiest thing in the world. So just when you see it, don't freak out. I try to call it out in the slides. And so we put these paths that includes the application name twice. It's weird, but it is necessary to do this because of the notion that all these template names are global across the entire application. But if then we call this the template name with the name of the application prefixed, away it goes. Django could have made that a little easier for us, but they basically didn't, and so we have to do this. But everybody does it the same way. So now what I want to talk about is the actual templating language itself. I showed you a couple examples, the double curly braces, but it turns out there are lots of things that you can do with double curly braces in the template language. So now we're going to talk about the actual template language. As I mentioned before, there's more than one templating language. We're using the default one. And I think it's actually one of the better ones, this whole notion of double curly braces. There's all kind of templating engines, and a lot of them use these double curly braces. Sometimes there's a one called mustache because the curly braces look like a mustache. So this double curly braces, you learn it in Django and you'll find it all kinds of other places. I've used it in front-end processing. This is back-end processing because we're doing all the substitution in the back-end. So there's basically a couple things you can do. The double curly braces do substitution, and one thing that's cool about this, if you recall, I talked about how you have to escape data that came from the user. Anything in the double curly braces is automatically escaped. As a matter of fact, you have to do something to not escape it, because it turns out that 98% of the time you want to escape data that you're printing out, because it doesn't change what it looks like, but it does make sure that it's safe. If you add this vertical bar safe afterwards, that's like a modifier. I think it's called a filter in Django that says, look, don't run this, don't run that filter on it to do the HTML entities. Just do it as is. I know there may be HTML in that, but I've taken care of that because I am the application developer. You can call functions, like with the code is the percent, curly brace percent. And in there you tend to call a code. This is like code. This is like calling a method or a utility code. And so the first part of this is what you're calling, and then later you can have some parameters. So this URL says, I want to find a URL for the view cat detail, and I'm going to take the number that is the current cat primary key for the cat record and put that on as the URL as well. The author in this case is and we'll see this later, is a model item, and get absolute URL is a method inside that model item. You can have sort of ifs and if then elses. It's kind of Python-like, which is nice in that you don't really have to learn new things. There is looping code. that's in there, like a for loop that we'll talk about in a bit. And then there is blocks that can be replaced. So you can have a template that sort of pulls in another template and then substitutes in part of it. So you can have whole blocks of substitution, not just little strings of substitution. And so we'll talk about each of these in turn. So here we go. We'll start with a real simple one. And you'll notice that in this particular simple one, we have no parameters on the command on the URL. So we don't have any parameters here. I'm going back to a non-class style, just a simple function, and I'm not sending a context. The context would be the third parameter on the render call, and so I'm just saying, hey, and this is what you do when you just have some static HTML that you don't really need to change anything, and so that's what's sitting in here. It's just a simple page. There's this thing called a built-in template view class that sort of does exactly this thing, that just grabs a template, turns it into an HTTP, grabs a file, turns it into an HTTP response, and sends it back to Django. So that's just a super simple template. Now here's one where we're going to take a parameter to the context, and I'm not taking it from the command line quite yet. I'm just going to make the parameter always be 42, and the key is, this is a key and this is a value. So zap in this case is the key and 42 is the value. I often call this variable context, but the fact that's just a mnemonic memory thing for me, context or CTX is what I tend to call it. And now I'm passing in the template, this template here, the guest.html template, and it has one little curly brace substitution, and remember that does escaping for us automatically, so there's no need to use escape the way there was when we were doing this via concatenation. That alone is a good reason to use templates. And so this ends up sending out your guess is 42. So this is just really focusing on what's in that context and how the things come out of the context. This name here, zap, in the context means pull the thing out of the context under the string name zap, and then it substitutes the results, like the 42. So instead of it saying guess was zap, it's your guess is 42. So that's really focusing on the substitution. So this is showing us how we do the save stuff in case you actually want to pass some HTML into a template and actually want it to render as HTML, not as HTML entities or HTML entity style. So we're sending in a thing that's bold with a B and a less than B. That's HTML. It's got less thans and greater thans in it. And then we got zap. And so you can see that the zap comes out as 42. It's HTML entities, but it has no special characters. But if we escape text, text is the one with the HTML entity characters, that automatically escapes it so that you see the less thans and greater thans in the browser output. Escaped, less than B, bold, greater than B, right? And if you say text and then add the safe filter to the end of it, that says don't escape it. And so then this bold goes right into the HTML document, and instead of you seeing the less thans and greater thans, you're actually seeing the text turn to bold. Now, usually the bad folks that are trying to get into your computer are not just turning your text to bold, they're trying to run JavaScript. And all we're showing here is that whatever less thans and greater thans would be in that context value txt, they're going to end up literally in the document, and the browser is going to interpret them as HTML. I mean, there's just no way that somehow your browser knows the HTML that came from your program versus the HTML that came from a context variable, because by the time it gets to the browser, it's all one thing. And so it doesn't know, oh wow, that's dangerous. That came from a variable. No, by the time the response goes back to the browser, it's just a blob of text. Now we can talk about some loops here. I am passing in two arrays, apple, orange, banana, and lychee. And then I'm passing another array called n with peanut and cashew. And then I'm going to create a context. And in that context, I'm going to have fruits point at the list F, nuts point at the list N, and then zap is just the string 42. And do I even use zap in this one? No, I think there's another place that it. No, oh yeah, it's. I just don't have it in the. So here's the template, a part of the template. It's not looking at zap, and so here's the key. So we got this for loop. for X in fruits. Well, fruits is looking up something in the context under the key fruits. They're string. They don't look like strings in. They don't look like strings in the template, but it looks up there and it finds a list. So that little list F is what really is going on here, and F is a list of apple, orange, banana, lychee. And then X becomes the iteration variable. That's only within the template. And then I'm going to print it out, and then I'm going to end it. So that's like the start and end of a for loop. Apple, orange, banana, lychee. Now, you'll notice that I have an LI tag, which is the list item tag, and it just generates all that HTML. And again, the double curly braces are doing HTML entity escaping automatically. So, so we take a look at nuts. So we ask, is nuts present? Because that's a way to tell if there are if variables present or absent. If it's absent, I'm going to ask another filter on the end saying how long was it. Okay, and so this is the n. Nuts is the n list, and it has a length of 2, which means it has 2 elements in it, and so we see the number 2. And so you can do various things. So this is an if then else, the syntax of an if then else, with curly brace percent. Now we can pass objects within objects, and so it's a little tricky. We have a context in this X variable, and the sort of the outer key is pointing, outer is pointing to another dictionary, and in that dictionary there is a key of inner with a value of 42, and then we render the nested.html, and you see the outer, but then outer.inner, so outer is that object, and then object.inner, then this thing becomes 42. Okay, so you can kind of walk through objects if you have hierarchical objects that contain objects, or lists that contain objects, or any number of hierarchical structure of lists and objects. You can walk through them. So here's just another simple example. This one has data coming in instead of hard-coded. So we again have game 200, and we're running into game view. It's a class view, and the 200 comes in as the parameter because we said it's the parameter that comes after the word game, and so guess comes in as 200. It's a string at this point. It hasn't been converted to an integer. So when Django pulls these off, well, it does some validation based on the types, but it doesn't actually necessarily convert them. And so we're going to create a context, x equals a key of guess, and convert it to an integer to pass it in. And then we're going to pass the context in and the template in. And so the word guess is going to come out. And we sort of saw this. The guess is 200. And then depending on the if then else logic, it's going to say, in this case, too high because your guess was 200. And of course the right answer is always 42. So now we're going to talk a little bit about how you manage a common text going from one template to another through template inheritance. So now we're going to talk about a technique called template inheritance. And this and other times, it's a great time to review object-oriented programming, because I'm just going to use object-oriented programming definitions and words and not completely explain them. So you got to know what a class is, you know what self is, those kinds of things. And I've got a great online lesson that you can go read and listen to and understand objects. And I'll explain it to you in 30 or 40 minutes. So inheritance, actually from that lecture, is the notion in object-oriented programming to not repeat yourself. You have some kind of a shape, and then you make a bunch of objects that mirror that shape. But you can also, with inheritance, you can have a shape that makes another shape, like a shape in general that's a triangle. And so you can inherit that all triangles have everything shapes have, and all squares have everything shapes have, and all circles. And it's just a way of capturing information once, writing code once, and then not repeating yourself. Functions are a form of DRY, don't repeat yourself. Modules are, but inheritance is the key. And inheritance kind of can get in our way as programmers because it leads to smaller and smaller code. If we're going to make 5 things, each of these 5 things is really small because we make a big thing over here and we inherit all 5 of those things from it. But then you look at it and like, oh, I don't understand that, right? I don't understand these only one-line functions. What are they doing? Well, the answer is there's 50 lines out here that we're inheriting from. So we'll see some of that. I'll try to kind of allude to that part where, look, there's magic over there. And a lot of what you do in Django is use classes and objects that you didn't even create, meaning that they've got data in them like .scheme or request.scheme. And so this is just also a way of trying to simplify the way you handle sort of things, objects that are handed to you, and then you hand objects to other parts of Django. So template rendering basically says, okay, here's some render data and here's a template. What happens now is there's this thing called a base template, and the base template and the template combine together to be sort of like the ultimate template, and then you pass in the render data and produce the rendered output. So let's just say that we had a bunch of pages and we were doing the same thing over and over again. Now we will soon do this with navigation because you want to put a menu at the top of every page, and literally that menu could be 40 or 50 lines of HTML, and you do not want to repeat that menu every time at the top of the page. So you want to put that one place, and then you want to make many pages that have the same top navigation so that your pages, as you go between them, look like the navigation is the same. So we're going to do this in a very, very simple way. So we have one template, this cond.html that we've been playing with. You'll notice it has some HTML and a title and a body tag and some of this, and then it's got this stuff. Well, let's say we wanted a bunch of pages that had that everything but the body. So what we basically then do is we take parts of this, like the repeated parts, and we put it into a template. And then we take the part that we're going to change every time and we put it into a template that then extends. So see, this one here has one line that says extends temple-base.html. So this one uses everything in here but then adds some stuff. Okay, so the basic idea is we split this one big template into reusable parts and non-reusable parts. And then we have a bunch of templates that come off a base. We call it base commonly in object-oriented world because it's like the thing that we're basing it on. So, you know, this is the base, and then we're going to build on it. Base, build something else on top of it. So how this works in practice, we have a view here. We're going to call this view game2, right? So we're going to use the URL game2. We have a class-based view. We have a get method in there. The request data comes in as request. We told it to parse the slug off the end and pass it to us in the variable guess. We make a template, which is exactly what we did before, where we have a key of guess and the value is the actual guess itself. And then we pass that template in the variable x into render, and we tell it to go read temple con2, which is the condition, the second conditional one. And the thing is there's nothing in the Python code, in the views.py, that knows about the base. What happens is the only place that the base is the only place that the base is noted is in the con2 template itself that says, hey, go grab this one and extend it. Now the way it works is it starts out a little counterintuitive. It says it really says start with this template here and then push this content into the base template. And this block content and end block, it basically, that tells what I want to replace. You're replacing blocks in the base template. So all the stuff in the con2.html that is between the block and the end block is what is then pushed into the base template. And then in a sense, the base template with those blocks replaced is what is returned as a result of the render and then returned to Django as the HTTP response. We're going to use these a lot. When we start doing navigation, we're going to go crazy with these things. So up next, we want to talk about URL mapping and reversing, where we have to actually make a link in one page to a different page. So now we're going to take a quick look at URL mapping and URL reversing. has to do with basically routing, and it really allows us to generate links from one page to another. So we're in the middle of a page and we want to make a link to a different page. We got to figure out what the string of that is. So again, we're sitting here in the middle of our code. We're in the views, and this URL mapping is basically a set of functions that allow us to read the urls.py. In a way, if all these functions didn't exist that allowed us to read urls.py, we would write a bunch of functions to do that. And so these are just now part of Django. And so often these are used in the view. Sometimes they're actually used right inside urls.py to come up. So it's like, if you know the name of a view, what would be the URL to get to that view? And sometimes views have just a URL, and sometimes they're a URL plus a parameter, and that's all set up here. And so it's like, give me a link to a view, please. And then Django looks in the urls.py, potentially across applications, and gives you that string. And it's just to avoid hard coding the strings. That's really the idea. And so this is just a common problem. This is the documentation right from the Django website. You don't want to hard code these things. You actually can, but then if you rename an application, the whole idea is you could make a Django project that had 4 or 5 applications, and then you could reuse some of those in a different Django project and add some more applications. So, you know, you don't want these applications to have too many hard-coded decisions. And it might be easier to hard-code some of these things, but it is actually in the long run much easier from a maintenance perspective. And so it's better maintenance. It's another, don't repeat yourself, or doing a table lookup rather than hard coding strings. It also lets you hunt around in your code to see where it is that you're talking to that other application. Because we're going to do login eventually, and login is another place. It's not in our application, but our application is going to have to generate login URLs by asking the login application, hey, what's the URL to log in? What's the URL to log out? And that's where we'll mostly start doing this. So I want to talk about it now, so when we get to log in and log out, you'll have that will make more sense to you. And it also is some of the stuff that you're doing from the tutorials. You're putting these reverse lookup things in, and you may or may not know what they are. And my goal here is to give you a little sense of what really they're there for. So let's take a look at an example. So here we have our urls.py, and most of it, I mean, this is the application route, so if you're looking in the samples, it's in the route application. The main thing that we've added is some names. Names are here to look up these paths. We don't really want to look it up by this path mapping because that could actually change. So we're basically saying this view in your views.py, second view, is going to be referenceable by this second dash view. I named them differently very much on purpose. So here's what happens if you just go to the route/route, the name of my application. It pulls up this main/HTML. And so the first thing I want to show you is what a hard-coded URL looks like. Now we know that blah 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 samples/route/second is going to go to that second view because the application's name is route and the view name is second, and that's good. That will work. It's not going to break, but this is where you lose flexibility as you try to recombine applications from one into the other. And so in a sense, what we're asking to do here is we're going to instead use this URL utility. And so in our template, we use curly brace %, and then we're running a utility that's been plugged into the template system that is like when we're running the URL function, as it were, and we're going to pass a string to it, and that is within the route application, the view that is named second view. So that goes into this file, the route urls.py, reads down the views until it finds second view, and then it reverse generates the path that works for that. Now in this case, these two strings are going to be the same, and yes, that looks a little uglier, but the key is that we can make changes here, and this will not, the top one, route/second, will not reflect the changes, but if we're looking it up by name, we can do all kinds of crazy things and remap stuff quite naturally. And so again, it's just this URL command, the name of the view, the application, the view. So this is what it looks like when it's all said and done. There's no parameters to this. So if you take a look at this route second view ends up under this hard-coded, the route/second view, the hard-coded ones ends up under the string in the URL output, the page output. We just see it's /route/first is the thing that comes out from running the code URL and passing route colon first view in, so that's what it looks up. And we can make a link. This is now an href, and the actual path is sitting there in the href. So now we're going to see how we do this when we're going from one application to another. So an application we're going to look at in just a bit is this thing called the generic views. It's an application called GView. And we want to make a link to that application, and we know that there are two views. There's a list view and a detail view. And all we have to do is go take a look at the urls.py, and we know that it's an application GView, and this view has a name and that view has a name. The view that is all the cats is got a name of cats, and the view for a single cat is cat. But the cat one takes a parameter. It's an integer number, which is cat number 42 or whatever. And so we're sitting here in the route application, main.html, and we can now go create a URL that actually is pointing to another application and a view within that other application. So this is a URL for GView cats, and that'll just look it up. So now we don't even have to know what the URL patterns are inside of GView/cats. Now, we can look at GView cat, which is this URL, but you'll notice that this has a parameter, and so we actually have to add a second parameter, which is that 42 number. And so this will generate the URL straight to the detail page for a single cat. Now, there's a lot of nice stuff about this. So for example, if you omit this, it's going to look this GView cat up and find it and say, you know what, I'm supposed to have an integer, and it'll blow up on you, right, if you get that wrong. Or if you put a 42 on this one, on the GView cats, you're not supposed to have a number on that. But GView cat, you are supposed to have a number. So this is one of the nice things about this reverse URL lookup, in that we can, there's some error checking that goes on, because if it could just blow up silently, and in many ways when code blows up silently, it's worse than blowing up in a spectacular fashion, because if it blows up in a spectacular fashion, you can fix it. So this is what it looks like. So this GView cats URL and GView cat 42, this one that actually is the detail page that demands a parameter, it constructs that just fine. Okay? So that's going from the route application to the GView application. Now, you can also, this is kind of subtle, and we will need it when we start doing social login using GitHub. So I'll just mention it because we're deep in it right now. And so basically this is actually the overall DJ4E samples urls.py, and that's the one that's pulling all the URLs together kind of in the same folder as settings.py. And so you're pulling in a bunch of URLs, and these live in an application of their own name, but we can actually give them a name of our own to reference them. So you can actually name them, you can reference them with the name they were already given by the application that we're talking to, or we can say, you know what, I'm going to call these social colon or nsroute colon. So if we take this route application and include all those URLs, and we're going to use a namespace of nsroute, you still can say route colon, or you can also say nsroute. And so you can see that in this example, right? We can go to the second view of route, or we can go to the second view of ns. And so there's route. Route is the one way in, but nsroute is our own way in case we somewhere have an application named route or something like that. And so this allows for a second way to access these URLs using a namespace. And it's not in the urls.py in each application. It is in the urls.py for the Django project. So I just finished showing you all that in the templates, but we can also do this in Python, and we'll find that sometimes in like models.py or views.py, or even sometimes in admin.py, we'll need to sort of be able to find a view in the same or another application and automatically construct it. Sometimes in forms.py, we're going to do it as well. And so this, you tend to call this reverse or reverse lazy to look these things up. And the URL feature inside of the template is pretty much just calling this reverse lazy automatically, because the parameters are kind of the same. So I just want to show you how to do some of those things that I just showed you in templates, how you can do them in Python as well. So here's the one in templates. We just have this little plugin to a template called the URL plugin. It takes one parameter and looks up in the urls.py of the first application, the URL named first view. Maybe there's parameters, in this case there's not, and then it generates a path to that, /route/first, right? And so that's how you do it. It's really under the covers calling this reverse lazy. And so these reverse and reverse lazy are from the Django.urls library. And so in this view, there's nothing tricky about this view. It's just a class-based view. We have a get method. We pass in all the request stuff. But basically, we can call reverse lazy and pass it the exact same string, which is go into the GView application, work your way down until you find the cats, or go into the GView application, go in and find the one for dogs, or in this case, this is the dog detail, and it requires a number, and so this GView dog, go find that one, and then the second parameter is 42, so make me one for that. And in Python, U2, and U3 are all just strings, which I'm passing in through some context under the variables x1, x2, and x3. They're really lousy choices of variable names, but I do that sometimes to point out that they're arbitrary and capricious and all they have to do is match. And so then like the x1 matches in this substitution, now we're just doing string substitutions, which is different than calling the URL, but it's still just a bunch of strings. You called reverse lazy in your Python code, and now you're just pulling that string into with double curly braces. And so this is how it ultimately works. We can, we get these, we're just showing how this output turns out, where we go reverse lazy for GView cats, GView dogs, or GView dog with an argument of 42. We pass it in, we replace it, and so this is how it prints out, GView cats /GView dog /GView dog 42. And so that's how that reversing works in Python. And you'll see that certain situations, whether you're like in a model, sometimes you're in a model, it's very common in a model to want to put something about the reverse in it. And the reverse lazy says delay until later to look it up. So up next, we're going to put this all together and ultimately start writing using the generic views, because we're going to look at list pages and detail pages, and in time we're going to look about delete pages and update pages. And Django has these wonderful features that make it work really simply with very little code. But we want to talk about it because sometimes the less code you write, the harder it is to understand.
Here we are in Orlando at yet another office hours, and I'd like you to meet some of your fellow students and let them say hi. So go ahead and tell us your name and a little note to your students if you like.
Hi, my name is Eleanor McCoy Carter, and I love taking Python. I'm taking the first of the series, and it's a great program. I'm here to learn more.
Thanks.
Hi, I'm Joe House. I just finished my second class, and stick with it. It'll pay dividends.
Okay.
Hi, Lexi Casson. I finished the course about a year ago, and it's already been doing great things for my career. I'm a senior data scientist, and I recommend it highly to anybody who's looking to get into the field.
Thank you.
Hi, my name is Chamuka. I'm in the middle of a career change, so I heard about Dr. Chuck and his Python, and so I'm taking it.
Thanks.
My name's Darren Potek, and I've taken the Python course on Coursera, and I'll be using Dr. Chuck's first book the Python 3 book, a little advertising here, to develop a STEM class for a high school in the area, Circle Christian.
Yeah, I'm so totally looking forward to that. I might have to come back down to Orlando just to meet the high school students once this starts.
I think it's great.
Yeah.
We're looking forward to it.
Are you doing it in July?
It'll actually start in August time frame.
Okay.
So.
And I may be bringing my family down in July, so I might be back in Orlando in July.
We'll greet you with open arms. You're always welcome in Orlando.
We'll greet you at Epcot.
Yeah. Say hi, Hunter.
Hey everybody, I'm Hunter. Dr. Chuck is awesome. Take his course.
Okay, so there you go. I don't know where we're going next. I think we might be going to Bletchley Park in a month or so. So hopefully I'll see you somewhere on the net. Cheers. Chuck here. Just finished another wonderful couple hours of office hours here in Breda, Netherlands, where my son is playing at a floorball, international floorball tournament, and we had a bunch of students show up, and I want to let them introduce themselves and say a little bit about the class. So hello, what's your name? And tell me a little bit about the class.
Yes, I'm Karel, and I enjoyed following your courses.
Okay, thank you.
Hey, I'm Jerry. I'm from Belgium, and I just love Python.
So you love Python perhaps a little too much.
I do.
So why don't you just show me or bring your tattoo up so I can see your tattoo. So tell us the story, Jerry, of the tattoo.
I had it done in Kentucky. So
you had it done in Kentucky?
That's right. Yeah.
And so what prompted you to get a Python tattoo?
Because I really love Python, and I really enjoyed the classes with you. So.
Well, thank you.
I've got a new hobby now, so
you got a new hobby.
It for work too.
Tattoos are cool now. They're not. They're not. You're not a bad person if you have a tattoo the way you used to be.
Hey. Hi, my name is Roger. My story is not that spectacular. I don't have any tattoos of Python logos or anything.
The day is young.
That's true.
And we're in the Netherlands.
Yeah. Well, I just want to thank you for helping me with kickstarting with Python, because your course is really like kickstarting me with Python.
Okay.
So.
That was what it was supposed to do.
Thank you.
Hi.
Hi, I'm Becky, and I just really appreciate that I got to take the course several years ago and got started with computer science.
And you're a recovering law student.
Yeah.
That's moved from law to technology.
Yeah.
That's cool.
Hi, my name is Alex. I really enjoyed your courses. Your classes really helped me to get started with Python, and I really liked it. Thank you for everything.
Thank you.
Hi, I'm Ritvika. I really enjoyed your class along with my boss and another colleague, Bobby and Paneet. So if you guys are listening, so it's like I'm covering for you guys. It's great. Your class is really great. Thank you.
Thank you.
Hello, my name is Tanya, and I'm very grateful to Chuck for his inspiration, and I started learning Django 2 years ago.
Well,
Thanks.
cool. I'm going to start teaching Django as soon as I can. Bye.
Hi, I'm Janne. I started the Python course together with Becky, and now I moved on to PHP and actually graduated earlier this week.
You also have an awesome tattoo.
Oh, it's Pac-Man.
Yeah, it's old school. It's an old school Pac-Man tattoo. Waka 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 waka. Oh, and you're chasing the ghost.
Yes.
Tattoos are so awesome. So thanks for watching. I don't actually know where I will show up next. I got a whole bunch of travel in July, so you'll see me somewhere in the United States in July. Cheers. So, hello, here we are. This is a very strange thing. We are at the Para Games in Breda, Netherlands, and I'm here with Team USA, where my son is playing on Team USA in the USA Wheelchair Floorball League, and we're playing in international games here in Netherlands. And so not surprisingly, one of my Coursera students is on Team Belgium. So I'd like to have you meet Thomas and have him introduce the rest of the members of Team Belgium Wheelchair Floorball League. So, hello, Thomas.
Hi.
Say hi.
Hi.
Tell us a little bit about
How are you
your
guys? My name is Thomas, 34 years old, and I'm here with my team, Belgian floorball hockey players. So here they are.
Here they are.
And we have to play against you guys in 5 minutes or something.
Before
so that's going to be great.
Tell me a little bit about Python.
Yes, Python. I have been following your course of Python. It was great. I liked it. It was very clearly explained. Good exercises, so I learned a lot from it. So thank you very much for that.
Okay. Well, thank you for that. Let's meet some of your fellow players.
Yes.
Tell us your name.
Hi, I'm Michael from Belgium. I live in Bruges and I'm 36 years of age.
Okay. So, are you guys leaving?
Hi. Hi, I'm Dimitri, and I might actually take your Python course next. So
okay.
Looking forward to that.
Okay.
Hold on.
That's okay.
Hello, I'm Jonas, 27 years old, and I'm the goalie. I'm one of the goalies of a Belgium national team.
Okay, well they're all really in a hurry because they have to do a team meeting because we're about to play Belgium versus USA. I'll put a little footage of Belgium versus USA in the video. Cheers.
Hello and welcome to Python Objects. I'm Charles Severance, and we're well on our way to getting through all this material in the Python. So this lecture is in a weird place. I even debated where to put it in the book. I don't really want to teach you how to write a lot of object-oriented programming, but we're going to start using objects, and I want to be able to use the terminology. And so as much as anything, this lecture is about terminology and understanding the words, things like methods and method signatures and variables and inheritance. And so think of this as a terminology lecture rather than a learn how to program or learn how to use this. It's not something you're going to figure out right away. And there'll come a time when you as a programmer really want to start using object-oriented programming. It's really a powerful and wonderful technique, but I think it's too early as a beginning programmer to really say, oh, let's write a bunch of objects. So just relax and enjoy and learn this material and think of it as sort of a theoretical thing rather than, you know, a how to program thing. And so part of this is we're going to start reading data structures, and I mean data on how to use all these libraries, etc. And we're going to see the word objects, right? And then we're going to start hearing them. And I want you to be able to read the Python documentation so that you understand what's going on. And so, you know, the word object should make sense to you, even though you're not going to write a lot of object-oriented programming. And so page upon page upon page, database stuff, which we're going to talk about soon, is uses objects all over the place. And the beautiful soup talks about uses objects. We've kind of been using them, and I've been waving my hands, and I use the word method without defining it. But now it's really time to define it and go to it. So I want to review from the very beginning what we think of as a program. So the classic program, my favorite little minimum program, is our little elevator floor converter, which converts from European elevator floors to United States elevator floors. And the key to this is that it's input, processing, and output. And this is a good way to model any program. And in that process, we've got variables, and we've got logic, we've got algorithms, we've got loops that we write, we've got all kinds of things. And we construct a series of steps to achieve some goal. In object-oriented, and frankly, you've been using object-oriented all along, the program has lots of objects, and we're sort of putting stuff into these objects, taking stuff out of one object and putting it into another object. And you've actually been doing this all along. As soon as you're looking at dictionaries and lists, you're doing objects. And so an object is quite a little thing. It's sort of its own little space inside of a program that contains code and data. And so we're working together. All these objects are now working together. It's a bit of self-contained code and data, and it is one way to take a very complex problem and make it easier by breaking it into separate things that can be engineered and developed separately. And so you've been using string objects, or maybe you'd use beautiful soup or something. These are powerful capabilities, and if you had to look at all of them, it's just, hey, here's a thing, use this object, it'll do these things for you, and there's lots of details inside of it. Just don't look at it, don't worry about it. And so there's boundaries, that things that you can use, things that you can look at, and things that really you don't bother looking at. You go read the documentation and use it, and away it goes. But then someone had to write that, and so they built an object. So what we're going to do is look a little bit under the covers of what it takes to build some of these objects. And so if we think of this program that originally just sort of did processing, we can think of it as having some kind of an input, right, coming into our program. And we have a string object, a dictionary object, maybe eventually some objects like a database object or an object that we eventually define. And you can think of as we're receiving data, it comes in an object, which is a string object, where we start putting the strings in dictionaries and do whatever. We pull out a list of them. And so you can think of data as moving between these objects. And like I say, even strings, in the first week, first lecture, first week, first everything, we were using objects, and we've been using them all along. And so you can think of every string and every dictionary as a little program all by itself that has a bit of code and a bit of data. And so a string has the data, which includes all the characters that make up the string, but then there is a method called upper that does uppercase, or rstrip that strips off the right, a white space from the right. And so it's like they're almost little programs that have inputs and outputs themselves, and we can make lots of them. And there's lots of cooperating objects that make up an application. And one of the nice things about the object-oriented pattern is that they form boundaries, and within the boundary, if you're inside the object, you can say, look, I'm going to build you a string object or a database object or a beautiful soup object, and I'm going to build this capability and I'm going to give it to you in the form of an interface, and I'm not really going to care how you use it. And so we have this sort of visibility wall where I'm going to make an object and I'm going to let you use it, and the maker of the object doesn't necessarily have to know every single thing about the use of that object. But so just like inside the object, they don't have to worry about what you're doing with the object outside of it. When you're outside the object, you don't have to worry about what's going on inside of it. We, as the user of the object, we talk to its interface and we get things from it and give things to it and use functionality within that object, but we don't have to look inside of this. We can just say, oh, it's a nice little magical thing. We read the documentation, we read a web page, and it told us to do this, this, and this, and away you go. And so it is sort of this isolation boundary that works both for the programmer who's writing the object and the programmer who's using the object. And so it's a very nice pattern, and so you'll see how we're going to build code and we're going to group it together, and then we're going to be using it sort of as a big blob of stuff. So some definitions in this space, words that I want you to understand. When we're going to create one of these things, one of these objects, instances, that has some data in it and some code in it, we have to be able to define the shape of this object. What code will each object have in it, and what data will each object have in it? And that's called a class. The key to a class, and this little picture that I've got up here in all these slides, is a key. The class is a template. It's not the thing itself. So it's a cookie cutter. It knows a lot about how cookies are made. And if you have cookie dough and you hit the thing, then you make as many cookies as you want. And so this nice little cookie picture is a great, mental model of how it works. The class is the template, and then the object are all of the cookies that are made from that template. But the template defines the shape and the nature of the class. So the code that we write is going of each of the objects. The code we write is the class code, and then later we say, oh, let's take that template and make ourselves an object or an instance. Now, as we're defining a class, we have two basic things that we put in the class, and there's a couple of different terminologies for this. One is method, which is code. It's like a function that lives inside of a class. Not a function that lives inside your program, but one that lives inside of a class. And so this is a scoping thing. A method is really just a function, but it lives inside the class. And then fields or attributes are data items that are in the class. And so they're variables that are defined in the class. You can define variables outside the class that you use in your program, and you've been doing that all along. But if you're saying, I'm going to build this capability, and it's going to have data inside of it and code inside of it, the code is the method or message, and field or attribute. And there are just two different sets of terminology. Method is what I'll probably use. If you look in some object-oriented patterns like Smalltalk or Apple, they often will call these messages. So you can either access a method inside of a class or an object, or you can send a message to the object. The same is true for field and attribute. It's just a chunk of data that's in the object that you may or may not have the right to access. So, like I said, a class is a template. It defines the characteristics of the objects that we're going to use to make it. It is the cookie cutter. So dog is sort of the exemplar. Lassie is a particular dog, and so dog has fur, and dog barks, and dogs do all these things, and so we know something about dogs, but it doesn't mean we have a dog, right? The class is a more abstract concept that when it's time to get a dog, we know certain things about dogs. Instances or objects are once we say, oh, time to make a cookie from the template, time to get a dog, we know something about dogs. That's the creation of an object, and that we call them instances, instance of a class. So the class is it doesn't exist, but we say make me a new object using this class as its template. Oh, and now make me another one, and so we can have many objects from one class. So just like many cookies from one cookie cutter. Method is a bit of code that lives inside of an object. It's like a function, but it's scoped to within the object or within the class. Okay, so that kind of gets us started on some of the terminology, and we'll come back and we'll take a look at how we write code that's object-oriented. Okay, so now that we've gotten through the definitions, let's work into some sample code. But hey, look at this. We've got ourselves a cookie cutter and some cookies. So remember that a class is a template. It's not the actual thing. An object is an instance of a class. So you have to take the class and do something to make the object. And actually you can see here's some other classes. There's clearly a sort of a snowflake class and a gingerbread man class. That's an object, object, object. Somewhere out here there is a snowflake class and a gingerbread class, but we got a snowman object and a snowman object and a snowman class. So class is the template, object is the instance. So here's a bit of Python code. So let's take a look at what we got here. Class is a new reserved word, kind of like def. We have the name of the class. That is a name that we choose. That's the name by which we'll refer to this class for the rest of this program. And it has a colon at the end of it, and which means it starts an indented block, which ends when we de-indent. Inside the class, there are generally two things. There is some data, and this just looks like an assignment statement in the class, x equals 0. And then there is a def. This looks just like a function, and then it starts with a def, has a colon, indents. So that function finishes right there. The difference is this is a method because it lives inside of a class. And so there is no function called party. There's a function called party within party animal class. And we'll talk in a second about this self thing. It is the way that inside this code we refer back to that variable. So this is not actually executing any code. It's sort of remembering the template, defining the class party animal. This is what we call constructing. We're constructing, using the party animal template or class, we are making a party animal. And then once we make that, we stick it in the variable an. And then we're going to call this party animal, this party method 3 times, 1, 2, 3. Now this self thing, and we'll take a look at the self ends up being an alias of an. And so you can look at this syntax as just kind of an equivalent of this syntax. It's calling the party method within the party animal class and passing the instance in as the first parameter. And so self ends up being an alias of an each time these are called. Now if we make a different variable and a second object, which we will eventually, you will see that works a little bit differently. And so this syntax is a short version of that syntax. So if we watch how this executes, it starts up here, it just defines it, and then we construct it. And that's what basically constructing it, we know how to construct it because we look at the class and we make a variable x, we make some code party, and then we construct that. That's what the party animal does, and then we assign that into an. And so an is now pointing at that. Then when we call the party method, that basically takes this an and passes it in as the first parameter, which is used as self. And so self.x, which is what we're doing in this line right here, self.x is a variable. X starts out as 0. X starts out as 0 because when it was constructed it was set to 0. So we're in here, an is an alias of self, and now it looks up self.x, which is 0, adds 1 to it, and so this becomes 1. And then we print so far 1. And then the code returns and it goes down and does it again. And x becomes 2, prints out so far 2, comes back down, and does the last time, calls it again, self.x is 2, add 1 to it and stick it back in, so this becomes 3, and we print out 3. And then the program finishes. And so you can think of this as constructing the object and then associating it with this an variable. Now that we've created this object, we can play around with things we've played around before with dir and type. We use dir and type to kind of inspect variables and types and objects. So we've been using objects all along. This code here says, hey, make me an empty list. Well, it turns out that what we're saying is there is already a list class inside of Python, and we're constructing an empty list, and when we get back this empty list, we're assigning that into X. So X, in a sense, contains or points to an empty list. So then we say, hey, what is in X? What kind of thing is X? Well, it's a list. This is a thing. It's a list type. Lists have list of things in them. And, use append and all the things we've been doing before, they're just objects. And then the dir, if you remember the dir is the capabilities. And there's all these internal capabilities that do things like implement the bracket operator, etc. Those double underscore ones, we can ignore them, although you can even look them up and figure out what they mean if you feel like it. But the methods that we tend to call are in this class. And so things like x.sort, I've always told you that is the sort method within the X thing, and the dot operator is the operator that we use to look something up within an object. And so you've been using this syntax all along. X.sort, dictionary.items, all of those are methods within the corresponding class. If we take a look at this line of code that we've been doing for a very long time, which says, oh, stick hello there into Y. If I reword that as more OO or object-oriented, what this single quote does says, make me a string object and put some text in it, and then when that is done being constructed, stick that into Y, right? And so Y now points to a string object that's been pre-initialized to the string hello there. Now that's a long way of saying hello there ends up in Y, but in OO terms we can talk about that. If we do a dir of that, we see a whole bunch of internal methods which have double underscores, and then we see all kinds of methods that we've been using. We've been using methods like upper, we've been using methods like find, we've been using methods like rstrip, right? We've been using these methods, so we go to like y.rstrip, parenthesis. Again, that's a method, that's an object, not a class, it's an object, and that is the object lookup operator. Now if we do the same thing to code that we've built, or a class that we've built, so now we have a party animal class. Remember, this up to here is just definition. Now we construct it and we store it in an. So an is a variable that contains an object of type party animal. We ask it what type it is, and it prints out here. It says this is a class, and it's main underscore party animal, and this whole thing here is the underscore main. It's scoped to underscore main. But you can see that you have made a new type. You built a type by using this class keyword. And then we use the dir. Remember, dir looks for capabilities. And again, you will see a whole bunch of underscore things. They have meaning. You can look them up. But eventually, you'll see the two things that you've put in it. One is the method party, and the other is the attribute or field x. And again, these are the things that you can say an.x or an.party, because this dot is the object operator, the object lookup operator that says look up in the object an the thing x, or look up in the object an the thing party. Okay? So up next we'll talk a little bit about how objects are created and destroyed. We also call that object lifecycle. Now we're going to talk a little bit about object lifecycle. And what we mean by object lifecycle is the act of creating and destroying these objects. And I've been using this term constructor already. And so when we declare a variable, whether it's a string or a dictionary or a party animal, there we create them and then they're discarded, and there's all this dynamic memory that comes and goes. And we, as the writers of objects, have the ability to insert ourselves at the moment of object creation and at the moment of object destruction. And we make special functions that we call the constructor, the object constructor, or the class constructor, and the destructor. And we don't actually explicitly call them, they're called automatically by Python on our behalf. And so the constructor is much more commonly used. It's used to set up any initial values of variables if necessary, et cetera, et cetera. Destructors are, we'll cover them, but they're used very rarely. So here's a bit of code that we've got. It's our party animal, and a lot of it is the same as what we've been doing so far. So we have this variable x, and the constructor has a special name, underscore, underscore, init, underscore. Again, we pass in the instance of the object, self. And in this one, all we're going to do is print out that you're constructed. And here's this code that we've had before. And now we have underscore, underscore, del, and then we pass in self. And we'll just print out that we're being destructed and what the current value of x is for that particular instance. So let's go ahead and run this. And so again, this doesn't really do any code up to here. That just defines party animal, but this is the constructing of it. And basically that says, oh, and it really kind of creates these variables, and then it also runs the constructor. And so in this case, this line right here is causing the I am constructed message to come out. Then we do and party, and that says, 1 and 2. And here's an interesting thing. We're actually going to destroy this variable by throwing away an no longer points at that object. An is going to point to 42. So we're going to sort of overwrite an and put 42 in it. And at that point, Python's like, oh, this whole little object that I just created, somewhere it's out here, it's vaporizing it and throwing it away. And so before this line completes, it actually calls our destructor on our behalf. And so that message comes out. So we are allowed, as the builder of these objects, to add these little chunks of code that says, I want to be involved at the moment this object is created, and I want to be involved at the moment that this object is destroyed. Now, in this last line, an is no longer a party animal. An is now an integer. It's got a 42 in it. It's gone. It's been created, it was used, and then it was destroyed. Okay? So you got to be careful. If you overwrite something, you can sort of throw the object away. So the constructor is a special block of code that's called when the object is created to set the object up. So we can create lots of instances. Everything we've done so far is we make a class and then we create one instance, one object. And each of these objects ends up being stored in its own variable. We have a variable an and we've been using it. But the more interesting thing begins to happen when we have multiple instances of the same class sitting in different variables. And it has its own copy of the instance variables. So let's take a look at this. So this code here, I've taken out the destructor, and it shows a little bit more information. So now we're going to put two variables in here. We're going to have a current score or whatever, and a name. And we're going to start it out as blank. And this time we're going to add a parameter onto the constructor. And so the self comes in sort of automatically as the object is being constructed. But if we put a parameter on the constructor call, which is this party animal call, then this comes in as the z variable. And so self is the object itself, and z, this first parameter, is whatever parameter we put here. Everything we've done so far has no parameter here, but now we have a parameter here. And then that means that when we call this constructor, this line of code comes, and then name is no longer blank. Name is going to be Sally in this particular thing. And then it'll say, oh, self.name, which will be Sally, has been constructed. And so then we have this, and that object is now constructed, and then we put it in the variable s. And then we call the party method on that, and we construct a different one. And so this time it calls, and z is Jim, and we basically have another copy of this. And so this is how it's going to look. right? As it runs down here, when this is called, it makes one instance and stores that in the variable s. And there's a variable x in there, there's a name in there, there's an init method and party, and that's all in here, right? All that stuff is in here. And now we say, let's make, and that's going to have a Sally in there. All right, Sally in there. And then we're going to do another constructor, and so it's going to make a whole new thing, and it's going to store that in J, and this one's going to have Jim in it. On S party, then this turns into a 1, and then we're going to call J party. That turns that into a 1, and then S party will cause this to be a 2. Okay, and so what happens is we have now two objects, one in the variable S and one in the variable J, and they have separate copies of their instance variables. These are the instance variables or the object fields or whatever, but they're the variables. But the key is that every time we do a new construction, it duplicates this, and there's another copy of it. So there's an X within S. So S.X is this variable, and J.X is that variable. Okay? So the next thing we'll talk about is inheritance, and that's the idea of taking one class and extending it to make something new. So the last topic we'll talk about here in object orientation is the notion of inheritance. And this is a form of code reuse, and it's one of the more advanced aspects of object-oriented programming. So just kind of understand what it is at a high level, and then you know where to come back to when you need to learn a bit more about inheritance. So the idea is, instead of making a new class from scratch, we actually make a new class by starting with an existing class. We are extending it, or another word for this is subclassing. And it's sort of a situation where you're like, I've got this code and I've got this data, and I just need to add a few things to it, and then I'll have a whole new thing. And as you design objects and what we call object hierarchies, you often do this, and it's a form of sort of real clever code reuse. But again, don't necessarily think that you're supposed to know when to use this or why to use this. Right now, it's just terminology, okay? Just terminology. We have what call these as parent-child relationships. The original class is called a parent, and the new class is called the child class. So subclasses are another word for this. You have a class and then you subclass it. I think extending, inheriting, and parent-child are probably better ways of expressing it than subclassing. So here's a bit of code. Let's take a look at this. This code's unchanged. It's the party animal code that we've been saying all along. It's the one that we construct and put a name in. And now what we're going to do is extend it. And so you'll notice that this code down here is the part that's doing the extending. So we're making a new class, football fan, and by putting in parentheses before the colon, party animal, that says football fan inherits everything that is party animal, meaning the X, the name, the init, the party, all those methods and data are sitting there. And now we're going to add a new variable. So football fan has, in addition to all those other variables, it has points, and it has a touchdown method. And, you know, self points is added, you know, we add 7 of the points, and then we call the party, and that does that. So this is calling this method because football fan includes X, name, and party, and init, and everything, and all this stuff, this constructor. So this football fan is really an amalgamation of all these things together. Party animal is just this stuff, right? And so we still have two classes. We don't just have one. We didn't erase the party animal class. And so we take a look at the code that we can run here. We can say, oh, okay, let's make a party animal, Sally. And so that constructs an object like this and then stores that in S. And with an X starting out at 0. And then we call S party. Oops, better change that color. Starts out at 0. And then we call the party method, and that changes it to 1. Okay, and so this bit of code, it's as if this part doesn't matter at all because it is a party animal, it's not a football fan. But now if we take a look at this code down here, take this code down here, we're going to construct a football fan and pass in Jim. But football fan has no underscore init, so that actually uses the underscore init from party animal because we extended party animal to make football fans. So we inherited all of the good that was in there. So there it's going to make a name, a variable x, which is going to start at 0, a variable name that's going to have Jim in it, and a variable points that's going to have a 0 in it. So this j variable has more things in it than the s variable has. And so we can call the j party, and if we call j party, that goes here and adds 1 to x, right? So that adds 1 to x. And then we call j touchdown. Well, that comes down in here and adds 7 to the points, right? And then calls party within us. And so self.party is the current object, i.e. self and j are the same thing, right? Self.party. And then it goes up here and passes self in, and it adds 1 to the x, in this case, of this j variable. So this becomes 2. And that's where it prints out, you know, 7 and 2, and away you go. And so it's a way for you to kind of take all this stuff and stuff it into a class by making a new class and just add the extending bits, the bits that are in addition to the other stuff. So like I said, inheritance is a powerful and wonderful concept. It's a form of, excellent form of reuse, but basically the whole purpose of this lecture was so that I could in the future just use these words and you would understand them as compared to, I just want to say method. And I've been saying method all along, and it's high time that I defined it. So let's just review one last time. Class is a template. It is not actually a thing, it is a shape of a thing. And we define it and say when we make one of these things, it's going to have these variables in it, it's going to have these methods in it. Attributes, variables within a class. Method is a function that's inside of a class. Object is once we construct a class, we get back an object. And so object here is the snowman cookies. Class is the snowman cookie cutter. And a constructor is a bit of code that sets up our object, our instance, when it first is created. And inheritance is this ability to create a new class, but take all and import and affect all the capabilities of an existing class. So, object-oriented is awesome. For the rest of this class, we're not going to write any object code, we're not going to use class at all, but we are going to use objects, and literally you've been using objects from the beginning of this course. As soon as you said print, whoops, as soon as you said, you know, x equals high, that's an object. And as soon as you said x.upper, you were calling a method, right? You've been calling a method all along. When you're doing something like fh equals open, this thing you're getting back, that's an object. And then you do fh.read or whatever. You're calling a method in the dot operator. So you've been using objects all along. I now am just finally explaining to you when I say call the read method or call the upper method or what's this little dot and why is that there? So again, it's time for us to understand that, but it will take you a long time before you encounter a problem that's large enough where as part of your solution, you're going to make a new object. But when you do, it's really a powerful thing. I mean, it's a really bad idea for me as a teacher to say, oh, write a bunch of objects. It's like, it's premature for that. It's later is when you will actually learn how to use objects and you'll be like, oh, thank heaven that these objects are here. Okay? So, that's all for now. Thanks for listening. See you on the net. We're on to our last mini lecture about views, and it's a big one. It's about generic views. It's a really big lecture so that we end up with little tiny views with one line of code. So I've been building up views, and we've talked about inheritance with the templates, and now we're going to talk about inheritance and views. And we've been inheriting all along with views. So here we are in the views.py. This whole thing, these particular kinds of views, we define them in views.py, but they're very informed by the content of model.py, which means that views are constructed automatically just looking at the data in the models.py. So it's again sort of the logic of don't repeat yourself. If you have a thing in models.py, you've defined exactly what the fields are, and things like, you know, what the help text is for this field and what the description for the field is, that has nothing to do with the database, but it can inform the views. And so it's just a way for, you'll see how it all fits together nicely, but sometimes when we use these super awesome techniques, we end up with a little tiny bit of code, and it's really important to deeply understand that tiny bit of code, because you can sort of just fade away and not realize what's going on, because this code is so cleverly reusing a ton of other code and pulling stuff in from other places. So if you go all the way back to, we talked about SQL, the 4 basic operations are put data in a database, get data out of a database, delete that data, or update that data. CRUD, create, read, update, and delete. And we're going to build a bunch of things, whether they're add things or auto things, where we got to insert an auto, update an auto, delete an auto, list all the autos, insert a cat, delete a cat, list all the cats, update a cat, right? And so we have a bunch of user interfaces that we're going to build over and over and over again. And as you build your own projects, you'll probably have 4 or 5 tables and then little CRUD user interfaces for each of the tables. And sometimes you make them a little different and there's pretty stuff on them and they're customized. But surprisingly often, these things just look the same and we end up repeating ourselves, which is something we don't want to do as software developers. So here is a simple CRUD application. It's the cur, create and read. Or no, actually, it's this one here is only read and detail. So we have a list of cats, and then you click on the cat list, and then you see the data for a particular cat, and then a link back to the list. So this is like a detail page. But we're going to do a lot more than that. But this, I just want to show you how these generic views work by keeping things very, very simple. So we're going to talk about a generic view in the list and the detail, which are 2 of several generic views. So this is our GView application, and here's the urls.py. In this GView, it has a list of cats, an individual cat, a list of dogs, an individual dog. And so you see this sort of repetition. And I'm putting so many of these in here because I'm going to show you sort of different approaches to implement them using less and more detail and less and more inheritance. So they're all kind of the same. I give them a name. You know, some have integer primary keys, and away you go. And so here is the cat list. I'm going to start with a template. So we're going to expect in the cat list template that there is a context variable called cat_list, and that is a list of cat objects. And then we are going to iterate through the cat list, however many cats there are, with inside of a list, and generate an li tag, and then create a link URL, and then pull out the name of the cat. So the cat has a name, and the cat has a primary key, and so we are going to generate a link to the cat Sophie, and underneath that link is the link to /cat/12, whatever that number is. And if the cat list is empty, we're going to say there are no cats in the database. Now we've actually got a script that you use to preload all of this data. So there's instructions in the sample code as to how to preload that data. Take a look at the README for it. And so if we're in the detail page, we're going to pass a cat object in, and that has a name, and then we want a link to go back to the cat list. And so again, we're using something from the immediately previous lecture where we're using the URL macro, passing in the name of a view within an application. So this is the GView applications, the cat view, and then that makes for an href, that makes a valid link with the string go back to list to be the thing that does. So we're going to build all this stuff, and that's the basic idea, that template and the HTML, that's how we're going to do it. But we're going to look at how the views work. And again, this is a reminder of the dry principle, the don't repeat yourself principle. Again, sometimes this dry principle gets us in trouble because the idea is that some bit of logic is placed one place and reused as many places as possible, because don't repeat yourself would probably be as well described by calling reuse, 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 reuse. Do it once and then reuse it as many times as possible. So that if you have to fix it and you got a bug in it, you don't have to find the 49 places that you put all this code. And because we do the same thing over and over and over again, cats, dogs, horses, we do it over and over and over again, cars. The idea that you have a list view, a detail view, an edit view, etc., it's a common thing. And really, if you're going to do this stuff, why not make it look consistent and function consistently? If you have one developer build the cat's editing interface and another person develop the dog's editing interface, and they like go off the same, go off in their own way, and they got some groovy design, but it's different, who cares, right? It's inconsistent. So consistent, you still want a beautiful design, but you want the cat's data and the dog's data to make sense with that consistent design. So both of them can have a nice design. So we got templates. The templates expect variables, like the list expects a thing called cat_list or dog_list or whatever, and then the cat detail just has a cat variable in it, and then we call it. So if we just forgot about all the stuff that we're about to learn and we just wrote a view, it would look like this first one, this cat list view here. And so we would inherit from view. We're going to go to the database. We've imported the cat model, cat.objects. This is the way to query all the cat objects and get a list of cat objects and put it in the variable stuff. That's what cat.objects.all does. Now we've done this before like in the shell, but now we're doing it in actual Python code in the views. Like I said, views are where all the stuff happens. So that says make a database call, load all the cat records, turn them into objects, and give me a list of those objects. And then I'm going to pass in the context into the template, the gview/catlist.html, I'm going to pass an entire list. And if you go back and look, there was a little loop in the template that printed out, Sophie, Frankie, and made links underneath them into the detail page. Okay? So this is how we would do it if we were going to not repeat ourselves. Okay? Now, this next way of doing it for the dogs, we're going to do it another way. And so what we're going to do is, it looks like it's more work, but it's more reusable. So the stuff that we're doing here. So what we're doing is now we have a dog list view, which is just a class, and we're going to create an attribute variable in this object called model. And we're just going to say that this model for this particular one is dog. So the idea now is in this get method, we take this code right here, and we said cat, make that be generic and have it be driven by this one variable. Okay? Now the tricky part that makes this a little tricky is sometimes we're just using the model, and then other times we are going to actually turn it into a text string. So if we take a look at this, boop, boop, we have this variable model, and in the get request, self.model is the way refer to the particular instance that we're in, that model variable. And this little meta verbose underscore name title to lowercase. You can figure that out by yourself by going to Stack Overflow eventually. That's how I figured it out. I wanted to get a lowercase version of the model name. So the model's name is a string DOG, which is not the same as the dog model. Okay? And so that just is a way, model name is going to be lowercase dog. But if model is cat, then model name will be lowercase cat in this bit. So I'm trying to make reusable code. So yes, the reusable code looks a little more complex because it's generic. But you'll notice that I'm creating a variable called model name underscore list because I'm just concatenating it together. So it's model name and is going to be dog underscore list. So that's what's going to happen. I am going to talk to the model and retrieve all the objects. That's okay. I don't have to change it to a string. Self.model is dog.objects.all. So then I'm going to get a list of all the objects and stuff, and I'll put that in the context. And then I'm going to go get myself a template out of the GView folder with the model name underscore list, so that what used to be cat list in here is now dog underscore list. I'm concatenating it together, and I passed the context in. And so then when that happens, then you get a dog list and some list of dogs, and away you go. So what I did is I generalized this code and put it in here, and then I passed in a sense, to the object that was made from the dog list view class, the actual model that I wanted it to operate on. Okay? So I do this to give you a sense of how this works. You can do the exact same thing for horses by doing this. And that is, you import the generic Django Views generic right here, and you say, I'm going to make a class called horse list views. I'm going to extend not just view, but generic list view. So this is a generic class. You can go look at the Django documentation for this. It's a generic class that does a list view in general. And the rule for the class is you have to add one line here to say which model it functions on. And that's it. And that's because the get code is already in this model. We're extending that model. We're inheriting all this code, not from dog list view, but instead from generic list view. So we took something that was 5 lines, a little more generalized, it's like 8 lines, and now it's 1 line. And so that's how the extension works. But you have to trust, and you have to go read the documentation for list view to know how it is that you inform it as to what model you're supposed to use. So I want to show you a little bit of how this is happening by making one of these list views that's mine. It's not as cool as the real Django list view, just to give you a sense of what's going on behind the scenes in the Django list view. So if you say, so I'm going to make a new class, DJ4E list view, and then I'm going to extend view, and then I'm going to have a get method, and it's going to be all this code. It's looking for a variable called model, and you'll notice that it's not defining model up here because it's intended that this is a class that's going to be reused. So I'm going to say, oh, well, whatever the model is that's been set up here by the class that's being created while we're extending it, go grab that, convert it to a text, get the title of it, and then convert it to lowercase, make that model name. Whatever the model is, retrieve all of its objects and put it into stuff, and then put model name underscore list, you know, in this case car underscore list, and then pass that list into the template, and then render, you know, gview car underscore list context. Okay, so this is not doing anything per se. DJ4E list view is creating a class that I'm going to extend later, and I'm going to extend that 2 lines later. I'm making a car list view that extends DJ4E list view, and the only thing I need to do to get all of this code in here is extend it, and then I do need to add model equals car. So you'll notice that car list view has the exact same syntax as horse list view, right? Horse list view, you basically tell it, the generic list view, tell what model to work on, and then generic list view does it all. And if you look at car list view, it says use this generic list view that I just invented to show you the source code of what it is. That's the source code behind the scenes. Like I said, it's way more complex and sophisticated than what I did. This is the crudest, simplest version of an extendable generic list view. But when it's all said and done, you don't write any of those versions. You literally make a list view and tell it what model it is. You make a cat view and tell it what model it is. And you just reuse the list view over and over and over again. So the fact that I give you 4 different ways to do this, yeah, I think 4 different ways, maybe 5, 4 or 5 different ways to doing this. The real way to do it is one way, but when you look at code like that, you're like, horse list view is an extending generic list view and the model is horse. I'm trusting a lot. And the answer is, yeah, you get used to it. And now the code you have to write is only 2 lines of code. And you have to write the template still because it's going to call your templates, but it knows the name of the template by looking at that horse, right? It knows, oh, horse, oh yeah, horse underscore detail, right? Or horse underscore list. And so this is the actual detail page that shows you the horse and goes back to the list, etc., etc., etc. And so using these generic views, you can make things really short and really succinct and really simple. So generic views are excellent. They allow us to produce lots of similar pages without repeating ourselves. They keep your code consistent. They the repeating yourself, doing the same thing over and over, even if it seems quick to cut, paste, change, cut, paste, change, cut, paste, change. If you really want to build reliable code and code that's thousands and thousands of lines with hundreds of features, you don't want to be able to you don't want to be pasting the same thing over and over. And so less lines of code means fewer mistakes. So this is kind of the end of our talk about views. It's really where we're going to start doing most of the work. The URLs, the models, they sort of don't get the kind of activity. Although we are going to talk upcoming about forms, which touch on views, and they touch on models, and they touch on templates. So forms are one of the things that lets us take our user experience and really up it. So we'll see you soon.
I was trying to characterize what is C++ particularly useful for, what did I actually build it for, and what is its strength today after almost 30 years of evolution, and also where's the limits to where it is. So the way I see it is there's a core domain for C++, and that's what you would call traditional systems programming, but that's not the right term, because it's just a style of language and a style of programming. So I go a little bit further. I said, what is it that requires the kind of services that C++ has? What is the sum of all these applications I've been dealing with? Where did it work, and where was it essential? And I came up with the phrase infrastructure, and I roughly define it as if it breaks, somebody gets hurt or somebody gets ruined. These are the kind of foundational things in our systems that must work for the system, for the society to work. The question I'm trying to phrase is what matters in those areas. And I've come up with some notions of compact data structures, very strongly typed interfaces for maintainability and for minimizing errors, a heavier emphasis on algorithms over random code, because we need reliability, we need the stuff to be comprehensible, analyzable. We want to make sure that it's actually correct. And so the paper I was writing come from that kind of thinking. What is the right style, and what are the supports for that style we need for infrastructure software, for software that must be dependable? And we can get real examples, sort of the keys of some of the modern operating systems, the basics of our phone system, the brakes in my car. How do we make that dependable? How do we make sure that the space probes don't get the logical equivalent of the blue screen of death halfway to Mars, where we can't send a repairman? How do we make sure that they actually go into the right orbits? And JPL lost a probe off Mars because two groups had communicated nicely, they thought. But in fact, one of them spoke imperial measures and the other one spoke the SI system, the MKS system. And the result was a misnavigation that sent more than $500 million worth of equipment into the wrong orbit. Not a good idea. It was the work of 200 good engineers, lifetimes work, down the drain. And that could have been avoided by ever so slightly improvement in the interfaces between the parts of that program. So things like that I'm interested in. So there's a core area where I think the facilities for C++, the kind of, they're not perfect, but the kind of things I would like, the kind of things I work on are essential. And then there's a huge gray area where you have choices. They can help, in my opinion, but they're not essential. Then you have areas where it probably is unsuitable to apply that kind of stringency technique. I mean, I want to essentially get 100% reliability. If I'm putting up a small application for my own use, or if somebody is trying to push out a little cute web app, they don't need that kind of reliability, and maybe what I'm talking about in terms of programming is not for them. But I think the really important thing here is to realize that there are different techniques, different languages that apply to different areas, and we have to recognize this. We can't have a single language for everybody, a single technique of using that language for everybody. We can't have a single tool chain or a single kind of system. And from there we can go a little bit further. We probably don't need the same kind of training for education for everybody. The engineer, software developer, or whatever that is building infrastructure, say the mechanism that automatically updates the software on a cell phone, has to have a different education, different knowledge, different training from the one that makes a little game. Because the one can actually destroy a whole day or a whole week for millions of people by a little slip. Maybe even somebody gets hurt. If the 911 calls don't get through, bad things happen. And it's not just the software that runs on it, it's the update software, it's anything in the chain of safety critical issues that has to be dealt with. But somebody doing that has to think differently from somebody who writes a little application, maybe to make a couple of bugs quickly. There's nothing wrong with that, but they have to think different. As a matter of fact, if you apply this very stringent engineering-oriented thinking to little commercial apps, you'll probably be a year late to market, and it'll be irrelevant. On the other hand, if you took the attitude of first to market is the only thing that happens, and apply them to the steering wheel of my car, no, that's not a good idea. These people have to think different, and the way you get people to think differently is to give them different educations. We don't have an ANSI standard programmer, and we shouldn't have. If it was, we should have several. And I think the field has to, in some sense, clean up its act before somebody else comes in and try and cleans it up for us.
This notion that you can sort of make your own constants and have the seconds after the constants, is that a feature that you added at some intermediate stage, or is that simple sort of operator overloading?
We were observing that we were getting a whole zoo of little suffixes out of the various fundamental types. So the U suffix is for unsigned, and L is for long, I think, and I can't remember them all anymore. And we thought, you can do anything in C++, but you can't make your own literals. And then I had observed separately that there was techniques that were effective, except that people would not use them because the notation was too ugly. The Unix example is Unix example is one of those. You've been able to do everything in the Unix example I showed. Not quite as elegant, but you can do everything showed for the last 10 years. Libraries have been available. There was a nice one from Fermi Labs, back to nice places and nice people again. But it wasn't used as much as it should because the users didn't believe in the notation. They didn't like it. And so we were looking at how can you basically clean up people's source code. How can we make code look the way it would look in an ideal language? How can we make code look much as it does in the textbooks? So the Unix example is simply a way of getting your code to look the way the equations look in your physics textbook. I mean, we know how to avoid that Mars climate orbiter problem. Everybody had been taught it in physics in high school. First make sure your units match, then do the detailed calculation. So why didn't people do it? It was too cumbersome and it was too ugly when they did it. Or too costly if they used runtime techniques. So I, together with friends, we thought this problem was worth addressing, tried to figure out what solutions we had, went through several evolutions. I think the last finishing touches was done by David. And it's now standard. This is one of the features that is not shipping widely today. But wait a year and that example will probably run on your computer too.
Are there other kind of examples where you've let people from within a class create their own literals beyond sort of suffixes?
When I started out with C++, I provided constructors, which allows you to construct objects of a certain type from arguments. And that has been very effective, and people have used constructors as if they were literals, but they weren't. There was a runtime cost. So the first thing we did with C++ OX, C++ 11, was we introduced constant expressions as a more fundamental unit. This was work between me and my colleague Gabriel Das Reis. And we have const expert functions that can be evaluated at compile time. And we have const expert types so that you can use type-rich programming at compile time. This is very important in sort of the high-performance computing and in the embedded systems world. That was what we did to address that. Constant expression evaluation is much more general, much easier to use, and yes, more pretty in C++ 11 than in earlier versions. So that just strengthens what the direction we've gone before. So you could write complex 1, 2 to make a complex number in C++ in 1984. Today you can write the same thing and have the complex number created at compile time, and therefore say put in ROM. I don't know why you would want a complex number on ROM, but you might want a point, which is the same thing, point of 1, 2. Now, you still have to write point or complex. And the other thread of thinking in C++ was to generalize and make safer the initialization. And so it happens that if you know the type you need, like you have a function returning a complex number, you can simply write open curly 1, 2, and it says, oh, 1, 2 is supposed to make you a complex number, and it will make a complex number and return it. And if you happen to be at compile time, it'll do that at compile time. So things work together, you get better notation, you get better performance, and anything you can do at compile time works even better in a concurrent system because you can't get a race condition on a constant. If it's been calculated before the program starts, you can't get the threading problems.
So open curly means find a constructor for the thing that I'm about to put this in.
Yes.
It looks at where the destination is,
yes,
and it says, is there a two parameter constructor or a 3-parameter constructor or whatever?
Or if it's just a struct, it'll take the first element and put it in the first element and the second.
It does it for a struct as well?
Oh yeah.
See, I haven't played in C++ in a while. That's a great idea.
I refer to this as uniform and uniform initialization. It'll initialize if it can. And if there's any ambiguity, it of course finds the ambiguity. If you're in a context where like you're calling a function and the target could be a point or a complex number, it's a tough luck. Go and try again.
Or tell me.
So the error checking has actually been improved. C++ 11 is slightly better at finding bugs than C++ 98 was. I mean, I come from the school of philosophy that says that the compiler is your best friend when you generate code, when you build programs. And to make it your best friend, you actually have to have more types. If everything is an integer, well, what can the type system help you there? No, it can't. If everything is a floating point number. It can't tell you whether it's imperial or SI units, and you get bugs. So you need type-rich interfaces, and for that you need to be able to build cheap types, basically, and flexible types.
And convenient.
Types that's easy to use, simple. And so we worked from complex of 1,0, 1,2 or something like that. So curly is 1,2, and the type is optional, it's only needed when it's needed. And then finally, we can now write, if we wanted to, 1 plus 2i. Define I as the unit for the imaginary parts, and you get complex arithmetic without ever saying complex.
Hello everybody, we are here in Cape Town, South Africa with yet another wonderful office hours just down the hill from UCT, University of Cape Town, and as usual I'd like to introduce you to your fellow students, let them say hi and a little message, whatever. So here we go. So, yeah, you'll be first.
Hi, I'm Kirsty, I'm doing a PhD in bioinformatics and the course is really helpful to me.
Thanks.
Hi, my name is Kabango. I did take this course last year. Now I'm doing machine learning. And
machine learning, great.
Hi, I'm Rian, and I did the course last year. It's my first programming, and now I can't stop.
Great, great.
Hi, it's Jeff here. Yeah, no, I did most of the Python courses last year, and I've just been enjoying all the MOOC ideas, and yeah, just keep programming and do your thing.
Cool.
I'm Stephen Markup from UCT, and my email address features in the Python MOOC.
Yeah. So Stephen is famous in the Python MOOC. He's in chapter 6. We parse his email name to find at UCT ACZA. So Stephen, famous email address. I'll put something over top of you that says something about your famous email address.
Hey, hi everyone. I'm Joseph. I did the internet history course, and I found it very helpful. I'm also doing the Python for everyone.
Great, thanks.
Hello, my name is Dari. I started with the internet history course. I have a telecommunication background, but now I work as a web developer.
You work as a web developer?
Yeah.
You weren't a web developer before?
No, mixing the two.
Oh, cool. Cool.
Hi, my name is Joey, and I finally met Dr. Chuck. Thank you for the course.
And I finally met Joey. And
cool.
I had to come all the way to South Africa to meet Joey.
Cool.
Hi, I'm John, and I'm an engineer, and I use the Python I learned every day at work.
Cool.
Hi, I'm Kat. I'm also an engineer, and I really enjoyed all of Dr. Chuck's courses, and I hope that there are going to be a few more coming out in the future.
Yes, indeed. Okay, so could you point it back at me again? Okay, so there you have it, yet another successful office hours. It was really, we had a great time. We almost got kicked out of the coffee shop, but we didn't. I think the next office hours might be in Denver. So if you see this, maybe we'll see you in Denver. Cheers.
Hello and welcome to our lecture on forms. There's actually quite a few lectures here because we're going to talk about how forms work in HTML and HTTP, and then we're going to talk about how they work in Django. So forms are the way that we put HTML in browsers that have fill-in-the-blank areas. And so the idea is that you draw some fields and some places for the user to type, and then you have some way of sending the data up to the server. And so we'll take a look at a number of different ways to gather this stuff up and send it to a server. There are two basic ways to talk to the server with form data. Everything we've been doing when you do an anchor tag is a GET request, which means you're going to get a document and show it. And you can put parameters on the end of those, like the question mark guess equals 42. You can put that on the end of a URL. But then what we're going to really introduce and talk more about is the notion of posting data. So in forms you can actually do getting or posting. And so let's take a look at some code here. So this is a little bit of utility code that I'm going to use over and over and over again because because the get data and the post data and even the cookie data and stuff come in as dictionaries. They look like dictionaries, key value pairs. And so I just wanted a way to dump the data. I want a little label, probably should call that guy label, and then a dictionary. And so I'm just going to retrieve, go through all the items and call HTML escape so that we just don't end up with HTML cross-site scripting injection. Just print the keys and values out and put some paragraph tags and stuff like that. So it's just a way to dump this out so I can show it to you and not put this code on every one of my slides. So just remember that that's what dump data does. And here is a little form that prints out a form and then retrieves the form. So you'll note the dump data, if there is no data in request.get, it doesn't print anything out. But this ends up producing a form, right? And there's a form tag, there's an input tag. Input is the painting. Just put some text out, and then this label, this box here is the input type equals text, name equals guess, size equals 40, and then we put a submit button out. And we can type some stuff in, and we can hit the submit button, type 42 in, and hit submit button. And you will notice that once this submit button is hit, it adds automatically onto the end of the URL that it came from, $guess equals 42. And then it sends that back and does another GET request, but this time it does a GET request with $equals 42. In comes this guess equals 42 is put onto the request.get, and then we dump it out so we get to see the key value pair of guess equals 42. And again, Django's taking care of all that parsing and everything before we get to it. Now, this is pretty much the exact same thing. Later we're going to talk about this CSRF exempt. This is to keep it as simple as possible for now. And all we have to do is tell that we would like to communicate this same form of data, one input field and a submit button. We're going to communicate this from the browser to the server using the post method. And so this is a communication to the browser when the server says, I would like to send this data using the technique of post, not the technique of get. And so, it prints out, we put in the number, we submit it, and so the first thing that you'll notice is there's no key value pairs, and that's because the post actually transports the data to the server in a different way. And it appears in a different key value pair. We can tell whether it's a post or a get, and if it's a get, we get our get parameters in request.get, and if it's a post, we get our post parameters in request.post. And so we still get the same guess keyword equals the number 42. Okay? And so that's simply the two ways of transporting it. And this is talking about those two ways, right? The browser has a form, blah, 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 input type equals guess. And the name field, name equals guess, is the field that is going to tell what the key value pair is. So if you're going to put a post, you're going to hit the submit button on a get form, it does a get to wherever it came from, right? And then appends the key value pair to the end. And again, that goes into Django, which parses it and puts it in request.get, etc., etc., etc. And if all you do is you tell it with a method equals post, then it chooses a different way. So the post is going to the same URL, but there are no parameters here. And so there's a series of headers like, what is my preferred language, etc., etc., what I'm using for my browser, the content type is this application URL form encoded, and that's talking about this. Now remember, this is going into the server, so the content type coming out tells if it's an HTML page or a JPEG, but the content type going in tells the server how to parse this. So it leaves a blank line, it's very symmetric with how the server sends us pages back, and then guess equals 42. Now, there's some complexity here, and there's some complexity in that post data, and there is some complexity in the get parameters where if you're sending special characters, there's ways they have to be encoded, but we're going to ignore that for now. Just understand that the reason you don't see the parameters on the post request is the data has been transported as part of the HTTP connection, and it's later on in the connection after all the headers have been sent. So you might say it doesn't matter. Well, it does matter. So there's a couple of simple rules. The post needs to be used when data is going to be created or modified, and we'll see situations where we force this, where you don't want to delete something on a GET request. If you're reading or searching, GET is great. It should never be used to insert, modify, or delete data, anything that's going to change the state of the system. And part of the problem is that web spiders will find GET requests. So you might, if you build a bad application, like a catalog of bearings, for example, and you have a delete that happens to be a GET request, and a web spider grabs your page and hits all those URLs, you might find that the web spider just wiped out your database. So web spiders do not follow posts because they assume that by following posts they might be changing your data, but by following gets, they're just reading your data, and that's all a web spider really wants to do. Unless, of course, it's doing some kind of automation. So get URLs are supposed to be idempotent. So the idea is if you say blah, 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 guess equals 42, it's supposed to kind of give you back the same page. Now, that's like saying, you know, blah, 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 current calendar. Well, what is the current calendar? It might be, it's not identical, but it is sort of semantically the same thing. So you're supposed to be able to go bookmark a get. You know, you can bookmark a get URL, but not, like you might say, where's my inbox? You know, here's a URL to my inbox in some kind of a system to read my data. And so you can bookmark that and go back to your inbox. It should be a GET request. You shouldn't be bookmarking posters. The other thing is that depending on your browser, your web server software, etc., you may have an upper limit on the GET. Let's just think 2,000 characters. Doesn't mean you should worry about it too much, but just large things, especially when we start uploading files like pictures, then all of a sudden the GET is impossible and you have to use post. And it also has the advantage that post doesn't mess up keeps your URLs looking prettier. So next we're just going to do a quick review of the kinds of things that you can do in forms in HTML and different kind of input tags we can show in our HTML. So now we're going to do a real simple run through of the kinds of things that you can do in HTML and forms. This is only the beginning, and there's so many great online resources for how to do forms in HTML. So I've already showed you the basic text field. We'll talk about the password field, radio button, checkbox, select and drop down, and I just got kind of this one HTML page that you can view the source of and borrow. I kind of write this stuff up for me for a quick reference. So we've already talked about the text field, right? So input type equals text, and then the name is the value. The ID, don't get too stuck on the ID. The ID has to do with how you associate the label tag with the field, and so that knows that somehow account and this text box are connected. So the ID is more of a browser thing, and the name equals is the thing that it's going to be sent to the browser. So the browser is always going to get key value pairs. And so, you know, when we type Beth and we hit submit, then we're going to get the incoming post data is going to have the value account equals Beth. Now, if you look at password, that's a type. Password, for all intents and purposes, is a text type. And it shows it so people can't shoulder surf and see what it is. Of course, they can watch you type your password, but it shows asterisks in the box while you're typing. But then it's important to realize that once the data is submitted, the data is submitted in plain text. And so here's another one, another nickname. So nick equals NICK. So that's basically the variance of the input types of text. Hidden, type equals hidden is another one where you just don't see it in the user interface. We're going to use one of those input type equals hidden in a bit. A radio button is designed for situations where you can only pick one of two things. So when you hit AM, the PM goes off. When you hit PM, the AM goes off. And you can actually have a whole bunch of them, and you can click them. Now they're drawn together because they're type equals radio, and then the name is identical. And interestingly, you can scatter these literally all over the page. It doesn't lead to very good user interface, but away you go. And so what happens is again, no matter how many of these you put with a name equals when, no matter where you put them on the page, if you click one, all the others are going to turn off. And so the one that's clicked, they all have different values. And so what will happen is whatever one is clicked at the moment that you actually send it, that will be the key value pair, where when equals PM, because only one can be selected, and it's up to you to make these things unique. Or maybe you don't want them unique. You do whatever you want. And so in this case, the PM one is selected, so we see when equals PM, in the incoming post data. So that's a radio button. So this is a checkbox. This is probably more useful in many ways. Checkboxes, you can have as many that you want, and each of them are individual and distinct. So if you take a look, for example, you see that you have different names, class 1, class 2, and class 3, right? So that each checkbox has its own name, but the checkboxes are actually just little checkboxes. The text here is just text. The text is not really a critical part of it. The value is what will get sent if that checkbox is checked. And so in this example, we've checked Pi4E and SI539, and you'll notice that 2 of them have values and one of them doesn't. Now the key is often you're just checking to see if the data is there. In this case, class 3 is not in the post data, and class 1 is on. That's the default. If you don't say value equals, it's like value equals on, or whatever the value is that you put in that checkbox. And so you get to decide these. You might easily think that you don't need any values whatsoever because you're really looking for the name of the field, and you want the name of the field to be distinct. And so again, you can check as many of the checkboxes as you want. You can uncheck them, you can check none of them, and you can check all of them. So those are checkboxes. So to describe a drop-down is a multiple choice option basically for a single value that's going to be sent back to you. And so we have a select, which is the whole thing, and that gives the name, the keyword that it's going to be sent back to. And then we have a series of options, and you'll notice there's no value on the select, but each option has its own value. Right? So I happen to be going 0, 1, 2, and these are strings, not numbers. They often are just numbers to make our lives simple. And then you have some text, etc., etc., etc. And so you pick one. In this case, I leave it default, and I hit the submit. So soda is going to be equal to 0. So this happened to be the one that's selected when we hit submit. Okay? So that's what a select looks like. You can also make a select that has some defaulted one, and so you just put selected on one of them. So that means it's the drop down. They're all there, right? They're all there. If you click on this thing, you'll see, if you click on which snack, you're going to see all the different snacks. Peanuts is pre-selected. And if I don't change it and hit submit, then we're going to see snack equals the value, which is peanuts. So that's an example that you don't have to make numbers, although it's really common to be using numbers. So that's a drop down with a default other than the first item. The default is it's the first item unless you do it otherwise. When you're typing in comments or a blog post, a big long blob of text, you use a text area tag. The text area tag is a little bit different in that it doesn't have a value equals. It does have a name equals. It has rows and columns to tell how tall it is and how wide it is. There are clever styling libraries that make these a little prettier. But basically what it is, it's a series of text, including paragraphs, including new lines, etc. And you're just allowed to type with new lines and edit and cursor around in here and build all kind of stuff. And then you send it in, and you can put default text in here. You can edit the text, you can change it, and it comes in as a key value pair with new lines and everything and any weird spacing that you might put in. But it's basically a block of text like a comment or like a comment or a blog post or something like that. So the last thing on this page here is the submit button. And so you can make a type equals submit, and you can give it a name, and again that's a key value pair and a value. Now the submit is a little bit weird in that the value actually appears on the submit. What we tend to do is this submit, and if you're in a multi-language environment, you're going to want that to be whatever language of the user. So usually what we do is I carefully name the variables, or the name of the form, and then I check for this to exist. And if I have a bunch of buttons, I name them differently and don't really actually look at this text because that text might want to be translated at some point in time. So that's an input type. Input type equals button. This is a little pattern where I'm going to do like an escape or a back or something like that. And then sometimes it's easier just to do a little JavaScript. And what this little JavaScript chunk is, location.href equals quote www.dj4e.com return false. What this says is it actually sort of, when you press this escape button, it goes up in the browser and in effect pastes this little URL into the URL bar and then hits enter, and return false keeps the form from being submitted. And so this is a way that I often will put a simple cancel or escape or something else in a form. Just if I know the URL I want to go back to or go to, then you can put it in here and click location.href. So those are the input types that have been around for probably 20 years. Yeah, at least 20, 25 years. HTML5 is a more recent phenomenon, although by now it's pretty well supported in most browsers. Defined a whole new set of input types. And what's nice about this is we were slowly but surely building complex libraries to solve all these problems. But now we can use these input types, and now each browser can support them to their own way. And they all fall back to type equals text. And so if you have a really old browser, these don't cause trouble. So here's just some samples of some things. So type equals color is a color picker, and that's going to pop up a color picker, let you cruise around. That color picker is defined by the browser and usually the operating system, and so you'll pick a color, and then that color is going to go in hex format, and that's the red, the green, and the blue. And so that's what colors look like. You can have type equals date, and so here's a date, and they pop in here. You're going to pop up a date picker for the birthday. You'll pop up a date picker, and you'll be able to kind of move around and pick a date, and then that'll put that date in as a string. They're all going to turn into strings when they're being sent in. A couple of the other ones, like email, name equals email, that basically does validation that says it's got to have an @ sign. There's some rules about what is and isn't a valid email. And so this will refuse to submit this form unless there's a valid email in there. The same is true for number. If you put something that's like 25 and it's not between 1 and 5 with min and max here, it's going to refuse to submit the form. The same is true for a type equals URL. It's really a validation on the form to say, look, you can't put something in here that's not a valid URL. And just to prove that it doesn't matter, if you make any type, which flying doesn't exist, you can type something in and it just functions as a text field. And so in a way, all these fall back to text fields. Now the key thing is when you hit the submit button, normally that gathers up the form and sends it to the server. But when you use this HTML5 validation like date, number, email, URL, it actually will, before you hit the submit button, before it actually sends it, it's going to do a quick validation on these things. And it will actually stop and say, you know what, you didn't get that one right. And it just refuses to submit. So you can't override that in your application. What happens is the data doesn't get submitted at all until, so the browser blocks the submission of the data. Now if it's not an HTML5 browser, it's going to get submitted with no validation whatsoever. So we still have to kind of check this data for sanity, which we'll talk about soon about how to do that in the server. But this is quite nice because it gives your user some immediate feedback, kind of customized to the browser, so the browser takes some responsibility for helping get the user to type the right stuff in. And so that is a romp through HTML forms. You will learn so much more. I just wanted to kind of cover some of them in case you hadn't seen it in a while. Now that we've talked about forms a bit, I want to talk a little bit about security in forms. I want to talk about a security issue called cross-site request forgery, or CSRF. So the idea of a CSRF attack is that a rogue site, it has to do with cookies and how cookies get sent to sites. So let's say you're logged into my site, and a rogue site generates a page that's going to post. And on every form you can post to a site other than the one it came from. And so if I can get data that I want to send to the legitimate server, the rogue site can set up a post, and then if I can convince you to hit the button, then it will grab the cookie and send it to the legitimate server that you're already logged into and perhaps do something dangerous. And so the rogue server doesn't need to know the cookie. The rogue server just needs to convince you to click on a rogue form to send to the request server. So the defense for CSRF is to, don't be confused with session. It is going to use session. We're going to grab another large random number, and we're going to call it the CSRF token, and we're going to stick that in the session. And then what we do is every time we send a form out that's coming from our server, we add a little input hidden tag that has this CSRF token. And then when the post comes in, we check the CSRF token that's coming in the post data, and then we check it against the one that's in the session, and then rejects it if it doesn't match. So here's a picture of how this works, right? So we'll have a legitimate server, right? We're going to produce a page by the legitimate server, and it's going to post back to this same server. The action is the URL to send the post data to, and we got some key value pairs and a submit button, right? So you hit the submit button, and it's going to come back to the server. Now, one of the things that the browser is supposed to do is pull the cookies for that server and send it. So it sends it both a post and the data, but it also sends the session ID cookie. And then what happens is that the Django gets its hands on it. It looks up the session ID, pulls it in, and notices that it's C7 and I've been logged as an instructor, and then I can actually change this grade and set the grade, and it works. Okay. Now, here is what happens when you get to a CSRF attack. So somehow a page gets sent to the server, right? Sent from a rogue server, and it just has this form. Method equals post, action equals DJ. It's not the action, it's going to a different place. And it puts sort of a new grade and then a submit. So what happens is this submit comes in, and the browser dutifully appends the cookie to it, and it sends it. Now, you had to be tricked into getting to this page and sometimes tricked into submitting the page. But once the post comes in, it has the legit cookie in it. The cookie is used to look up the session and reassociate it, and we can check in the session that the user is indeed logged in, and we'll let the thing set the grade to 1.0. So this would be a way, if you could convince a logged in instructor to run a post form that you created, you could basically change your grades. So that's how it works. That's how a CSRF attack. You have to be tricked twice first, but there's ways in JavaScript to make it so it's hardly noticeable that you get tricked. So if you do this with CSRF, the legit server basically adds another value, not the session ID, but another value in the session, which is a large randomly chosen number. And then when a page comes out, it's a legit page, and it uses a type hidden variable and puts the CSRF value in. Now you hit the submit button, and the CSRF is coming in as post data. Your regular data, the grade data is coming in, and the browser dutifully appends the session. And so then using the session cookie, it reassociates the session, says, yep, you're C7, you're the instructor, and the CSRF works, CSRF matches, so let's go ahead and let you set the grade. So we let them in. With the attack blocked, because the rogue server can generate a page, but it doesn't know what the CSRF is. So it could, who knows what the CSRF is, so it generates it. Maybe it can put a CSRF, but it doesn't know it. So then the post happens, and all the data gets gathered up, and so it sends the CSRF, but it's not the right CSRF. The session ID is sent in, and so the session is pulled in. We know it's user C7, we know it's instructor, but we're going to check to see if the CSRF matches, and then it blows up. And so then you just refuse the post, probably log the user out, and then log some kind of a security error. So the idea is by having this little CSRF number in the session, we can then take care of that. So like most things, Django comes out of the box with CSRF protection built in. Just like the session, we've got CSRF middleware just dropped in, and actually it works automatically. You don't even have to ask for it to work. Once you have a session, it starts putting out CSRF things. So up next, we'll talk about, now that we know the concept of CSRF, we'll talk about how we're going to use CSRF inside of forms to implement sort of CSRF protection. now that we've introduced CSRF conceptually, let's talk about how we actually implement it running in Django. So if you remember, I didn't really point this out too much when we went through it. This was my first form where I showed you how data could be transported to the server using a post request. If you look at the top, I have this little annotation at CSRF_exempt, and there's a little import above it in the views file. And what I was basically telling Django is don't blow this up because I'm not handling CSRF properly. So what we're going to do is we're going to do the exact same view, except we're just not going to have that little thing. And so we'll call this one fail form, and we're going to throw out a form. We're going to press submit. Everything looks fine. The only difference is I did not turn off CSRF processing. So on a post request, CSRF processing is on by default, which means that we have to do something explicitly when we're making post forms. But I didn't do it yet, so this is what happens if you don't do it. So you get a form and you press type some stuff in and you hit submit query, and boom, you get this forbidden message. That's a 403. So among all the HTTP responses, we've got 200, which is okay, we've got 302, which is moved, and we got 404, which is not found. 403 is you're not getting this page, but not because I don't have it, but because you're not authorized to do it. So this is it aborting and stopping the post. So it comes in, it looked up the session, and everything looked good except the CSRF did not match. Now, we are a legit server, so what we've got to do is we've got to actually add the CSRF to the post on the way out. Okay, so this is the exact same post, and I'm doing this kind of at a low level, and we'll show you a much easier way to do it in a minute. So we have an input hidden. I just happen to know that CSRF middleware token is the proper name for it, and I'm just going to have a placeholder which is __ token. And so then what I'm going to do is I'm going to talk to that middleware, CSRF, get token. Now that token is probably just a number sitting in the session, but I don't need to know that. I just say, hey, give me the token for the current request. The request is, of course, all that data that's coming in. It's got the sessions, got everything else in it. So, hey, give me that token. This is a big, long string, which is really just a big, long, random number, a big, long, random string. And then what I'm going to do is take whatever that big, long, random number is, and I'm going to replace this little bit with a stir, a simple replace, and then I'm going to send that out. So this time, when we go to that page, you'll see that now we have an input type equals hidden, name equals CSRF middleware token, and then the big, long middleware token, whatever that is. And then now when we submit it, it bundles up both the guess and the middleware token, and it actually bundles up the submit as well if it's got a name, and sends that in as post data. So now when it dumps out, you see, oh, well, you got guess equals 42 and CSRF middleware. Now, by the time it's got to this point, we're not really doing the checking here. The checking was done before the view started. And so if we go back to the view here, the checking is done before it gets to here. When you're dispatching from a urls.py to this, and it says, you didn't tell me not to do CSRF, and it's not done properly, so I'm going to blow you up. So if it's going to work, it's already worked. The fact that we've come in here and we're dumping this stuff out of the post, that's just sort of like we see it, but it would have blown up before it would have even got to our code at that point. But we do get it and see it as post data. We don't need to, because if by the very fact that our view is running means that the CSRF processing has been successful. Okay? And again, the rogue system has to somehow get its hands on this, the actual number of the CSRF, and that changes every time you log in, and literally it could change every hour or so or whatever. And so it's a hard number to guess, and it's a hard number to get your hands on. Now, that manual thing is not the easiest way to put this in. There's an easy way in CSRF. You simply say, so here's our form, here's our /form. I do all the stuff I want to do that I want to do, and then I use the code. This is called a template tag. When you have CSRF enabled in your Python, you have a template tag of CSRF _token. And that emits the input, the type equals hidden, the right name, and all that stuff. So you, as the developer using templates, you don't have to know anything about that. Okay? And so that's how we do CSRF. And the only other thing we got is a guessing game, and then we're going to pass a message into that, and we're going to do that in a bit, we're going to use this for a whole bunch of little examples. So kind of remember this particular guest.html template. But the key right now that we're talking about is the fact that we've got this CSRF token in. Now, I'm going to write a bunch of guessing games, and these guessing games I'm actually going to start checking the guesses. So I'm going to have a function in this view that's called check guess, and it's pretty simple. It returns a string or false. If the guess is an actual non-false thing, we check to see if it's too low, too high, or right on time. Or if it doesn't convert, if this int guess throws a trace back, well, then we'll say bad format equals guess, and then just because it probably came from the user, we're going to escape it and then send that back. So whatever it does, we're going to send back a nice little message going back. And so here is a simple guessing game that we're going to do. And so if you, so we're using a view-based view, a class-based view this time. Of course, we extend the class view. And remember how it works is it's not just a function. We actually have two methods. One is a get request, and the get is called when we're receiving get request, and the post is called when we're receiving a post request. This alone is one of the nice reasons to do this. You don't actually have to say, if it's a get do one thing, if it's a post do another thing. We just have two methods, and Django properly routes the requests in. Okay, and so this is going to be a form post. So on a get, we just render with no messages. We render with no messages. And we have a CSRF token that goes out, so we just render it. Then we'll click the button so that this render right here will produce this page. Then we type in the guess of 42 and we hit submit query, and then that bundles it all up, including CSRF, and goes to the post. Now the CSRF, as long as we put it in that template, we don't have to care, because before that post method gets activated, CSRF has been processed, and we get a 403 if the CSRF isn't right. So if we go back up here, and you don't put this in, and you run this code, this CSRF token, you don't put it in, then when you hit it's never going to make it to the post. I mean, it blows up en route to the post if the CSRF doesn't happen. But we've got CSRF, and it's all automatic. We just throw that one line inside of our form, and that's all we've got to do. So we put 42 in, we hit submit query, passes CSRF, it comes in. So we grab the post data, the guess from the post data. We call my little check message, check guess. That's going to give me that little message, whether it's too low, too high, or some kind of other mistake. And then I'm going to pass in a context. The string message has that string. And if then we go, do I have it down here? No, I have it up here. So then the message comes out. So this, you'll notice I've surrounded this by an if, so that if message is false or not present, then it doesn't put anything out. But if it is, it actually puts the message out. And so out comes the guess. And so this is what it looks like when we do a get request, right? We see this. Then we're going to see all this, stuff. We're going to type our number in. We're going to hit submit query, and then it's going to fire up a post request. And so then it's going to come back into the post request. It's going to get the guess from the post data. It's going to check it, and then it's going to pass the message in. And so the message is going to come out here, and then we're going to return that page. And so you're going to see something like congratulations 42. So that was part of the post, and so we now have made a successful guessing game. So next we're going to talk about, just when we get something working, there's always something that we have to say, oh, but there's a little detail that we forgot about. So up next we'll talk about post and refresh, which is a little problem that we're just going to have to fix. So these forms are kind of complicated. There's a lot of little details. Once we get them, then we'll be able to knock out forms and just do form after form after form. So I call this little section post refresh oops. So remember this little page not so long ago where I'm like, look, it's great. We did CSRF and we checked it and it worked great and we put the CSRF token in and it's all good. Well, it turns out from the heights of success is the depths of failure. But it's not too bad, not too hard to fix it. So we just got to fix it. So the problem is if the browser sends a post request and it gets back a 200 and a page of HTML, which is exactly what we just did. And then you hit the refresh button on your browser. The browser is going to resend the post request. And if you go back, I said post requests are things that change. So for example, if you are transferring money from your account to someone else's and you hit the transfer button, it's a post and money gets transferred. And then transfer successful. And then if you hit refresh, you're going to post it again. And so the refresh basically reruns the entire previous transaction. It doesn't just grab the page, it sends the post data again. So if you transferred $100 in one post and you hit refresh, you're going to transfer $100 again. So what happens is that because the browsers know that posts are potentially dangerous to the server, the user will get a pop-up, not from you, but from the browser to say, hey, this person who built this server application left you sitting on a post and you hit refresh and I'm going to about post it again. So are you sure you really want to do that? And the problem is the user doesn't even know what a post is, barely knows what's a refresh, and it looks like a mess. So the way to do this is you go to the page, you type in 42, you hit submit query and it'll say congratulations. And you look at it and then you press the refresh button, the reload button. And you press the reload button and it says, to display this page, Firefox must send information that will repeat an action such as a search order confirmation that was performed earlier or a money transfer. That is not a message from your application. That is literally because your application was a little sloppy and Firefox is like, I'm really not sure if we should do this, so I'm going to ask the user. But it doesn't exactly know what to ask the user. It doesn't know what you just did. And so it's a yucky message, and what we want to do as programmers is avoid this. We want all the message, all the user experience coming from us, not having the browsers take over some of these things. And so it's just bad practice in general to send a 200 post, to take a post request and then send a 200 with an HTML page back. Okay? And so it's just ugly. The browser asks, it's out of your control, it's ugly, it's bad usability. So we can do a little bit of work to make this never happen. And so that's what we want to do here. So the way we do this is through what we call post, redirect, refresh. So up next, we're going to show how we're going to fix all this using a post, redirect, get, refresh. These titles keep getting longer and longer. So now we're going to solve the problem of a post followed by a refresh. And we're going to use something we've talked about before. We're going to use a redirect, right? So the basic rule is never send HTML as a result at the end of a post request. In a sense, if you're going to return something at the end of the post method, return a redirect. Don't return HTML. Now, we got to eventually get them some HTML. So we redirect to a page that we know, and then that will cause a GET request, and then that page is what we will show. So the question is, handle post, send a redirect, and then redirect to where? Now this is kind of controller, right? We talked about model view controller, right? Controller is, oh, something happened and I'm going to move the user's browser from here to here. So redirecting, when we're redirecting, in a sense, that's a controller function. So we often do our redirects from the views. Or we're saying here, you're at the end of this view, you know what, I don't actually want to show you a page right now. I'm going to send you to another page so that that page you see with a GET request. Now we often send ourselves back to the exact same page. We take a post from on a page and then we redirect right back to the same page. So to remember, we got 200 OK, which is a nice page. We got 404 not found. We saw 403 not authorized before, and 302 is found and moved. And we're going to reuse this redirect capability, but we're not going to do a wild redirect to a site completely outside of our site. So this is a diagram from Wikipedia that's talking about the post redirect, and on the left side we have the problem where the user fills out some kind of a form, does a post, changes the data in the server, we send back a 200 request, it says your order was successful, and then the user hits the refresh button. Now the key is this only happens if user hits refresh, and then the browser asks, are you sure you want to do that? And if you say yes, then it's going to order twice or deduct the database twice. So the solution is for us to have the user fill out the form, click a submit, send a post request, do the actual transaction, insert an order or do whatever, and then send a 302 redirect, and then the browser instantly goes blink, blink, blink. There's no, the browser instantly turns this into a get, potentially right back to our same page, and then we send the page back that says your order was successful or whatever, and then if the user refreshes that, it just says over and over, your order was successful. Okay. Now, one of the things we're going to also show you when we do this is that we might actually have some kind of a message in that moment of post, because that's where we got the post data, and then we've got to pass that to the next request, and we're going to use the session to do that, and then the message can come out. So this whole your order was successful, often it knows the order was successful in the post code, so we have to send this to the next request, and we use the session to get it from the post request to the next get request. And that's a technique called flash messages. And I'll show a simple way of doing that, and then later we'll show a more complex way to do this Django style. Okay, so here we go. This is actually the nice way to do this, right? So when we first go to the page, we're going to go do a get request. We're going to see if there's a message. That's that incoming message, but it's the first time, so there is no message. We'll talk about that in a second. If there is a message, once we've got it, we're going to delete it from the session, and then we're just going to send the guest.html with the message, but the first time to message is false, so you'll see no message, right? So the first time through in a GET request, it runs this template, there is no message, and then the CSRF token is there, and so we get to see that as our GET request, okay? So that is the GET request. So we then put in our guess, and then we press the submit button. That gathers all that data up and sends a post to the browser. And so that post will end up, after CSRF checking, will come here because it's a post. And so what we're going to do is we're going to grab the guess, which now is coming from the post data. We're going to check it, and message is just a message of too high, too low, etc. And now, instead of rendering, which is what we did before, we rendered right here, we're actually just going to set that into the session under message. We're going to store it, and then we're going to send a redirect. And we're going to send a redirect to request.path, which means that we're actually telling the browser to do a GET request right back to us, which means it's going to come in here. Then it's going to read the message, and then the messages are going to come out here. Okay? So that's how the post happens. Let's go through that again. We get the post, we grab the guess, we check the guess, and we store our response to the guess in the session, and then we redirect back to ourselves, which comes into the GET. We pull the message out of the session, we delete the message from the session, and then we actually render the page. So you get the original GET request, you type in your guess, hit the submit button, went to the URL awesome, but it came back with a 302, not with a 200, and with a location that says go back to get post awesome. So that's the same URL that we posted to. We posted to the URL. And if we look underneath the response, we'll find that that's empty. Okay? So on the post request, there is nothing in the response. There is no page, because what we're seeing here is the result of this GET request. Okay? So what happens is that the browser sees the 302, sees the location, and immediately turns around and does a GET request. And then that GET request has this page. And then it's going to get a favicon, which is just another GET request. And so this is the GET after the redirect, and we can see the data that's associated with it. And it's got, this one actually has a real response. It's a real 200. And then we have the real page, and that renders it. And then it grabs the favicon just so that it can put a nice, cute little favicon up there. Now, if we hit refresh, so we sit on this page, and we hit the refresh, then what will happen is it'll rerun the most recent thing, and the most recent thing that we got was this GET request, which means it does another GET request. Whereas before it was redoing the post request, and that's why it was complaining. So you get no message, you get no problem, you get absolutely nothing. So it's actually really quite pretty. So here is the pretty little way of doing it. And the simple rule is, and the first rule is, at the bottom of a post method, you should be redirecting. If you're sending a message, you're sending a screen back at the bottom of a post message after the data has been handled, then it's a mistake. So the steps are, we go to the page, we do a GET request, there is no message, so we get sort of the page with no message. Then we do a POST request, the POST request comes in, we check the guess, we put the message in the session, and then we redirect, and then it comes back to a second GET, pulls the message out of the session, deletes the message from the session, and then renders it with the message and everything. And that's called flash message pattern, in particular because we're deleting it after we've shown it to the user. So next we're going to switch to how Django actually has forms.py and makes it easy to construct forms. So we're not going to be writing a bunch of input tags or option tags or select tags. Django makes this a lot easier for us.
Hello everybody, here we are in London in Shoreditch, and we had at very last minute a office hours, and we got a few people that showed up here at the Blues Kitchen, and I want to introduce them and so they can say hi to you and whatever it is they want to say to the rest of the class. So tell us your name and say hi.
Yes, I'm John. I work a few minutes down the road, and I'm delighted to have got to meet Dr. Chuck. I'm having a great time on the course. Thank you very much.
Thank you.
Hello, my name is Farah and I live in East London, and I've taken the course back in 2015 and I'll be taking the new Python 3 course soon.
Great.
Hi, I'm Fergus. I've been taking a couple of courses back in November with Dr. Chuck. It's been great. Thanks very much.
Thanks. So I think the next place that I'll be seeing you is in South Africa in a couple of weeks. So cheers. Chuck here. We're in Kyoto, Japan. This is the first office hours that was held in a karaoke box. We didn't do any karaoke. We did eat a lot of food. It was mostly just a quiet private room that I could get my hands on. And so I think I might start using karaoke box as meeting places in the future, because it did worked out very well. So as always, I'd like to go around the room and have you meet some of your fellow students and let them wave and say hi and say a little something about the course, how they feel about it, okay? So, hello. So tell us your name and say something about the course.
Hello, I'm Barrett. I'm from the States, but I live here in Japan. I'm actually teaching English, but I'm looking to transition into educational programming, thanks to Dr. Chuck, hopefully.
Oh, cool.
So, yeah.
Cool.
Hello everyone, I'm Gary. I'm from China. I learned web development courses on Coursera from supervised by Chuck. I think he's a very interesting person, and if you take his classes, you never get asleep. Yeah, encourage you to take that.
Don't go to sleep. So here we have our traveler from all the way Korea. Tell us your name.
Yeah, my name is Seyong. Just flew from South Korea in the morning today. I'm really delighted to be here, to be part of this event and be part of it. Yes.
I'm honored that you took that much time to come and see us, so thank you.
Hello all, my name is Hairi. I'm from Indonesia. My background is forestry, and I learned Python to help my study. Thank you, Chuck, for the class.
Thank you. Thank you.
Hello, my name is Yusuke Sakai. I'm from Japan. So
I love your name. Sakai is a great name.
Thank you very much. I'm very happy to learning Python and doing the Python coding, and very happy to see you.
Wow.
Thank you.
Thanks for coming.
Hi, I'm Liu. I'm from Japan, and good to see you.
Thank you. Shoji, do you want to be in the video?
Yeah.
Hi, this is my good friend Shoji.
Yeah, I'm just an observer for this office hour event.
And a faculty member at Kyoto University. and part of the MOOC effort at Kyoto University. So yeah, so Shoji and I have known each other for a very long time. Normally we're singing karaoke when Shoji travels to the States and we go to conferences together. So here we are at Kyoto. I don't exactly know where I'm going next, but I have a bit of a resolution for 2020, and that is I'm going to cancel a lot of my normal travel, and I'm going to try to go to places that I've never been before, because there's so many Python conferences around the world, and so I think I'm going to start going to more and more of the Python conferences off the path of the normal conference places that we go all around the world. So perhaps I'll soon be coming to a country close to you. So cheers, see you online.